small by first building a program that generates text given some user-defined rules. Then, as the second application, you'll build a program that creates web maps, and after that, you'll build a program that blocks access to certain websites in certain hours during the day in your computer. This program has been quite useful for me personally, as it doesn't let me browse distracting websites while I'm working, so that improves my productivity. And then as the fourth application, you are going to build a website with Python and the Flask framework. And not just that, but you will also learn how to deploy the website in a live server so that everyone can see your website through the website URL address. Then you will build a desktop program that interacts with a database and lets users store, delete, and view data through the program graphical user interface, which you are going to build with Python. Next, you'll create a program that starts the computer webcam and starts recording the video, and it detects movement live in the video frame that is being captured. And so the program also records motion data and produces a web graph with an overview of the motion that took place in front of the camera. And all this process is fully automatic. Next, you will create a web scraper, which is a program that extracts data from websites and stores those data in a well-structured format, such as CSV or Excel files. Then you'll create a web app which visualizes stock market data on a web page. This is very useful for people who work on data analysis and visualizations. And after that, you'll build a web app using Python and the Flask web framework. This web app will have a PostgreSQL database as well in the backend, and in the front end it will have an HTML form where users can submit data, and then the program sends an automatic email to the users with some statistics extracted from the backend database. So that's a very interesting web application with lots of features. And lastly, you will create a web application that lets users submit addresses of locations, and the program converts those addresses to geographic numeric coordinates and lets the user download the output through the web page. So that's about the 10 applications. All the content is yours and you have unlimited access. However, here is my advice now. Let's be honest, if all you do is watching the videos without trying the codes that I show in the videos, you won't be able to learn Python easily. You cannot learn how to drive a car by just watching someone else do it, right? So make sure you write and play around with the code I show in the videos, and don't just copy my code, but try to experiment, change some parts of the code, run the program again, and see how the output changes. Also, try to solve the assignments you are given, because there are a few assignments throughout the course, and also ask questions in the Q&A area, so in the question and answer area. Do internet research and be persistent on solving code issues which always arise while programming, no matter how good you are. If you do all that, you will have very good control of the Python programming language, and you'll be ready to apply for at least an entry-level job after you finish this course. That's about the course. Now, feel free to go to the next lecture, and I wish you good luck. Thanks. Great. Before we go ahead and learn about the Python basics such as variables, functions, and so on, I think it's good that you understand how a Python program looks like. This is especially good if you have never programmed before. Now, as in many other programming languages, you may have three kinds of programs. And I'll tell you why we have three kinds of programs. So you may have a program with a command line interface, such as this one here. You may have a program with a graphical user interface, such as this one here. So it's a desktop application. And you may also have web applications, such as this one in here, that runs on the browser, and it can be accessed through the internet. Now, the first thing you should know is that all these programs, they are based on a .py file, such as these ones in here. So this is a Python file, and whenever you start building something, you should write your code in this script, which looks like this one here. Anyway, and then once you have that script, you can either run it through the command line interface, such as this one, script 4.py, execute it, and then you communicate with the interface. So your program, your Python program, is asking you to enter some letters in there. So enter V, enter C for consonants, L or C, anyway, and you get some output in the command line interface. Now, when do you use such a program? Well, you'd use this program if you're not planning to distribute this program to normal users, to people who don't know programming. So, as you saw, I use Python, the Python program, which I have already installed, and I'll show you how to install that later. So I use Python and then point to the Python script, so to the Python program, to execute that program. Now, normal users, they don't have Python installed, or they don't know how to execute a Python program. And that's why you have graphical user interfaces there, such as this one, or browsers, such as this one in here. And yeah, when would you use a desktop application such as this? Well, you'd use that if you just want to distribute your program to a specific number of users. Let's say you work on a company and you want to build a program for the employees of the company to do specific tasks. And so you could build this program, and it's possible to create an executable file out of your Python program. This particular one is a .exe file for Windows. It runs on Windows as a standalone program, but you can also create .app files for Mac computers. And yeah, then the user, they don't need to have Python installed. They will simply execute that .exe file and they can use the application. So yeah, that's the application. We will be building all these three applications in the course. So the command line interface one, the web application, and the desktop-based application. And then you have web applications, such as this one here. So when would you use a web application? Well, web applications are best when your audience is large. So basically, you may want as many users to your application as possible. So for instance, what we have here is, this is a geocoder service. So it geocodes, it converts addresses to latitude and longitude coordinates. So what users can do here is they can choose a file, so a CSV file, and then you calculate latitude and longitude and send them back a CSV file with those values. So a web application, in simple words, can be for anyone. This also is based on .py files on the background, so I wouldn't show these files for now. We're going to build all these applications as I told you. So, and yeah, that's about this lecture. I hope you have a clear idea now on what a Python program looks like, and what you can do with Python as well. If you have questions, please feel free to ask them in the Q&A section, so in the discussion area of the course. And yeah, I'll be happy to help you. Hope you enjoy this, and I'll talk to you in the next lectures. Hello there, and welcome to this new lecture. In this lecture, I'll show you how to set up Python in your computer. Specifically, these instructions are for Windows users. So if you are a Mac or a Linux user, you can skip this lecture. You can go to the next lecture where I'll show you how to set up Python on a Mac, and the instructions also work for Linux users. So for Windows users, please follow if you haven't installed Python yet. We're going to download and install Python, and also try Python out. And so you go to python.org, that's the official Python website, and you go to downloads, and here you'll see the latest Python version. Currently this is 3.6.0. Just click that and save file. You also notice that there's also a version Python 2, so Python 2.7 to be exact. But Python 2 is not being supported anymore after 2020. So Python 2 is slowly retiring. So it's advisable to use Python 3. This one in here. Once you have downloaded the .exe file, just click it. Run. You can choose to install it in the default directory, but you can also do a customized installation if you want to change the directory. Anyway, make sure you have checked this option, add Python 3.6 to path. So I'm gonna go with the default installation process. And yeah, that was it. Setup was successful. You can close the window now, and we can go ahead and open Python. So how do we do that on Windows? Well, you can press the Windows key button. So we're talking about the Win key. By pressing it, you will be able to search on the Start button. Alternatively, you can simply go to the Start button, click it, and then type cmd. And then click on cmd.exe, and that will open the Windows command prompt. And so this is like the terminal on Mac or Linux. On Mac and Linux, it is referred to as the terminal. On Windows, it is referred to as the command prompt or the command line. To open Python, all you have to do is type in Python, and that will open an interactive session of Python. And an interactive session is best for testing out. So here you can write lines of code one by one, like that, and you promptly get the results in here. So this is why we call it interactive. But you cannot, it's not very appropriate to write multiple lines of code. So let's say you have a program that has 10 lines of code. And in that case, you'd want to write those lines in a file, in a Python file. But we will cover that later. This is the interactive shell. This is good for testing. So before you do a program, you are not sure about certain aspects, certain commands that you want to include, certain keywords that you want to include in your program. So you test things out in here very quickly. This is very efficient. And it's also good for learning. To exit the interactive shell, you'd press exit and brackets, open and closing brackets. Now, something you probably noted was that the Python that I opened was version 3.5.2. But why is that? Because I installed Python 3.6 in here. 3.6. So why did I get Python 3.5.2? Well, the answer is that I already had Python 3.5.2 installed on my Windows. So in other words, before I installed Python 3.6, I could trigger a Python shell like that. So the question is, how do I run Python 3.6 now? Well, the first thing you should know is that there is no problem having multiple Python installations in your system. The key here is that you have to assign different commands to each of your Python installations. So for instance, Python 3.5.2 has these commands to run Python. Now for Python 3.6, we need to assign another command. And I'll go and search for the installation directory of Python 3.6. So open that. And now Windows, when you search for Python, when you enter the Python command here, Windows is looking at the path variable, the Windows path variable, and it's searching for this type of command Python. But this was already occupied by another, so by Python 3.5.2. That's why it triggers Python 3.5.2. So in that case, you may want to do a trick here. Let's say do Python 36 and restart the command prompt. And then run again Python 36, and you get Python 36. So that's a trick. And again, of course, you can do operations here and so on. Of course, you still have Python 3.5. At least I have Python 3.5. Maybe you don't because you didn't have any Python installed just yet. So that's the idea. On your system, if you install Python for the first time, if you install Python 3.4.6, you'll be able to execute Python with this command, Python. If you had an existing Python installation and you install a new one, no problem, you can run Python 36 like I did. I hope this was clear, and I hope you are up and running now with Python, and I'll talk to you in the next lectures. Hi and welcome to this new lecture. In this lecture you're going to learn how to set up Python in a Mac computer. So if you are a Windows user, you can skip this lecture because you have a Windows computer, and we explained how to set up Python on Windows previously in the previous lectures, and the instructions will also work for Linux computers because a Mac is based on Unix. And so, let's begin. The first thing you need to know is that you already have Python on your Mac. So Python comes shipped with Mac by default. And let's go and open Python. I'm going to click here and then type terminal and then open the terminal app. So terminal is equivalent of a command line on Windows. And here now, let's go ahead and open Python. You can simply call Python, and if you see these 3 arrows there, that means you were able to start a Python session. So good news. However, if you look here, you'll see this is Python 2.7, so it's a bit outdated. And the current version of Python is Python 3. So it's recommended that you actually install Python 3 on your Mac or Linux instead of using the old version, Python 2.7. Because we're going to use a lot of libraries later on in the course, and some libraries may not be compatible for Python 2.7. You can still work with Python 2.7 if you take the responsibility to fix errors and compatibility issues that may arise as you learn Python. So it's going to be maybe some extra work. However, I advise you to install Python 3. So I'm going to exit Python 2, the Python 2 session, exit and 2 brackets, and you go again back to the terminal. To install Python 3, open a browser, and then you should go to python.org, then go to downloads, and then install the latest version of Python, which should be shown here. So Python 3.6 is the current version, and that should download Python. I can see this bar in here. And so please don't uninstall Python 2.7 if you are planning to install Python 3.6, because Python 2.7 is connected to your operating system. So if you uninstall it, you may harm your operating system. So you may get some messy errors there. So simply ignore Python 2.7. So leave it be, don't uninstall it, and simply click on this package that you have just downloaded. You should see the installation wizard. So simply go and click continue, continue, continue again, and read the license if you like. I'm going to go and click on agree, and then install. Provide your username there, your Mac username. Click on install software. And so finally, the installation was smooth and it was successful. Click on close. Yeah, I'm going to move it to trash. So the installation package. And now go ahead and go back to your terminal. So again, if you enter Python, you're going to get Python 2.7. So how do you get Python 3? Well, exit and simply click Python 3, just like that. Execute, and you'll see that this is Python 3.6. And yeah, good luck. So normally this is the command you'll be using on Mac, which means whenever I type Python on Windows, you're going to type Python 3 on Mac or Linux. As easy as that. So now you have Python installed, and here you can do operations. You get the idea. However, please note that what we're doing here, we're programming interactively. So we're simply writing some lines of code, but these lines will not be saved anywhere if we write them in this interactive session. So what we want to do is we want to write scripts of code. So Python files which we can save. We can save the code and we can execute all the lines at once. And we'll be doing that in the next lecture. So please follow me, and yep, I hope it worked for you, and I'll talk to you in the next lectures. Hi again, and in this video I'll show you how to create and how to run a Python program. In the previous lecture, we set up Python and we ran a Python interactive session. So that was like a running code line by line. But what we want to do instead, we want to write code that we are able to save it in a file, and we're able to run all the code at once. So that's what we're going to do in this lecture, and this is targeted to Windows users. So if you have a Windows computer, please watch this. If you have a Mac computer or even a Linux computer, please skip this video and go to the next video where I show you the same process but on a Mac computer. So Windows users, let's create a Python program. We're going to use very basic tools for now, but then in the next lecture we're going to download and use an advanced editor. On Windows, before creating the program, there's something you need to make sure of. You go to Organize and you go to Folder and Search Options. You go to View and then look here for this option, Hide Extensions for Known File Types. You want to make sure this option is unchecked, just as I have it here. Don't check it. Yeah. Cancel that. And with the option unchecked, you go ahead and right-click and create a text document. And put a name, let's say my program, and you want to remove the txt extension. I want to say .py. Okay, no problem. I want to change the name. Now, this is the file where you're going to write your Python code. So just go ahead and edit it with any editor that you have, maybe Notepad. We're going to use Atom later. For now, this is good. And this program, what this will do, it will print out some text. Let's say the hello text. So that's what you do. You use the Python print function, and then the function has this syntax. So it expects to have some brackets, opening and closing brackets, and inside these brackets you want to pass the thing that you want to print out. In this case, this is called a string. We'll cover strings later, or you can say text. So we want to print out some text, and text goes inside quotes always. So strings go inside quotes. Make sure you want to save, Ctrl S, exit the script, and then click outside in here and hold Shift and right click, and then you want to go to Open Command window here. That will open the command prompt. Look carefully and you'll see that the command prompt was open in this current directory, which is actually the directory of your Python file. So this one in here is in here. So before you run the program, you need to have these two directories the same. Because if you open the command prompt from here, as we did in the previous lecture, that will go to another default directory. So the best way to do is as I did it here. Shift right click and go to open command window here. And then what you do is you type Python and then the name of your program. My program.py. So what you're doing is you're using Python, the Python program, to execute this file. And you get the output in the command line, which is hello, the text hello. Similarly, I could execute it with my Python 3.6.py, and you get the same output again. So 3.6 and 3.7 doesn't make any big difference. The differences are very, very slight. So you don't have to worry about that. Let me execute it one more time, Python. And if you type now my and if you press the tab key, that will autocomplete the name of your file. So it will find the name of your file because it knows that you are in this current directory. So use tab for autocompletion. And yeah, again, you execute it and you get the output. Of course, you can go ahead and add other lines of code there. Let's say print 7, a number. Numbers don't go inside quotes. Ctrl S to save and close and go to the command line again. And press the upper arrow key to execute, to call a previously executed statement. So upper arrow key will call python myprogram.py, execute, and you get hello and 7. That's the idea. Hope you enjoy this, and I'll talk to you in the next lecture. Hey, welcome to this new lecture, and in this lecture I'm going to show you how to create and execute a Python program on a Mac computer. So if you are a Windows user, please skip this lecture. And so in the previous lecture I showed you how to install Python 3 and also how to launch a Python 3 interactive session. So which is good for executing and testing out code. So like that, line by line, but if you quit the terminal, you're going to lose that code. You want to find out a way to save that code in a file so that you can develop your program step by step. So you can go back to your code, add the code, modify it, and most importantly, you can execute multiple lines at once instead of executing line by line interactively. So let's go ahead and do that. Normally you need to figure out to create a directory where you want to save your program. So I'm going to create this folder in here, and this is empty for now, so I'm going to create a file there. There may be different ways of creating a Python file, but I prefer to do it via the terminal. So currently, if you do pwd, that will print out the current directory of the terminal. So the terminal is an app, and it is open in a current directory, in a certain directory, which is this one for the moment. If you do ls, you will see the directories and files of the current directory. So users admin has these directories, has these folders. So if you want to go to the desktop folder, you'd want to do desktop, or you can use the tab for auto-completion. So the tab key, and then on tab, that will take you to the untitled folder. Execute, and now you'll see that your current folder is the untitled folder. That means you can go ahead and create a file now. Let's say touch my program.py. So you can give it any name that you want. Execute, and that will create an empty file, which for now you can go ahead and edit it with text edit, for example. Later on we're going to install Atom Editor, which is much more advanced than this simple editor, but for now this should be enough to just get you started, to get you the idea on how to execute a Python program. So let's create the code for the program. This program will simply print out the hello text. So you use this print keyword, and then you use double quotes, and then the text hello, and then another double quote to close the text, and then a closing bracket. Ctrl S to save, exit text edit, and then go back to the terminal. And what you do here now to execute your program, the program that you just created, you use the Python 3 command, and then you can type myprogram.py, or you can use tab to autocomplete the name, enter to execute. and you get the output of the program printed out in the terminal. So in this case, the output is hello. And yeah, that's how you create an executable program on Mac. And similarly, you can go ahead and create other Python programs in here, just as we did with myprogram.py. I can also show you a quick way to actually open the terminal in this current directory without having to do cd and write the path name. So let's do that. You go here, System Preferences. So this is a one-time configuration. Go to Keyboard, Shortcuts, and then in the Shortcuts tab, you go to Services. Scroll down. And so you probably have this option unchecked. So you want to make sure you have checked the New Terminal at Folder option, just like I have it here. So make sure that is checked. Close this. And then what you do is to open the terminal in a current folder, in a specific folder, you right click on the folder and then go to New Terminal at Folder. And then what you do is Python 3 myprogram.py execute, and you get the output. So that's a quick way to open the terminal in a specific folder. And yeah, that's about this lecture. I hope everything went smoothly, and I'll talk to you later. Thanks. Hey, hello again. In this lecture, I'll show you how to download and install the Atom editor. Atom is a powerful and very efficient editor for writing and executing Python code. This lecture is specifically for Windows, so for Mac users, please go to the next lecture. So this far, what we did was we installed Python and we tried a Python interactive session in the command prompt, and we also created a Python program using a simple editor such as Notepad or whatever editor you had on your Windows. So now we're going to use another editor, which is Atom, and you need to go and install it from and download it from the Atom official webpage. Just click the button there, save file, and it will take a while until it downloads. Great, the download process has finished now, so I'm going to click on Atom, click on Run to run the installation. And yeah, you have to wait a while until Atom is installed. And yeah, the installation was quick, and now Atom has been open on my Windows. However, I would like to close it here and show you the standard way of how to open Atom. So the way that you'd normally open Atom when you start programming. So one way to open Atom is to browse through your programs and open Atom by clicking it. However, that will open Atom in a random directory, so the most efficient way to open Atom is to go to the directory where you have your programs. So the program that we have is myprogram.py, and then outside in here, right click and go to Open with Atom. But if you don't see Open with Atom, like I do, so I don't have Open with Atom for now, then go and open Atom from your programs, go to File, Settings, and then check these two options. So these options were under System, under the System tab of the Settings menu, and then close Atom, and then right click, and now you should see this menu in here. Open it, and you should now see this view. But if you don't see the tree view here, the directory tree view, go to View, and then toggle tree view. So you can toggle it off and on. You can close this, and then to open your program, so to edit your program, you simply double click your file, your Python file, and yeah, you start writing. Print, start adding more code. Always press Ctrl S to save. And now to execute this code, you can either go here and open your command window here with Shift right click, Or there is a more efficient way to do it. You need to go to File, Settings, Packages, Install. You want to install a new package and search for Platform IDE Terminal. Hit enter. And yeah, this is the package I want to install, so click install. So this is a package that will install or will integrate a terminal, a command line inside Atom. So you don't have to use the external Windows, the native Windows command line, and you can run your programs from within Atom. Alright, Platform IDE terminal was installed successfully. You can close the settings tab, and so now you should see this plus icon in here. Clicking the icon will open a new terminal. So now this is open in the current directory, which reflects the directory of your Atom directory, so of your programs. Now you can go ahead and type in commands here to run your Python program. So my tab for auto-completion, and that will auto-complete like that. Don't worry about this. This just means the current directory. So when you do tab will add this. Ignore it and press enter, and you'll see the program output on the terminal. You can clear the terminal from the code from previously executed commands, and of course you can call previously executed commands with the upper arrow key, execute again. And don't confuse executing a program with opening a Python interactive session. So here you write Python code like print 7, for example, interactively. But if you exit this, because I see some students who will go ahead and run Python code in here, but this is wrong. This is not Python, this is Windows, the Windows command line. So don't do that. Instead, write Python code inside an interactive session or inside a Python file. And that's the idea, and this is Atom. I hope you like it, and I'll talk to you later. Hello again, and this is yet another lecture for Mac users. And in this lecture, I'm going to show you how to set up the Atom editor on a Mac computer. So if you're a Windows user, please skip this lecture. Atom is quite an advanced editor, but if you have your favorite editor by now, you can go ahead and use that editor. So that's perfectly fine. If you choose to have a look at the Atom editor, then please follow this lecture. First of all, you're going to have to download Atom. Simply search for Atom editor, and then go to its website, which is atom.io. Download for Mac. And so while you wait for the download, this is how the Atom editor will look like. So like that. And so the download has finished on my end. And you can go ahead and click Atom. Click Open. And yeah, basically, Atom has been downloaded and has been installed. So you've got a welcome guide in here. You can close that. This is an empty file. I'm going to close it as well. And let me close Atom and try to show you how to actually open it from scratch. So how to start Atom from the beginning. And so let's see how to create a program and execute a program with Atom. And you want to launch Atom. And then go to View, Developer, Open in Dev Mode. And that will ask you for the directory that you want to open. So go to Desktop, Go to the folder where you have your programs, or the folder where you want to create your programs if you haven't created any program yet, and click open. And so you get this tree view in here, and close that, and double clicking a file will open the file here in the editor. And so you can go ahead and add more code there. 3 plus 4, and you can also create other files. So right click on the main directory, go to new file, my program 2.py, let's say print 5 this time, Ctrl S to save. And so you have 2 programs now in here, and you can switch through the different files by clicking the tabs in here. So how to execute these programs now? Well, you can use your Mac terminal just as you did in the previous lecture, or even better, you can go ahead and install a package. So go to Packages, Settings, View, Open. Go to Install, type Platform IDE, so -IDE -terminal. Enter to search, and then go ahead and install the Platform IDE terminal package. The installation should take a few moments. And yeah, finally, Platform IDE terminal has been installed successfully. So you can go ahead and close settings, and you'll see a plus icon in here. If you click that, an embedded terminal will open in Atom Editor. And you can drag it down and up to resize it. If you see closely, you'll notice that the terminal is open in the current folder. See, so untitled folder, this one in here. And that means you can go ahead and use Python now, Python 3, and execute a program, my tab program.py, and that will print hello. Actually, it was supposed to print hello and then 7, but maybe I didn't save the script. So click on the editor here, Ctrl S to save, and then click on the terminal again, press the upper arrow key to call a previously executed command, execute, and you get hello and 7. And yeah, this is how to use the Atom editor. This is good because you have both, you have the directory tree here with your files, with your Python files, and you have the editor here, and you also have an embedded terminal. So I hope you like Atom, and from now on I'll be using Windows, but things will be exactly the same because Python is cross-platform, so which means the code is exactly the same on Mac and Windows and Linux as well. So just follow me, and I hope you'll succeed with Python. I'll talk to you in the next lecture. Hello there, and welcome to this new section of the course. In the previous section, so throughout the lectures of the previous section, I covered how to set up Python on your computer and also the Atom editor, and also showed you how to create a Python program, which is this one in here that we created. So at this point, you should have an editor and you should know how to create a Python file and write some code in it, like this one in here. Now, in this new section, what I'll cover is variables and data types. So in the next lecture, you will be able to create and understand variables. And in the lectures after that, you're going to learn about the various data types that we use in Python. So in this video, I just wanted to introduce you to this new section, and let's go to the next video where I explain variables. See you. Hi, in this lecture, you're going to learn about variables. So what is a variable? Well, a variable is like a container where you can store various data types in Python. For instance, this program now, this doesn't have any variable in it for now. So let me try and execute it. And you'll see that this prints out the hello string. String is a data type, but we'll cover that later. Now, what is a variable? Well, the variables will keep your code more organized. Let me create a variable here. Greeting. So you can call your variables whatever you like. You can give them any name. However, there are some naming rules which I'll mention in just a bit. So let me create this variable for now. I'll store in this variable, I said variables are like containers, so I'll store this text in the variable greeting. And then what I do is, instead of doing print hello, I'll do print greeting. And save the script, Ctrl S, and then go to the command line, the upper arrow key, enter to execute, and you get the same output. So this is how you create a variable. You don't use any quotes, because when you use quotes, you are creating a string data type, not a variable. And you can also use a dash before the variable. That would also be fine. So you get the output correctly, but you cannot use numbers before the variable. So Ctrl S to save, execute, and you get an invalid syntax. So this syntax is not valid in Python. But you can use numbers after or between the variable name. Let's say here greeting 2. So that would be fine to use. So that's the condition about naming your variables. You can start them with a letter or an underscore. Now, if you're not experienced with programming, you may still be confused on why do we use these variables. Well, this is a very simple program, actually very useless, but normally your programs will interact with users. That is what we call a real program. You create a program to give it to people so they can interact with the program, they can generate all different outputs and so on. So let's go ahead and make this program more dynamic. So what I'll do here is I'll get the text from the user interactively. To do that, you need to use the input function. This is also a Python function. Inside the function, you can enter a message to the user. So let's say write a greeting, a colon, and make some space there, and then you print greeting 2. Yeah, save the script, execute, and now the program is asking us to enter some input. So let's go ahead and say hi this time, and we get the output printed out in here. Hi. So what happened here is we created a variable, and that variable will store the value that the user submits in the command line here in the terminal. So the user submitted the hi text, and this text will be stored in this variable. So as I said, variables are like containers. And then you can use this text in various ways. But in this scenario, I'm just passing it to the print function, so I want to print it out on the terminal here. And the print function will get the value that is stored in the greeting2 variable and will print it out on the terminal. That's it. And yeah, I'd like to close this lecture now, and I'll see you in the next lecture. Great! Now let's learn numbers. Let me open an interactive shell here to explain this faster. And so numbers, you know what numbers are. To create a number, you just type the number in Python, and that's it. And you also have operators, like this is the plus operator. And you can also store numbers in variables. Let's say a equals to 2, b equals to 3, and then if you do a plus b, you get 5. Something to note is that, if you do that in here, a equals to 2, b equals to 3, and then if you just do a plus b, and then you execute the script. Let me open another terminal. You will not get any output in there. The reason is that you are not printing out anything in your program. So this is different from an interactive session. Here, if you simply do an operation, or if you simply call a variable like that, you get the output promptly. So this is just for simplicity when you're trying things out, so you don't have to pass print explicitly, but Python will understand that you meant print. But here things are more strict, so if you want to print out the output, you want to say print a plus b, and then execute, and you get the output. And yeah, basically that's the only difference between executing a program from a Python file and running the code in the interactive shell. So these are numbers, and I can prove that if I do type 2, for instance, you'll see that this is an int type, which means is an integer. So basically we have integers and we have floats. These are the two main types of numbers. A float is, let's say 2.4, it's a float, and I can prove that. 2.4, type 2.4, you'll see that this is a float. However, if you do type 2 in brackets, you'll see that this is a string, it's not a number, and therefore you cannot make operations using a string and a number. So Python will give you a type error, and this is saying cannot convert integer to string implicitly. So when you do a string plus something else, Python expects that you were adding another string after a plus sign, so that's why it says I cannot convert integer object, so it cannot convert this to a string implicitly. Because if you were to do 2 plus 3, you'd get 23, because Python treats these two as text. So to understand it better, let's add some text here, b, so you get 2a, 3b. So it's a concatenation operation. When the plus operator is used with strings, it is referred to as concatenation. Now let's go back to our sample program that we used earlier, which was this one in here. So now what if instead of getting a greeting from the user, you ask them for their age? Enter your age. So this is just a message, you can write anything you want there, but just try to have a message that makes some sense to the user. And so also I'm going to change the variable name to something more meaningful, age, and then what I want to do is, let's say new age, I want to calculate their age plus 50. Why not? And then print out the new age. Save the script, and let's go and execute this. We are going to get an error here, I warn you, but it's good that you see the errors that we get, because that's how you learn better. And so Python, my program, executes. For now it's working fine, because what happens is Python executes a script line by line. So it goes to the first line, and if there is no error, it executes that line. And in this case, we have an input function. So the program is on standby mode, so it expects from the user to enter the input. And so let's enter the input here, let's say 28. And here's the error that we get. So again, you saw this error before. This is saying type error cannot convert int object to string implicitly. And you also have the line here that the error occurred. So these are important messages. And line 2 in here. So what's happening is that age is a string, it's not a number. Therefore, Python cannot add up a string with a number. And so why is age a string? Because that's what the input function produces. So the input function gets the user input and converts it to a string. So even if you pass a number there, this will always convert everything to a string. Therefore, Python, cannot concatenate 28 plus 50. So what can you do in that case? Well, you want to convert that string into an integer. And for that, you want to use the int function. So it's a Python function that does the work. As you can see, it outputs now the correct output. So 28 plus 50 equals to 78. And similarly, you can convert numbers to strings. Let's say str50, and I think we'll get an error here. Yep, it says type error, unsupported operand type for plus. So you're adding up an integer with a string. So integer with a string. If you like to convert this to a float, let me remove that. Save, execute, 28, you get 78.0. Because what Python does when you use float is, float 28, it converts it to 28.0. So floats can be useful in certain scenario, and you'll have a lot of scenario in the course. So don't worry about that now, because we have real-world applications later on where you see the real benefit of everything that we are explaining here in these early sections that cover the basics. So this is about numbers. Try to practice them a little bit, and I'll talk to you in the next lecture. Hi again, in this lecture I'll show you how to do math operations with numbers. So we're going to look at math operators. Let's go straight away and open a Python session, and let me write a math expression there. 20 minus 10 divided by 5 times 3 in the power of 2. And what we get is 2.0. So why did I write this long expression? Well, because I want to explain to you the order of operators. So when you have multiple operators in an expression, the one to be executed first is the exponent. So we have 3 in power of 2 here, and that will give us 9. So power is the first to be executed, and after that is division and multiplication. Actually, division and multiplication are on the same level when talking about order, but the one that is first will be executed first. So in this case, division is the first one, so what will happen here is Python will ignore minus for now, so it will divide 10 by 5, and it will give 2, and then it will do 2 times 9. So again, 10 divided by 5, 2 times 9, 19. And then we have the rest of the operators, which could be a plus or minus. So in this case, we have minus, and so 20 minus 18, we have 2.0. And so you'd ask why we have 2.0, because 10 divided by 5 gives 2.0. So division outputs a float in Python 3. If you are on Python 2, it would output an integer. Now, to make your expressions look better, you'd want to remove the spaces for the power operator, and also you do like that. So now you can read it better. So 2 times 9, and then 20 minus 18, and so on. You get the idea. You get 2.0 again. And now if you want to execute the minus operator first, you'd want to put that inside brackets. So why did we get 18? Well, because 20 minus 10 gives 10, And then 10 divided by 5 gives 2, and then 2 times 9 gives 18. That's the idea. And then you could also do this, put these in brackets, and what would happen here is, 10 here, 15 here, in the power of 2. So 15 in the power of 2, and then 10. So 10 divided by 15 in the power of 2. Let's see what we get. Yeah, we got that. So let's see if I was right. 15 in the power of 2, we get 225. And then we got 10 on the other side. So 10 divided by 225. We get that number. So whenever you want to change the order of operators, you should use brackets. So yeah, I hope you get the idea, and please try this out. So try to do a few operations with numbers to get used to it. And yeah, I'll talk to you later. Thanks. Hi, welcome again. In the previous lecture, we were talking about numbers. Specifically, we looked at integers and float data types. So these are referred to as data types in Python. So integers and floats. In this lecture, we're going to look at strings. I already mentioned strings in the previous lecture. So a string is everything that goes inside quotes. Hi there, that is a string. And of course, strings can be stored in variables. And you can print those variables. So we're using the interactive shell now, but of course you can use a Python script as we did previously. So numbers were used to do math operations, but strings are used for displaying information for the user. So let's say you have a web application and you want to generate some text dynamically on the web page. So you would use Python on the backend, and Python would send strings to the HTML code. And HTML would render the code on the web page. Basically, that's the idea. Or if you want to create a notepad, an editor with Python, such as Atom, let's say, all these things you see here, so my program.py, selection, find, all these would be written as strings inside Python. And then you display them on the interface using various functions. For instance, if you want to display a string on the terminal, you'd use the print function. Now, strings have methods associated with them. What I mean with methods is, let me go ahead and try out a method. For methods, you need to use a dot notation. So you refer to the string, which is string C in our case, actually variable C, but the variable is holding the strings, so it's the same as doing here dot. So let's do C dot, replace, and what I want to replace is E with I. So I'm replacing for string here, I'm replacing letter E with letter I. And what that will do, it will replace all the letters, all the occurrences of this letter in the string. So you'd ask, where can we see these methods? Well, that's very easy actually. You can do dir and then pass a string there, any string. It could be C, it could be an empty string or whatever. And that will print out all the available methods that you can use with strings. So let's say C.upper, that will convert the string to uppercase letters. Now, if you want to know what these methods are about, you could ask for help. Just do help, and then C, so the string, or just empty string dot replace, just like that. And here you get the help. And so you get the definition here, replace method of the string instance. So string is like the blueprint that creates strings objects. Or you can say the data type that represents text. Look here is the syntax. So what you do is you use the string like we did. So let's say here, replace, then you open brackets. Here is the old item you want to remove from the string, and then the new item, we want to replace it with I. And then what you see here in square brackets, that means this parameter is optional. So you can either pass it or not. In the previous case, we didn't pass it, so what Python did was it replaced all the occurrences of the E item. But if you want to replace only the first occurrence, you do one there, and that will replace only the first E with I. That's how it works. So strings, they support functions. So print is a function here, and they support methods like this one here, and they also support operators. So you can do here plus there, and you get here there. Or you can make it more readable like that. So an empty space is also a string. And yeah, that's about strings for now, and I'll talk to you later. Hi again. In the previous lecture we talked about strings, and in this lecture again we are going deeper into learning strings. Specifically, we're going to look at indexing. Indexing is a very important concept, not only with strings, but with other data types that we'll be looking at later, such as lists and tuples and dictionaries. So please follow this lecture. And yeah, let's talk about indexing. Let me open a Python interactive session. And let me create a string. Hi there, exclamation mark, and close quote. Now, when you create a string, every string that you create, Python under the hood, what it does is it assigns a number to each of the items of your string. So it starts from 0. So age will be assigned an index of 0, and then a 1 for I, 2 for the Y space, 3 for T, 4, 5, 6, 7, 8. So the exclamation mark character will have an index of 8. So you would ask, why is this useful? Well, this allows you to extract certain parts from a string. And there is a certain notation to do that. You'd want to access the string, so in this case that's the variable C holding the string. And then you want to use square brackets. So an opening square bracket and then a closing square bracket. And inside those square brackets you pass the index of the item that you want to extract. Let's say I want the T character. So that would be 0, 1, 2, 3. I pass number 3 there as an index, and that will extract for me letter T, which is actually a string. So you can check the type of the output, and you'll see that that's a string. So a string is made of strings, you can say so. If you wanted age, you'd pass 0, and if you wanted the last character, well, you might have to count, so 1, 2, 3, 4, 5, 6, 7, 8, and so, sorry, I'm including type there, sorry about that. So C8 would give you the exclamation mark. But there's also another indexing system there that Python uses. So in this case, we had to count from the beginning to the end of the string. But wouldn't it be useful if you had another system that lets you count from the end, so from right to left? Well, such a system exists, and it starts from -1. So the exclamation mark would be -1. And yeah, that you can extract that with that. -2 would be E, R would be -3, and so on up to age. So you have two indexing systems there. which allow you to extract items depending on whether the items are in the beginning or near the end. Now, what if you want to extract more than one item from a string? Let's say you want to extract high. Well, there is a notation for that too. And so high is expanding from index 0 to index 1. So up to here. So let's try 0 to 1. That will not work very good, but let's see. So as I said, this will return only age. So it doesn't return item with index 1. And that's because splitting in Python, so we're splitting a string here. Splitting in Python is upper bound exclusive, which means that the upper bound of the split here is not included in the output. So if you want to include I, you'd want to pass the index after I, which is 2. So this is a string just for reference. And so we extracted item with index 0 and item with index 1, and then the split starts right there at index 2. So it doesn't include the space, just high. If you pass 3 there, that would include the white space as well. And similarly, you can pass like 1, and that will include I and the space. There are also shortcuts. So if you pass 0 to, like nothing to 3, that is the same as doing 0 to 3. So it will include 0, 1, and 2. And similarly, if you want to extract there with the exclamation mark, well, what you'd want to do is T would have an index of 0, 1, 2, 3, so 3, and then you can just pass a column there and execute it. And that will give you there with the exclamation mark. And let's now try to extract R and E using negative indexing. So something to know is that even though we are using negative indexing, which starts from right to left, the splitting will work from left to right, which means the first index you want to pass is that of the first item. So R, we pass -3 for R, because you know we have -1, -2, and -3. So -3 for R, and then we want E, which is -2, but since splitting is upper bound exclusive, we want to pass -1 there. So let's try that, -1. Execute, and yeah, we get the correct output. That's the idea. If you didn't pass anything here, you'd get the exclamation mark as well. So it will take a while until you get used to this, but with some practice you'll be able to remember these notations. And yeah, that's what I wanted to cover in this lecture. So this was about string indexing and splitting. So you split using the index that Python uses on the background. And yeah, I hope you enjoy this, and I'll talk to you later. Thanks. Great, now let's look at lists. So in the previous lecture we were looking at strings and indexing and splitting strings, and now we'll be working with lists, which are very similar to strings. They are similar because they are both referred to as sequences. So they are sequences of items. The difference is that, let me open Python. So the difference is that a string is made of other strings. So it can contain only strings, so characters or strings, whatever you like to call it. However, lists can contain various other data types. Let's say age, a letter, a number, and also a string. So this is a string, the first one. This is a number, an integer. This is also a string with multiple characters. And that is a list. So for lists, you want to use square brackets to create a list. Execute, And yeah, you can call it. And so this is a list of 3 items. And you can also store other objects in a list, but we'll cover other objects in later sections. We have table objects with lots of data. You may store files in a list. You may store widgets of a graphical user interface that you are building, and so on. So lists are very useful. And lists also have indexing, and you can split lists, you can extract items, and so on. So the good news is that lists have the same indexing system as strings. So you learned that in the previous lecture, and you can go ahead and apply that system now. So let's extract number 2. That would have an index of 1. Execute that, and yeah, you get 2 there. If you check the type, you'll see that's an integer. So every item of a list has its own data type. You can also access more than one item of a list. Let's say you want the first 2 items. You do 0, 1, 2. So like that, or 0 to 2, whatever you like. And that will produce another list. So the type of this split is a list. The type of the split of a string is a string. So S for the string here, C for the list. Lists now have methods associated with them, just like strings do, and so you can check what methods you have available there by just doing dir list. So list is the blueprint. You can use list, you can pass empty square brackets in there. It's the same thing. And then you can use help to look at each of these methods. So these are the methods without the underscore. And let's look at the append method. So to apply a method, you do C, the dot notation, append, and here I'll add 3. Well, what that does is it adds another item to the end of the list. So it appends an item to the list. And you can explore the other methods if you like. So let's say help, remove, like that. And you'll see how to use that remove method. So you do C remove, and then you pass the value of the item that you want to remove. So not the index, but the value. Let's say we want to remove 2. And you see that 2 is now gone from the list. So yeah, look at the other methods of the list and try to experiment with lists and play around with them, access items and split them, and you'll be good to go then. Yeah, thanks. I'll talk to you later. Let's now look at tuples. In the previous lecture, we looked at lists, and tuples are very similar to lists. The only difference is that tuples are not mutable, so you cannot change a tuple. Lists are used much more than tuples, so tuples are only used in very specific scenario. We will see some scenarios throughout the course when we build the real-world applications. So you don't have to worry about understanding when to use a tuple in programming for now. Anyway, I want to show you the syntax. So you can create a tuple like that. So a tuple, just like lists, they may contain different data types. Let's say 3, 4, and so on. Oh, sorry, I was writing in the terminal. Let me open the Python shell. So again, you have strings, numbers, and floats, if you like. Whatever type that you want, you can pass in a tuple and in a list. And of course, you can use indexing for tuples as well. So let's access the last item, and that will give 4.6. The difference is that, tuples, they have some slight different methods than lists. So if you do dir list, you'll see that lists have much more methods available than tuples. So for instance, you can append items to a list, you can clear the list, and copy and Count is available for tuples because count doesn't change the data type, so it doesn't change the tuple, it just counts how many items are there in a tuple. As I said, tuples are immutable, so you cannot change them. That's why these methods that change the data type, like inserting new values and popping out values, removing values, reversing and sorting, so these are not available. And yeah, this is more or less about tuples. In case you need them later, they are there for you. Hope you enjoy the course, and I'll talk to you later. Hey, hello! Let's look at dictionaries in this lecture. This far, we looked at strings, we looked at lists and tuples. And so now we have yet another data type, and these are dictionaries. Let me open the Python shell, and let me create a list first. I'm just creating this for a reference, so to compare lists with dictionaries, but you don't need to create a list for creating a dictionary. So to create a dictionary, you need curly brackets. So an open and a closing curly bracket. And then inside that, you'd pass the items of the dictionary. Now the difference here with dictionaries is that instead of letting Python add default indexes for your items, you want to create those indexes yourself, explicitly. So therefore, for dictionaries, you do something like this. Name, a colon, and then the item. Let me write another one. Surname, colon, and then the other item. And yeah, that's it. That's a dictionary. So what we have here is, when I was talking about indexing, I was referring to these things. Actually, these two are referred to as keys, not indexes. So for dictionaries, you can create custom indexes, so to say. And so these are keys. So we have key and value. Key and value. This is good because now if you want to access one of the values of the dictionary, again, you'd use square brackets, just as you did with strings, lists, and tuples. And then there you pass the key, which value you want to extract. So if you want to extract John, you want to pass the key of John. And that will extract John value. Something to note is that dictionaries are an ordered collection of items. So sometimes you may notice that the order of the key and values is not maintained. So you may see that surname has gone the first place. So surname Smith, the pair has gone the first one, and name John is the second one, and so on. So this is different from lists and strings and tuples. And the reason Python doesn't keep the order is that, you know, the way you access dictionaries is you explicitly pass the key of the dictionary when you access it, and so you don't need to know the order of the dictionary. Whenever you want to access something, you say surname, for instance, and that will return Smith, no matter where Smith is, so whether it is the first one, second, or and so on. And interestingly, in dictionaries you can also pass you can have like lists as values or even tuples. So let me write a tuple there, or let me keep it like that, and let me add another key and pair here. Now let's say cities. Let's say John Smith lived in 3 cities: Porto and San Diego and Bali. You close a bracket there. So as you see, we have the key here, we have the colon, and then you have the value, which can be anything. So it can be a string, it can be a number, it can be a list, a tuple. In this case, that's a tuple. So if you access now cities like that, you'd get, sorry, I had 2 brackets there. So you would get the tuple. And then you can also do tricks like, you know, if you want to access Bali, you'd add other brackets there and pass 2. and that will return body. So why is that? That's because, up to here you have a tuple. That's a tuple object, and then from that tuple you use again the square brackets notation to access an item from that tuple. So you want item with index 2, and that is body. And yeah, that's about dictionaries. Try them out some more, play around, and you will be able to comfortably create and access items from a dictionary. So hope you enjoy this, and talk to you later. Hey, welcome to this new lecture. This is the most important lecture you have had so far in this course. So please try to make the most of it. And this is actually a new video that I'm adding to the course. I didn't have this lecture a few times ago, so I added this quite a while after I published the course. And until now, I had explained this concept, so the errors, little by little in other lectures, but I felt that was not enough. And I was seeing that students were still having difficulties in understanding and dealing with errors in Python. So I decided to make a dedicated lecture for errors in Python. So here we are. And I said this is the most important lecture because, we learn about functions and strings and numbers until now in the previous videos. And these are individual concepts that, you'll learn now or later, you'll learn functions and strings and etc. But if you don't know how to read an error, how to understand an error and deal with it, if you don't know that, you'll have troubles dealing with everything, every other object like functions and strings and numbers, etc. So understanding an error and knowing how to deal with it, how to fix it is very important. And even the most experienced programmers, they make errors in their programs. The difference is that they know how to read these errors, how to understand them and fix them. But everyone makes errors. So if an error shows in your program, don't panic. Just follow the instructions that I'll give you in this video on how to fix the error. So that's what this lecture is about. So what is an error anyway? An error in a program is a bug that causes the program to function incorrectly. Now, in Python, we have basically two types of errors. We have syntax errors and we have exceptions. Let's first focus on syntax errors and let's forget about exceptions. We'll go to exceptions after we explain syntax errors. I have this code here, and actually, this is a Python file. This is the icon showing on a Mac. So currently I am on a Mac computer. But that doesn't make the slightest difference. No matter where you are, Linux, Windows or Mac, everything is the same. And so, I have a terminal here, and let me go ahead and execute this program. This has a few errors, so let me show them. On Mac you can call Python 3 with the Python 3 command. On Windows you can just call Python or whatever command you are using. You can also use any editor that you like. And so, errors.py is the name I gave to the script. Execute. So, this is now an example of a syntax error. And this is the entire body of the error message. And this is very important. So, whenever you get an error, the first advice I give you is don't panic. Just focus on the error, read it line by line, just like you're reading a poem or whatever. So, the first line of the error points you to the name of the file that has the error. In this case, is errors.py. Then you have a comma, and after the comma you have the line where the error occurred. So it's line 3, and you can see here that line 3 is this one here. But you also have, for your convenience, Python prints out the line in the terminal. So int 9, here is where the error is. And just after that you have the type of the error. So it's a syntax error. You also have other types of errors such as name error, type error, but those are exceptions, and I'll explain later why we call them exceptions. So this is one type of error, a syntax error, and the others are exceptions. So this is a type, and then you have a description after the colon. Sometimes the description is more specific, more detailed. This time is just invalid syntax. So you have to figure out where you did some error, where you missed some syntax of your program. And you also have this arrow here pointing upwards. The arrow points you either at the token that the error is occurring, or at the end of the token. So a token is, this is the token in this case 9. So it can be a number, it can be a string, anything. So at this point, this is pointing at the token. But it could also be like that. 999. Save the script. Execute. In this case, you see that it's pointing you at the end of a token. So around here you have an error now. And I know that int is actually a function. And functions in Python, they need to have brackets. So you need to pass 999 inside brackets, like that. And delete that. Save. And execute again. Alright. You've got another error, but don't panic again. This is my advice always. Instead of read the error, it says file errors.py, the file, line 5. Oh, line 5 this time. So it's not line 3 anymore, which means that line 3 was fixed. So what Python is doing is it's going through all the lines one by one from top to bottom. It checks the first line, it says, oh, it's fine. No error there, goes to the next line, no error. Goes to the third line, no error this time. Fourth line is also fine. And fifth line has an error. So again, it's a syntax error. And this one is more specifically described. So missing parentheses in call to print. Note that you'll get this error only if you are on Python 3. If you are on Python 2, this won't be an error because in Python 2, print was a statement and was not a function. So with statements like return or print in Python 2, you didn't have to pass brackets. This syntax would be correct. So again, this arrow here is pointing you at the token. So we just add brackets there. Ctrl S to save the script and execute again. This time we don't get any error, so the script executed fine and printed out the output here. 1, 2, 3. So we had 3 print functions printing out output. This doesn't return any output because we're not printing anything. So this just gets the function input and produces some output, but that doesn't print anything. If you want to print it, you want to pass the print statement function there. There could also be other types of syntax errors, such as you want to define a list 1, 2, and 3, but instead of closing it with a square bracket, you use a round bracket instead, like that. Save the script and execute. And you see that you got a syntax error, invalid syntax, at line 5, which is this one in here. Again, the arrow points you at the token, so you need to figure out how to fix this round bracket here. And you know that you need to close it with a square bracket, so that should fix the issue. So that's about syntax errors. They are very easy to fix. In the next lecture, I'll explain exceptions. So see you there. Hi again and welcome to this new lecture. In the previous lecture, we talked about errors in general, and I focused on syntax errors, which is one of the 2 types of errors you have in Python. So you have syntax errors and you have exceptions. Now we're going to talk about exceptions in Python. So every other type of error that is not a syntax error is an exception. And often all errors, syntax errors and exceptions, they are referred to as errors. So you're going to hear this all over the place. Now I have a new script here that I created for this lecture. Try to guess what I'm going to get as output when I execute this script. So I have a equals to 1, b equals to character 2, print int 2.5 and print a plus b. So guess what I'm going to get for a moment. Okay, now let me run the script Python 3 errors.py. File errors.py, line 4, which is the last line. This one, we get a syntax error, invalid syntax. Now this can be very confusing for you now because you're looking at the print a plus b expression, but you don't see any error there. So for a beginner this can be quite frustrating, but try to look back on the left of the arrow here. So think of the arrow, that the arrow is pointing at the token and the token has not been written correctly in the script. So in this case, the problem here is that this line here, it has an open bracket, a round bracket, and then it has the int function, and then the int function has its own brackets that is wrapping inside its input. So these are the brackets of the int function, but the print function doesn't have a closing bracket. What I did is that instead of putting a bracket there, I actually wrote another print function. So Python was expecting a closing round bracket, but I typed in a print function. That's why this is saying that this print function is not in the correct position. That's the idea. So always when you see this arrow, first look at this line, but then look before that also. Sorry about this. So always when you see this arrow here, first look at this line here, but also don't forget that the problem might also be before this line. Okay, so that was about the syntax error. I'll explain why I talked about this syntax error here. Let me execute this again. So the syntax error was fixed now, but we still have another error. So the reason I included a syntax error in my code was to show you that Python actually first checks for syntax errors. So basically it parses the code, it looks for syntax errors, it doesn't execute the code yet. So when I executed Python 3 errors.py in here, the code was not executed, but the interpreter just checks for syntax errors. It doesn't check for exceptions just yet. So first you need to fix the syntax errors, and that's what we did here. We added this bracket and we fixed the syntax errors. Now Python is throwing out an exception. And here is where I executed the code. And see the next line, we have number 2 there, which is coming from the output of this line here. So from line 3, we got the output correctly. So basically, again, Python executes the script from top to bottom if it doesn't find syntax errors. If it finds syntax errors, it doesn't execute anything. So 2 is printed out, and then you get this trace back of the error, which starts there and ends in here. That's the block of the error. Sometimes the errors may have more than one type of error. So in this case, we have only one type of error, which is a type error. But you may have multiple blocks here. However, the most important error that you must focus on is the last line of the error. So the last block of the error. In this case, we have only one block, so we're focused on in that. And line 4, which is this one in here. This is the line. Again, the line is printing out just like in the case of syntax error. And here you have a type of the error here, which is a type error. So what's a type error? A type error means that there is something wrong with one of your object types in your script. And you have the description here, unsupported operand type for plus. So this is trying to say that the plus operator has an unsupported type. So the plus operator, in other words, doesn't support one of the types that you have given to it. So it either the type of variable A or the type of variable B. So it says int and string. So it doesn't specifically say that whether int or string is the object, but it says that you cannot use a plus operator with an integer and a string. And that's logically wrong, because you cannot add a number to some text. That's what Python doesn't understand, and it throws a type error. So exceptions are like logical errors, and you need to use your logic now to fix the error. And you use your logic by carefully inspecting the error, and that's what we did. So what we want to do, we want to fix this. Now it's up to me whether I meant to concatenate these two objects or do a mathematical addition operation. So let's say if I was intending to do an addition between these two numbers, then I would have to convert b to float or an integer. Save that, execute, and yeah, in this case you don't get any error. You get 2 printed out from the third line, and 3.0 from the last line that we have just fixed. However, if my intention was to actually print out the concatenation between these two strings, instead of converting b to a float, I would have to convert a to a string. In this case, I would get the text 1 and 2. 1 and 2. So that would be a string object, not a number. Even though here it shows as a number, it's just how the terminal prints it out. So again, these are errors that occur in runtime, so when the script executes. Syntax errors are parsing errors, so the interpreter tries to understand whether the script is syntactically correct, whether you have followed the Python syntax rules. So you need a bracket, a closing bracket for opening bracket, you need a closing quote after the opening quote, and so on. Now, there are also other types of exceptions, not only type error. You may have a name error. Let's say here, instead of printing out that, we print out C. Save, execute. And here is a traceback. Again, 2 was printed out from the third line. The traceback says line 4 at print C. Name error, name C is not defined. So again, this is not a syntax error because you haven't made any mistakes with the syntax. You have this variable name, which is correct. You have brackets opening around brackets and closing around bracket. So everything is syntactically correct, but this C object, Python doesn't know this. You haven't defined this C variable, so Python doesn't know what to print out. Python is able to print out A because it knows that A refers to the 1, to integer 1, and so it prints out integer 1, but C doesn't have anything, so you get this name error. And whenever you get a name error, you know that this name here has not been defined by you. So to fix this, you may want to define C like that and execute, and you don't get any error. You may also have other types of errors, such as C divided by 0. See what you get. A zero division error, division by 0. That's the description of this error. So division by 0 is not mathematically possible or meaningful. And since Python is based on mathematics, then it throws an error. And you need to fix that. You need to remove that expression that divides by 0. And yeah, that's about errors in Python. I hope you understood a great deal of this lecture and the previous lecture as well. So it's relatively easy to fix errors. However, sometimes there are errors that you might have difficulties understanding and fixing them. So later, for example, we're going to work on libraries, and sometimes libraries, they have different kinds of errors. However, nothing to worry about, because there are other things that you can do for an error that you don't understand. And I'll talk about that in the next lecture. So I'll see you there. See you. Great, welcome again to this new video. This is the third video about errors. So we talked about syntax errors, we talked about exceptions, and now we're going to talk about how to fix an error when you don't understand the message. So let's focus on this error. A zero division error. In case you were good in mathematics, you could easily fix this error. So you'll be able to understand that you cannot divide C by you cannot divide a number by 0. So you'd fix this by removing this expression here. However, if you are not that good in mathematics, you may find this difficult to understand. In that case, the fastest way to fix this error is by copying this line here, Ctrl C. So select it, copy it with Ctrl C or right click and copy there, and then go to Google. Just paste it. Now, on Google, this got around 100,000 results. So Python is very popular, and you'll get a solution for almost every problem that you'll get with Python. So before looking at documentation or asking a question somewhere, it's very likely that someone else has had your issue before, and they have asked a question about that, and there is a solution about that as well. And a very, very good question and answer website is stackoverflow.com. And almost always when you search for an error on Google, the first results will be from Stack Overflow. Someone has asked a question with this title. It says, I faced an error when I ran a program using Python. So it's the same exact error as you, like that. How to avoid that error. And it also talks about the desired output. And there are two answers for this question. The answer with this green mark here is the accepted answer, and it has the most upvotes. So 11, and this has 2 downvotes. So -2. Actually, the difference between upvotes and downvotes is in the favor of downvotes. So these are 2 different answers that you can look at. Usually you want to look at the accepted answer that has the solution. However, in this case, this also has the explanation. It says you cannot divide by 0. This causes Python to raise an error. That's still a good answer, and I think it didn't deserve to have this balance of votes. But this one gives a solution on how to handle an error, and that takes us to another concept, which is handling errors in Python. So let's say you have a program, you have a function that gets 2 input values, and then it divides those 2 input values. However, sometimes the user may pass 0 as a second input. And in that case, if you divide, let's say the first value would be 2 and the second value would be 0, your program would crash. And if you want, you can use exception handling to actually avoid that program from crashing. And you can do that with a try and except statement. Anyway, we'll cover that in the next lectures in this section. So this was about searching for an error on Google, and you can easily find the solution to that. As you see, these are very clear questions. It's a big community, and everyone can vote up and down and can comment. So basically, the answers are very accurate. However, you'll not always find an answer on Google. In that case, it's time to ask your own question. So the first thing is, again, you check if you understand the error and fix it if you understand it. The second thing is you do a search on Google, and if the first 2 fail to solve your problem, then it's time to ask a question. And you can ask a question either inside the course. So you can, while watching a video, you can browse Q&A, which stands for question and answer, and you can do a quick search if you find an existing answer to your question here. And if you cannot find it, then you can ask a question, or you can ask a question on Stack Overflow. You can use this button here, ask a question, And I'll be happy to help you here on the course interface Q&A section, or other people can also help you on Stack Overflow. However, something is very important to know. The structure of your question is very important on getting a good answer. You know, sometimes there are very bad questions, like, let's say, my code is not working, how do I fix this? And that's all. With that very little information, it's very hard to get a good answer. So it's very important to ask a good question, and I'll show you how to ask a good programming question in the next lecture. So that's a very important lecture as well. See you there. Hey, hi again, and welcome to yet another lecture. In this lecture, I'll show you how to ask a good programming question. As I mentioned in the previous lecture, asking a good programming question is very important to get a good answer. And let me first show you what's a bad programming question. For instance, I'm going to click on Ask Question, and here is the title of the question. A bad programming question would have a very generic title like that. And here is the body of the question where you have to describe your question in detail. Some people, they just say, I got an error when trying to numbers. And I just pause the question. A better question would be to include the error, the code there that you executed, like that. However, that is also not enough, because you also need to show the error message. So let me delete this, and a good programming question would be, when we're talking about questions that have an error, questions that talk about an error that you got in your code. So this is your code. A good title would be to include the error message. So that one would be a good fit. If it's a very long message, then you can also choose to include only the name of the error without that. And then a good question would be, hi, I run the following code and expected to get division in the last print main, but I got an error. Here is my code. So you put the code there of your entire script. Don't worry, if your question is long, it's better to be long than to be incomplete. And here is the error. And here, make sure to include your entire error traceback, including the output as well. So from this line of the command line up to the next line. So this entire thing goes to your question. Just copy it. Don't worry if it's long. Can you help? So that would be a good programming question. Now this is still missing something very important, and that is the highlighting of the code. You need to select the code and click on this icon here. The error as well. And let me pose the question. External links must provide free educational content. Just click on proceed. And here is the question, and here is how it looks like on the other end. So this question has 4 good elements that make it a good question. The first element is that the poster is mentioning what he or she expected to get as output from the script that they were running. So it says that I was expecting to get the division in the last print statement, which is this one here, but I got an error. So the first thing is you need to include the expected output. You need to explain what you were expecting, because otherwise, if you don't explain what you were expecting, that the other person who wants to help you doesn't know the goal of your code or of your question, so it doesn't know how to help you to reach to that goal. So expected output is the first thing. Second thing is you need to include your entire code. And make sure that you include your code as text. it's better to use text as rather than screenshots, because text, the person who wants to help you can copy your code and run it on their Python interpreter. But if you include screenshots, they are images, and it's hard for other people to try out your code. If you ask this on Stack Overflow, your question would get closed, because if you ask it, oh, we're using a screenshot rather than the text version of your code, the question would get closed, because there are very strong rules in Stack Overflow to have a high quality question and answer site. So that's the second element. The third element is you need to include your entire screenshot, entire error traceback, sorry. So from the beginning up to the end. That was the third element. And the last element, the fourth element, is you need to highlight your code. Just like that. You see, this is much more visible and easier for others to troubleshoot. So the course interface has that function there that you can highlight your code. On Stack Overflow, you also have that capability. So just go to ask question, you write your code here, and highlight it, and then use this curly brackets. Yeah, that's it. If you ask good questions, the odds are that you're going to get a good answer as well. So I hope this makes sense, and I hope I showed you something that you didn't know, and I'll talk to you later. See you. Hi again, let's have one more lecture about errors in Python, and this particular lecture will be about handling errors. Handling errors can be an advanced concept to digest for now, because you're still going through the basics of Python and you haven't seen any real application yet. But later we will use error handling when we're building real-world applications. So you're going to understand error handling better later on. For now, let's just focus on the syntax and try to understand as much as you can. I'll go and do an example here, which I mentioned earlier. Let's say we have a function that does division between two given numbers, like that. Return A divided by B. And then you call the function here, divide 1, 2. In this case, the function will try to divide 1 by 2. And let me print out the output so that we can see it on the terminal. Go to the terminal and execute the script, so you get 0.5. Now that's good. However, if the user enters, let's say, 0 there, like that, execute, and your program will crash, so it will show an error. Now this one here is an example of a longer error message that I mentioned previously in the previous videos, that you might have more than one error in your traceback. So for instance, this says file line 4, this line here. So that line is where Python captured the error at first. So basically Python was trying to execute this line, but it couldn't do it. It didn't manage to do it because this line was trying to get the information from this function. And this function was trying to do this mathematical operation using 0 after the division. So that is not possible, and Python is pointing that out here. So that's the main error in line 2 in this expression. So that's where you should focus. However, when you ask questions, you should include the entire error message in your question, as I mentioned previously. So back to handling errors now. What I'm trying to say here is that, if you had other functions here and other lines of code that you want to execute, that you want Python to execute, but if the user passed this 0 number here, all the other lines would not be executed, so your program would crash, and you don't want that. And the way to avoid that is by using try and except. So basically you try to capture the exception, to handle the exception. And the way to do that is quite easy. Try, you say try and return a b. So this has to be indented like that. So try is indented because it's under the function definition. And then return is indented because it's under the try expression. Then you have except execute. So this has to be in the same indentation level with try. They are the same block. So except, if there is an exception, what you want to do is print out you are dividing by 0, or is meaningless. So let me try this now. And you get 0 division is meaningless, and none. Oh, sorry, I meant to do here return, not print. I explain you why you get none there. And so you got none as an output because what the function did was it tried to do this expression, but it got an error, so it ignores this line, it doesn't execute it, and then it goes to the next line. So this line is executed when this is not executed. And so it printed out 0 division is meaningless, but it also printed out none because when you execute a function that doesn't have a return statement, such as in this case, we had a print statement here, a print function, not a return statement. In that case, if the function is not returning anything, it can have a print function or other function as well. But if it doesn't have a return statement, then it will print out none. So basically, it executes the other procedures, such as the print statement, it prints out the statement, but if it doesn't have a return statement, it prints out none. Anyway, save this now, execute again, and in this case you get only this 0 division is meaningless printed out there. So basically, if you had other lines of code here, like that, those would be executed as well. And that happens by using the try and except block, which makes sure that the code flow continues. So, one other important thing to note is that it is advisable to actually here use the exact name of the error that you want to accept. So, 0 division error. And as you see, this got turned into blue, which means that this is actually a Python keyword. It's recognized by Python. And in that case, if you execute this, you get the same output actually, like that. Or if you pass a number there that it is possible to get a division from, you'll get that. Sorry about the backslash. I typed that by mistake on my terminal. Execute again, so you get this. And so what I'm trying to say about the 0 division error is that, sometimes you might get other types of errors in your code, other types of exceptions. So let's say you have a name error there, and you are saying that accept all errors. When you don't pass this, you're basically including all types of errors there, and that is a bit dangerous for your code because you might have problems that you don't notice, and basically you are ignoring them, but you shouldn't. So it should be specific there, explicit, like that. If there are other types of errors, such as a name error, that name error will crash your program, so you know what's going on, and you need to be specific. If you want to handle that error too, then you can add another exception here, except name error for instance. Yeah, that's about handling errors in Python. I hope this makes sense. I hope I explained this well. And yeah, this is about errors. I'll talk to you in the next lectures. See you.
Hi and welcome to this new section.
In this section, you're going to learn about two very important concepts in programming. These are functions and conditionals. So functions are used to keep your code more organized. So think of functions as small chunks of code, which together build a program. That is what you need to know for now. Functions are useful for other things as well, but you'll understand it as you build the real-world programs. In the next video, I'll write a function, but that is just a standalone function, so it doesn't interact with other parts of the code. It's just a function. But when you see the large applications later on, you'll see how the function integrates with other parts of the code. So that's a good thing of creating real-world programs. That is how you learn how to do programming in real life. And that's about functions. And then in this section, you will also learn conditionals, which basically are used to have your program make decisions. So if that number is greater than that, do this. If it's not greater, then do this other thing. That's basically the idea, but you'll see it in action. So this is about the introduction of this section. I'll see you in the other lecture. Hi again, in this video you'll learn how to create a function in Python and how to use that function. So let me go ahead and create a script. Let me name this my function.py. And let's go ahead and create the function. Creating a function will always begin with the def keyword, which means define. And that is followed by the name of the function. So you need to give your function a name. Let me name this minutes to hours. And as you may guess already, what I'm creating is a function that will convert minutes to hours. So you create the procedure on how to convert minutes to hours, and then you can call that procedure. So you can call that function. You can give that function any values when you call it, and the function will produce an output depending on the value and depending on the formula, on the procedures that you write in here. So let's go ahead and do that. Minutes to hours. Now functions, normally they have some input and they produce some output. The input goes inside these brackets in here. In our case, the input could be minutes. So this is just a variable. You can give it any name that you want. You can give it any name that you want for the function name as well. So the input is minutes, and then the output will be hours. But you don't write the output here. Here, what to do? You always use a colon. Press enter, and that will be auto-indented. So as you see, the functions, everything that you write below the first line of the function definition is indented, and every line after that. So the def keyword, the name of the function, the input, and here we write the body of the function. What we want to do is, let's say variable hours equals to minutes divided by 60. That should give us the hours. Note that if you are on Python 2, you want to do 60.0, because if you do that, you'll get an integer as an output and not a float. So in Python 2, you have to explicitly pass a float when you do division to get a number, to get a float with decimal points. I'm in Python 3, so I don't need to put 60.0 there. And yeah, this is a simple function, so this is what the function will perform, and then the last line of the function is normally a return keyword. So notice that these are reserved keywords, def and return. And what I want to return is, well, guess what? The output, which is hours. So that's the idea. We are getting minutes. The user will input a value for that later when we call the function, and then minutes will be divided by 60, and that operation, that number will be stored in the hours variable, which is a variable that exists only inside the function. So this is called a local variable. If you call it outside the function, it will not work, but we'll cover that later. And so then we return the value of that variable. Now, I'll save this and open the terminal. make some space there, and let me execute the script. You get nothing. The reason for that is because what you did here is you just defined a blueprint. You are not using that blueprint. So what you do next is you need to go ahead and use that blueprint. So, which means you need to call that function. So backspace to go here to unindent. Unindenting means that you are done with the function definition. So when you start a new line, like here, that means you are not writing inside the function. And so to call a function, what you do is you just call the name of the function. Min_2hours, and then you open brackets, and then inside brackets you pass a value that you want to use as input. So let's say you want 70 minutes, you want to convert them to hours. Save the script, go and execute. Again, you will not get any output, but let's see. As I said, you won't get any output. So why is that? Well, that's because you didn't perform a print operation there. You didn't call a print function. So what you do is you do print. So open brackets, close brackets, and inside the brackets goes the function call. Save your script, go here, execute, and yeah, you get the hours. 70 minutes is equal to 1.1666 hours. So it's important to know that this value here, this is just a number. So you can see that by doing type and execute. Oh, sorry, I didn't print it out. And so this is a float number, so just a number. The function gets an input and it generates an output, which is defined by the hours variable. So whatever is stored in the hours variable, that is the value that the function will output. And yeah, you can do things like, you can use this output to do other operations. Let's say you want to add 10 hours there and you want to print that output, so expect this to be 11.1666, so on. And of course, now in your script you can add more functions if you like, like that, like seconds to hours, you pass seconds there, and here seconds, return hours, and so on. And of course this works separately, so you can say print seconds to hours and pass there. Actually we have to change this because this would be divided by 3600, and let's say this number of seconds, execute, and you get 2.0 hours. And you also get the other output in here, and this one here. Now, something important to know is that these are custom functions. And this one here is also a function, but this is a built-in function. So custom functions are functions created by you, and built-in functions are functions that are created by someone else. So in this case, print is created by Python authors, and print also has its own code, but it's more a low-level code, and it's actually written in C, so you won't be able to see the code for print. And yeah, this is an introduction to functions. In the next lecture, I'll show you some more advanced features of functions. So let's see you there. Alright, in the previous lecture, I showed you the syntax of a function definition and the syntax of how to call a function. So this is the basic representation of a function. But there are some more things that you can add to a function. So that's what you're going to learn in this lecture. And I'll make this simple. I'll delete this. And here we are. And so here we have only one parameter. So this is called a function parameter. However, you can have more than one parameters for a function. Let's say seconds. So in this case, I allow the user to enter both minutes and seconds and then the program will calculate the hours based on that. So basically we want to add seconds here, seconds divided by 3600. So yeah, I hope I'm fine with the math here. So minutes divided by 60 give you hours, and then seconds divided by the number of seconds in 1 hour gives you the hours. And yeah, we add them up and we return hours. Therefore, let me delete this 10 here. In this case, when you call that kind of function with two parameters, you'd want to pass two values, 60, let's say, and 300 for seconds. Save, execute, and you get 1.25. And that's how you can add multiple parameters to your function and multiple values. Now, if you don't pass a value there, for one of the parameters, and you execute, you will get a type error. This is saying type error minutes to hours is missing one required positional argument, which is seconds. So you are not allowed to miss a value for a positional argument. So seconds is a positional argument which you need to pass in the function call. So these are referred to as arguments when you use them here, when you're talking about function call, and they are referred to as parameters when you pass them in the function definition. So parameters, and when you're talking about function call, you refer to them as arguments, and this is the value of the argument. And so positional arguments need to have a value passed in here. But default arguments don't need a value, and a default argument is when you use something like that. 70, and let's pass 300 in here. Execute. So syntax error, non-default argument follows default argument. The non-default argument here is this one. So positional arguments, such as seconds, are also referred to as non-default arguments. So the non-default argument second follows the default argument. And that gives you a syntax error in Python, because Python will get confused when you pass this 300 here. So it doesn't know whether you pass it for this one or for this one here. Therefore, you need to pass the default argument after the non-default argument. So seconds and minutes. Now, if you save the script and go here, this time you'll get a correct output. So 1.25. So let me summarize again what happened here. We have a non-default argument and a default argument, which has a default value. Therefore, when you call the function and you pass only one value, Python knows that you're passing that value for the non-default argument. And for the default argument, Python will use the value of 70. However, if you pass another value there, let's say 200 minutes, save the script, execute, you'll get another output, because Python this time used the value of 200 for minutes instead of its default value. So when you don't pass a value, Python uses the default value. When you pass it, Python uses what you passed in the function call. So this is useful when you create functions where some of the arguments will have a value that is not very likely to change very often. Something else about functions before I close this lecture. You don't always need a return keyword in here. You can also do, let's say, print hours, and then you don't need a print statement there. You just do that, execute, and you get the same output. However, note that, if you do plus 10 now, and you execute, you'll get an error, because it says non-type and int, so unsupported operand type for non-type and integer, which means the non-type is this one here. So this is not a number, and you can see that by doing print, so print the type of that function, of that output. and you'll see that this is a non-type. So the function doesn't produce a number when you use print. So bottom line is, when it comes to what the function does, you have two types of functions. You have functions that generate an output, and you have functions that perform some procedure. So this was an example of a function that performs some procedures. In this case, what this function did was it calculated hours and it printed hours. It didn't return an output. And other cases might be like, when you create a file, so you process some files, you create a text file, you write some output in that text file, and you don't need a return keyword in that case. But we will see that later when we cover file handling in Python. Most of the time though, you will have to return a value here. So that's the idea. This is about this lecture, and I'll talk to you later. Hi, here is one more lecture about functions, and this one is in a more practical view. Because what we're going to do is we're going to save that. We're going to look at the program that we built in the previous lecture. Sorry, in the previous section. So this simple program. Note that these are not the real life applications that this course covers. So these are just small snippets of code. Don't confuse this with the real life applications. We'll cover 10 real world applications later in the course. So in this program, what this did was it asks you for the age. Let me guess. That's not exactly my age, but anyway, 90. So this will print out your age plus 40. So 90 in this case. And what I want to do in this lecture is I want to organize this code better by putting this inside a function. So this will help you understand functions, how they are used in a more real-life situation. So the function basically had three components, and that was the input, the body of the function, so the operations that the function performs, and then the output. So in this case, we are going to somehow get the input from this user prompt, and then this will be the body of our function, and then we will output this one here, the new age variable. So let's go ahead and define a function here. Define age foo. Let's keep it like that. And we're going to get some age input there. And there goes this line. So the new age will be equal to the input that the function will pass in here. So we convert that input to a float, and then we add 50 to that, and then we return new age. So once you have defined a blueprint, so to say, once you have defined your function, then you want to prompt the user for a value so that you have a value ready there to pass it to the function call later here, which will be like print age foo age goes there. Now don't confuse this age variable with this one here. They just happen to be the same, but these are not the same because this is a local variable. Well, this one in here is a local global variable. Sorry, a global variable, local variable. So what happened is when Python executes this script, it goes line by line. So it reads the first line, second, third, and it knows it's sort of records in the memory this kind of blueprint. But anyway, this is just a blueprint, so it will not output anything. And then it goes to the next line. This is empty. Okay, go to the next line. Age equals to input. We have an input function which creates a user prompt. So it prompts the user this message. And then the user submits a value, and that value is stored in the age variable. So this is a global variable. It doesn't have to do with this one here. And then what happens is we call the function. foo, and inside that function we pass the value stored in this age global variable. So let's say the user passed 40. 40 will be passed in here. So 40 here, which means this 40 will be passed to this age argument, so to this variable. So the local variable now will get a value of 40, and that value will be put in here. So float 40 plus 50 equals to 90, and that will return 90. And so that 90 will replace this thing in here, and Python will print 90.0 in the command prompt in the terminal here. Let me try that. Enter age 40, 90.0. And yes, basically that's how you integrate user input with functions. That's about this lecture. I'll talk to you later. Hey, hello again. In this lecture we're going to learn about conditionals. What is a conditional? Well, a conditional is a block of code which perform different actions depending on whether a given conditional evaluates to true or false. So let's go ahead and create a conditional in Python. I'll create a file, conditionals.py, and let me create a conditional block. And first of all, let me create a variable. Let's say a equals 5, and here I'll create a conditional block. This block, what this will do is it will perform an action if a is less than 5, and another action if a is equal or greater than 5. So let me create that. If this is our conditional starts, if a, let's say less than 5, print, let's say less than 5. Press enter. And if you want to perform more actions with this condition, so when this condition is true, this will be executed. But if you want to perform more actions, you can add them there. If not, then you can go to the next check. So that would be else. So you have a colon here, a colon there. So else print equal or greater than 5. Now let me execute this. And we get equal or greater than 5. So why did we get that? Well, because, if a is less than 5, which is not, so this evaluates to false, and that means this will not be executed. So Python will skip this line and it will go to the next one. This next line says else, so else means if this is not true, this will be executed. So equal or greater than 5. So in this case, if a is not less than 5, then there's no other option but a is either equal or greater than 5. So that's an if and else conditional block. However, if you want to add more conditionals there, you want to use elif. So let's do that. The first two lines stay the same. If a is less than 5, print less than 5. Elif a is equal to 5, print equal to 5. Else print greater than 5. Save and execute, and you get equal to 5. If a was 6, you'd get greater than 5, and if a was 3, you'd get less than 5. And that's a conditional block in Python. And yeah, try to get familiar with the syntax, and in the next lecture I'm going to incorporate a conditional with this block of code. So see you there. Hi again, you should be able to remember this program which we built in one of the previous lectures. What this does is it has this function definition which gets the age and then it adds 50 to the age and then returns age plus 50 here, and then you ask the user to enter some input and then you pass that input to the program and then the program produces, the age that the user submits plus 50. That's the idea. So let's say 40 and you get 90.0. Now, the user may also want to pass 200, for example, for the age, and you get 250, which is not very realistic, let's be honest. And here is where you want to make your program more intelligent. And here is where you use a conditional. So slowly you are seeing how you can use features of a programming language to make some real programs. This is not yet a real world program because this is depending on a command line interface. This is not very friendly to execute programs this way, but the logic is going towards a real world program. So let's go ahead and improve the program so that if the user submits an age of, let's say, more than 150, you will not calculate 150 plus 50. Instead, you'll print out a message that says it's not possible to have this age or something like that. Let's go ahead and do that. This is a function definition. Now you shouldn't incorporate the conditional inside the function definition. It's good to leave functions simple as it is now, so it gets an input and it calculates the output. And so you can incorporate the conditional when you call the function in here. So let me delete that. The function definition, and then you ask for input. And then instead of calling the function right away, you first want to check to evaluate the input that the user submits. So let's check that. If age is less than 150, that is the time when you want to call the function. Age, so you're passing age in there. Else, so if it's not less than 150, you want to print out a message saying something like, how is that possible? So let me pass the print here as well. So we're printing the output. And let me execute, but I expect to get an error here. But it's good to take things step by step. Enter your age. Let me enter 1990 first. And yeah, you get an error which says type error. Unorderable types string is less than integer. So basically, Python cannot compare a string object with an integer. And this is in line 7, which is this one here. So this is a string, this is an integer. The reason is that, as I have mentioned before, Python loads user input as strings. So age will be a string data type. So you want to convert that into an integer or a float. It's good to convert it to a float. You can either do that here or you can do it here. I'll do it here, like that. But if you do it there, then you can remove that from there. So you don't need to convert age twice to a float. You can convert it at the source in here, and then you can use it directly everywhere in your code. So this is good when you're using this input more than once in your code. You can convert it directly in here, float. Save, try again. And you get the output. So 99 plus 50, 149. And let me try again to enter 151, which is above the threshold. And here you get how is that possible. And yeah, that's the idea. This is how you use conditional blocks. If your imagination is good, then you can go ahead and improve this program even further. So there's always something to improve. Give it a try, and I'll talk to you later. Thanks. Hey, in this lecture you will learn about loops. And loops are very important. They are one of the fundamental building blocks of the Python programming language and of every other programming language as well, because loops are crucial. So what are loops? Well, loops are basically a way that allow you to execute a statement multiple times. So what does that mean? Let's say you have a bunch of files, text files, and you want to insert a certain string inside each of these text files. So you'd have to open those text files in Python by writing the Python code that corresponds to opening a file, and then you'd insert that string inside the file and close the file and save it. So there is some code that does this opening and inserting the text and closing the file. And if you had 100 files, you'd have to execute that code 100 times. So you'd come up with, let's say, 100 lines of code. But that doesn't sound very efficient. So that's what loops are for. So a productive way to solve the problem that I just mentioned would be to create a list of these files, so a Python list of the file names, and then you would use a loop to iterate through this list of file names. And a loop would do all that in just a few lines of code. And there are two kinds of loops in Python. There is the for loop, and the example that I just mentioned would be solved using a for loop. And we also have the while loop. A while loop does also repeatedly execute a statement that you write, and it executes it as long as a given condition is true. So let's say you have a user that is trying to log in your web app, and while he keeps entering the wrong password, you'd continue executing a statement that would reject his login to your system. So while the password is wrong, reject the user, something like that. So that's about the definition of the for loop and the while loop. In the next lecture, I'll show you the syntax of the for loop, and by also looking at an example. So see you in the next lecture. Good. Now you know the definition of a loop, and you know that we have for loops and while loops in Python. And in this lecture, you will learn how to write for loops. Now, a for loop normally iterates through a list of objects and applies some methods or some functions or some operations over each of these objects. The array that the for loop iterates through is not necessarily a list. It can be a tuple, sometimes it can be a dictionary, it can even be a string. So every object that is made of other simpler objects. So let's create a list first. Let's say emails is a list of 3 emails, 3 email addresses. So let's write some fake email addresses here. me@gmail.com, you@hotmail.com, and they@gmail.com. Now let's say you want to apply the print function to each item of this list. And the stupid way to do this would be to print out every item one by one. Let's say the first item, which has an index of 0, and then you do the same for emails with index of 1, and so on and so on. That's definitely not how we want to do it. So to print out these 3 items, we use a for loop. And for loop always starts with the for keyword. And then you pick a variable, let's say email. So don't confuse the email variable with the emails variable. These are totally different. And for email, in emails, so here you pass a variable that holds the list you want to iterate through. And press enter, and as you see here, we got the indentation. So the line that follows the first line of the loop is always indented. So that means this line here that we will write belongs to this loop. So it's part of this block. And here is where we write the action, the statement we want to execute multiple times. So we want to print the email. So that is very straightforward and very clean and very readable. And let's execute this first before I explain it to you better. Save the script first and execute. And this is script 4. So we got the 3 items printed out on the screen. And I obviously got an @ wrong here. no problem. So what the code does is that you say for each item in the list emails, print out the item. And of course you can use every variable that you like if this is more readable for you. So for each item in the emails list, print out the item. Great. Let's do something more fancy here. I'll delete this line of code. And now I'd like to print out only the emails that have a Gmail address associated with them. So I don't want to print out any other item rather than the Gmail ones. So that means we want Python to make a decision. If it finds Gmail in the item, in the string, it will print it out. If it doesn't find it, will not print it out. So we want to use a conditional here, and that would be an if statement. So again, we say for each item in the list, if the string Gmail is in item, print out the item. So I'm sure this was easier than you were expecting. Let's save, Ctrl S, and execute. So we got only the Gmail accounts printed out. So again, we are saying for item in emails, and when we do this, Python grabs the first item of the list. So the first iteration is about the first item, and this item is temporarily stored in the variable item. Then while this value is stored in this variable, Python checks if the string Gmail is in that variable. So with the first item, this is true, and that's why Python prints out the item. So it prints out me@gmail.com. Then it goes to the next item. If Gmail is in that item, it prints out the item. In this case, Gmail is not there, so it doesn't do anything, and it goes to the next item. So that's why we call it a loop. So the loop goes in and out, until the list is exhausted. So when it goes to the third item, to the last item of the list, the loop ends, and the output is generated, like here. And don't forget about indentation, so be careful and look here that we indented under the for loop, and again we indent it under the if statement, because this indentation here is part of the if block, and this one here is part of the for loop block. So very readable code, and I believe very fun to write. I'll see you in the next lecture. Okay, before explaining the while loop, I would like to introduce you user input. User input is a feature that allows your script to interact with the user. And with interaction, I mean when the user executes the script, so like when we call the script here, the script will ask the user to enter some input. Let's say they will enter a number, and the script will get this number and will process it, will do some operations depending on what we have written inside the script, and then it will return some result back to the user. And the user input feature is implemented through the input function. As simple as this, input, and here you can write some message that will be shown to the user. Let's say, what planet are you from? Just like that. Save the script and then go to your command line and execute. So this is script 6. And the program is asking us to enter some input. Let's say Earth. That's it. Here nothing happened, because we didn't do any other thing here rather than just asking the user to input some value. So let's do something with that value. But first of all, we need to store that value inside a variable. That would be a good practice. Let's say planet equals to the value that the user will input. So the planet will get the value that the user will enter here. Then we can do something with that value. Let's say we want to print that value. Planet. That's it. So let's execute again. Mars this time. So the program prints out Mars. Okay, printing is good, but let's go a bit more advanced than that. So I'll go to my script 2, and what I have here is a function. Let me delete this. So we had the function here, which we wrote before in the course, And this function gets the currency rate as input and the amount of euros which you want to convert to dollars. So the function then calculates the dollars given the euros and the rate, and it returns the dollars. What we will do now is get a value for the rate and a value for euros from the user. So we will get those values here, and then we will execute the function given those values. For that we need two inputs here. Let's say r as a variable, input, enter rate. And once more, enter euros. And this would be E. And then these values would go here. So R for the rate and E for the euros. So we execute the script. Python reads the function definition. Then it asks the user to enter the rate. The user enters the rate. Then the script goes on. Python asks the user to enter the euros. The user enters the euros. And then those values are passed to the currency converter function. Now I expect to get an error here, but I still want to execute it so that you see what error you'll get, and that's how you understand things better. So let's execute script number 2. Yeah. This is not the error I was talking about. This is because I forgot to save the script. So let me execute it again. And so we are now asked to enter the rate. Let's say 100. Yeah. And euros, let's say 3 euros. Why not? And here is the error I was talking about. And Python is basically saying that it cannot multiply strings. Why is that? Well, that is because when the user enters the numbers here, as we did, the input function reads those values as strings. So it doesn't immediately read them as numbers, as we would probably expect. But there is a solution to that. Once we get those strings here in the R and the E variable, we could convert them to a float. We would want to apply the float function to each of these variables. So before these values would be passed to the currency converter function for execution, the values of these variables would first be converted to a float data type. And lastly, we would want to print out the output that this function generates. And that's it. Click Save, and then go to the command line. And script 2, enter the rate, let's say 4 euros 100 this time, and so we get 400. So that was how you can make your script interactive so that the script can get the user input, process it, and then returns an output. In the next lecture, I'll be incorporating the user input function while teaching you the while loop. So I'll see you in the next lecture. While loops now. You already learned about for loops, and we were able to execute the print statement multiple times using a for loop. For loops are used much more often than while loops, but while loops also have their area of application sometimes. And in this lecture I'll write a very small program that will demonstrate the syntax of a while loop. So let's start. A while loop starts with the while keyword. Let's say we want to write a program that will compare a password against the value that the user enters. And while the password entered by the user is not the same with the password that we know, the loop will keep occurring over and over again until the user enters the correct password. So while the password is different from, let's say the real password is Python123, and we need a colon there. And notice here that these two symbols mean is not. And here we are comparing a variable to a value. But we don't have a variable yet declared. So first we need to declare the variable here. Password equals to an empty string. So that's the initial value before the user enters their own value. And here we want to get the user value. And here we want to store the value entered by the user in our password variable. So input, enter, password. Now, once we get the value in our password variable, we want to compare that variable. And we compare it against the real password. So Python 123. So if the value entered by the user is equal to Python 123, we want to print out the string you are logged in. Else, so if this evaluates to false, we would have another action here. And that would be sorry, try again. That's it. Let's test this now before I go over the code again and explain things better to you. So save and then go to your command line. That's the script number 6. So let's try a wrong password here. Let's say just Python. Sorry, try again. We try again. Python 1, no. Python 123. And you are logged in. So we are just printing out some lines here, some text. But in a real life situation where we would be expecting a real user logins, we would have to write some longer code here that basically would show the user the internal pages of your website, of your web application. So you would unlock your user content of your website. So again, what we have here, while password is not equal to 1 to 3, this block of code will be executed over and over again. Once the value gets equal to Python 123, the loop stops running, and so does the script. So I believe this is a very nice explanation and example for you to understand the while loop. Again, you'll be using the for loop much more than the while loop, but this is good to know, and it was also good practice for you, I believe. See you in the next lecture. Alright, you learn how to use the for loop to iterate through a list. Sometimes though, you might have to iterate through 2 lists at the same time. Let's say you have 2 lists. A list with 3 items where you have some names. Let's say James, John, and Jack. Pretty creative here. And you also have another list. Let's say email, domains, which also has 3 items. It has Gmail, Hotmail, and Yahoo. If you'd like to apply the same operation to the items of both lists, you'd use the for loop in a slightly different way. So everything starts with the for keyword, and here you'd have to pass 2 variables. Let's say the variable I and the variable j. So for I, j in, and you'd use the zip function here. And there is where you put the names of your lists. Email domains. That's it. And here is where you write your actions, your operations, what you want to do with the variable I and j. Let's try to print them out first before we do something more creative. So this is how you print 2 variables at the same time. Click save. Go to your command line. This is script 7. And so you get both the item of the first list and the item of the second list. So that's how you use the for loop for iterating in more than one list. So let's move on. Hey, welcome to this new section. Now, I assume you know how to use variables, how to write functions, and you can tell the difference between different data types in Python. So you should know these things, and if you're not yet confident about those basic concepts, nothing to worry about. You'll use them over and over again as you build the 10 applications along the course. They are the fundamental blocks of the language, so you need them for every program that you'll write. And we'll be using these fundamentals a lot throughout the course. And now we start shifting a bit towards more practical things, and specifically, in this section you will learn how to handle files with Python. So far we worked only with numbers and text and, native objects in Python. In this section we will interact with files. So consider Python as a normal program, such as a Notepad editor or even Atom. Let's say Notepad, an editor. So Notepad can open text files and it can also write content in them. And Python can do the same, except you need to use code in the case of Python. So you need to write Python code to open a text file with Python, for instance, or other kinds of files. And you use Python code to grab the text of the text file. And you also do the same if you want to add text to that file, so read and write. And the process is very easy, you just need to practice it a little bit. So you need to practice the commands that do this file handling. And I'll be showing you all the necessary commands throughout the next lectures. These are built-in functions, so no need for third-party Python libraries. And yeah, that's just about the introduction. Let's get our hands dirty with code now. So see you in the next lectures. Great, in this lecture you're going to learn how to open a file with Python and how to read the file content so that you can manipulate that content there in Python later on. For instance, you may need some data, you may need to read some data out of a file. Let's say that would be a file where you have weather observation data and you want to open that with Python, and then you want to send an email with Python to, let's say, your email address automatically. So Python needs to read the content of that file as a string, and then it sends that string as an email to your email address. So that was just a random example. If you're an experienced programmer, you may find it easy to wrap your mind around how to use file handling techniques, so about real-world scenarios. If you're not a programmer, we'll be using file handling techniques in real-world examples, so in the application that we'll be building. Nothing to worry about. So let's look at the syntax then. Python can be used to handle both binary and text files. Text files are files with a txt extension, such as this one here. So example.txt. And you can open such files with editors such as Atom. And we also have binary files such as this DLL file in here, which you cannot read with an editor, as you can see. But mostly you'll find yourself working with text files. So here is a simple text file. And what I'm going to do now is I'd like to read these 3 lines in Python and print them out on the Python shell. So printing is crucial when you want to test things out. Let's say we're about to write a program, as I said, that sends an email. But first of all, you want to take things step by step. So you want to make sure that you're reading this file correctly with Python. And to make sure that you're reading that correctly, you want to print them out. You want to print the output in the shell. Once you see that the printing is working correctly, then you go to the next step, and instead of printing out that string, you take that string and pass it to your function that produces that sends email. So it's good to do things one at a time. And now I can either go ahead and create a Python file where I write the code to read this file, or I can use the interactive shell. For the sake of this demonstration, I'll prefer to use the interactive shell. So that will allow me to show you the intermediate results. So I write a line of code and I show you something, and then I write the other line and so on. So yeah, let's go ahead. And one thing, Terminal Plus, which is the Atom plugin that allows me to access a command line from within Atom, is having a bug, and I cannot install it at the moment, which is not a problem at all, because I can use the Windows command line. So shift right click and open command window here. And that will open the command line in the current directory, which is this one here, so Dropbox pp files. Here is where I have the example.txt file that I'll be working on. And yeah, Terminal Plus is good because you have everything in one window, and it's especially good for me to make this video so that I have things organized. But using the terminal of your computer is essentially the same thing. So to read the content of a file with Python, you first need to open that file using the open method, and then you want to read the file content using the read method. So first of all, you want to create a variable, let's say file, and then you use the open method, which is a built-in method, and then you point to the file that you want to open. And there is one more argument there you need to pass to the open method. So the first argument is the file input, and then you need to pass the mode that you want to open that file. And R means read. So the most important modes are R and W. R is read and W is write. So let's focus on R now. If you execute that, you'll get an error. Why? Because I haven't opened Python yet. And yeah, sorry about that. Let me write that again. So I was writing code in the command line. And R. Execute, that was successful. As long as you don't get an error, that is successful. So what is file? If you check what file is, you'll see that it's a text IO wrapper. Or you can call it a file object. So what we did is we imported that file in Python by creating a special object in Python. And remember, I told you that Python opens files as other programs do. So if you try now to delete example.txt, you'll get a message that the action can be completed because the file is open in Python. So once you have opened that file, you may want to read it. And to read the content of the file, and it's wise to save the content in a variable. So I'm calling this variable content, then I'll point to the file object, which is saved in the file variable, and then to the read method. Just like that, and execute. Nothing happens, so that was successful. Now if you print content, you'll get the text of the file. Which is actually a plain Python string. Sometimes though, you may want to save the lines in a list. So instead of using read, you want to use read lines. And if you print content now, you'll get an empty list, which I'm sure it's not what you were expecting. Probably what you were expecting was a list with 3 items, so line 1 and line 2 and line 3. The reason we didn't get that is that, when you apply the read method, before applying the read method, there's a concept called the pointer. So before applying here the read method, the pointer is before the first character of the text file, so just here. And when you apply the read method, what Python does is it reads everything that is from that pointer and down. And so when the read method finishes, so after the read method, the pointer has gone at this point. So the pointer is here, read method takes it here, and at that point, when you apply another read method or even read lines, as we did here, Python is trying to read everything that is from this pointer and down. And there's nothing under this point, so that's why we got this empty list. The solution to that is to apply a seek method there with an argument of 0. So what that will do, it will place a pointer back at the 0 position of the text file. So if you execute that, you get a message from Python which you don't need. Then if you apply again read lines, then print content, this time you'll get a list of 3 elements. So line 1, line 2, line 3. That's what the seek method does. And I know at this point it's hard to imagine why do you use the seek method. But in one of our applications where we're blocking destructing websites in our browser so that we cannot access those websites, which is good for productivity. In that application, we'll be using the seek method. There you'll understand how that comes into play. So it's actually very useful in certain scenarios. It really gives you lots of control over the files. And yeah, back to this list, you see these \n characters there. So one here, and another here, and yet a third one here. And \n in Python means a new line. So we have here line 1, but then when I created this text file, I did it like I wrote line 1 and then I pressed enter. So in other words, enter is the \n. And that is useful when you want to write content in a text file. So we'll be using \n later in the next lectures to write content in separate lines in a text file. And to get rid of those characters, to end up with a clean list with line 1, line 2, line 3, there may be different workarounds there, but what I'm thinking of is list comprehension. So our existing list is content, and you can either create a new list, let's say content1, a new variable to store the new list, the clean list, or you can update your existing variables by passing content there, and that would be equal to a new list. So now you want to create this new list on the fly using a list comprehension. So that would be rstrip, which is a method that remove some characters from a string, and in this case we would want to remove \n. So I there is a temporary variable of the list comprehension expression, and you want to say for I in content. So we are applying the rstrip method to the I variable, where I is the item of the content list. So what this will do, it will go through the first string, and it will strip out the \n from that first string, and then it will store it as first item of the new list, and then it will go to the second line, and it will do the same until the list is consumed. So execute that and content, and now we have a clean list. And yeah, that's what you should know about opening and reading text out of text files with Python. But that's one last crucial thing you should know. We still have this file open in Python. In this particular case, we're opening that file in read mode. But if you're writing something in that file, and then you close your terminal without closing the file, those changes would not be saved in the file. So you should always apply the close method to your file object. Just like that. And now you can go ahead and delete the file if you like. So that was successful. Again, your variables are still there. So once you read the content of the file and you store that in a variable, then you can reuse your variables as many times as you want. And yeah, that's about opening and reading files with Python. In the next lecture, we'll go ahead and write content in the file. So I'll see you there. Okay, now we know how to open and read content out of a text file. And in this lecture, we'll go ahead and learn how to write content inside a file, a text file. So we're still working with text files. Later, we'll be using the same methods, but applying those to binary files. So I'll go ahead and shift right click here and open command window here, so that I have a command line open in this current directory. Therefore, that allows me to pass relative paths when I work with Python, which is like directly example.txt. So if you open your command line from here, for instance, as you know, from C, you would want to pass full paths, which would be something like d and colon and then \dropbox \pp files \example.txt if you run Python from here. For convenience, it's good to open the directory in the current directory in your working directory, and mine is here, pp \files. And yeah, here's the command line. I'll now go ahead and trigger a Python interactive session there, and I'll go ahead and create a file with Python. Again, luckily the syntax is the same almost, so you use the open method and store the file that you'll be creating in a variable. Let's call this file, so let's name it example.txt. And this time you don't want to pass R, you want to pass W, which stands for write. You execute that, and immediately you get this example.txt file, which for now it's an empty file. So the open method, what it does is, it doesn't only open an existing file, it also creates a file when that file doesn't exist. So in this case, if this example.txt file was already in our working directory, what Python would do, it would open that file, and that file would be ready to write content inside it. When that file is not there, Python will create it. So now we can go ahead and say file.write. We don't use read, we use write in this time. And there you pass the string that you want to write in there. Let's say line 1. You execute, and you get some return there, which is not very important, but for your curiosity, 6 means you wrote 6 characters to your file. And now probably you're wondering and looking at this example.txt file, which is still empty. So it doesn't have the line 1 string written inside. The reason to that is this example.txt file is still open inside Python, and every change that you're making inside Python, it only exists inside the Python program. So you haven't yet saved the changes to your example.txt file, and that means when you open it with another program such as Atom, you still get the old file. And if you also try to delete this file, you'll not be able to do so because that is open in Python. So to write the changes in there, you want to use the close method. Close, and now if you go to Atom, you'll see line 1 in the example.txt file. And that's how to write content inside a file. Now, something important that you should know is, if you want to add a second line to this example.txt file, you probably would do, you'd open the file, so file open example.txt, in your write mode, and then you'd probably add line 2 in there, and then probably close the file. But what you get is line 2 only. The reason to that is the W method is not an append method. So for adding more lines to your existing text file, you'd want to use the append method, which you'll learn in the next lecture. So write method, what it does is it actually creates an empty file, and then it allows you to write everything that you want inside that empty file. That said, it's still possible to add multiple lines using the write method, but you will have to do that in one session. So that means you create a text file, and then say file write line 1, and then file write line 2, and then close the file. And what you get is this text. So you get both line 1 and 2, but that's probably not what you expected exactly. What you're expecting is probably line 1 in a separate line and line 2 under that. So to do that, remember that we had this \n special character. That will allow you to create a new line just after line 1. And then when you write line 2 and then close the file, you'll get a text file with 2 separate lines. However, if you had to write a long list of lines there, let's say you have 20 lines, you want to write and executing the write method 20 times wouldn't be very efficient. So what you could do is use a for loop to write all the lines using one single write method inside the loop. So normally you'd have a list or any other object. You may have an Excel file or CSV file with lines. And let's say you have three items in there. Line 1, line 2, line 3. And if you want to write these 3 lines in your example.txt file, you'd want to iterate. Let's say for item in L, which is the list, file.write. Item here would be, in the first iteration, item would be line 1, and then line 2, line 3. So you want to write item, and maybe it's a good idea to use \n So after line 1, you want to create a new line and then write line 2 after that. So item plus \n. And yeah, that should do it. And nope, that didn't do it, because Python cannot operate on a closed file. So this file variable is actually a closed file object now. And you want to open that first, because we closed it here, and therefore you need to apply the open method again. So again, file and open, you open that file, and then go ahead and say for item in L, and we do this. Execute. That was successful, but you still don't see the changes in your txt file, because you need to close the file. And yeah, a line 1, line 2, line 3, that worked perfectly. So if you get this error another time, you know that you first need to open a file in Python, then you apply write or read methods to that file. So that's about the write mode. In the next lecture, we'll go ahead and append some more lines to this existing text file. So I'll see you there. Alright, very quickly now, let's go ahead and add some lines in this example.txt file. And that process is called appending. Again, you want to use the open method. And again, you may point to an existing file, or if that file doesn't exist, it will be created. And the argument you want to pass now is a. So that stands for appending. As you can observe now, in contrast to the previous lecture, our text file was emptied, but in this case we still have these 3 existing lines there. Again, you use the write method to add anything in there, line 4 or whatever, and normally the changes haven't yet been reflected in the atom editor, so you want to close that. And now you see line 4 added in there. And yeah, that was what I wanted to show you in this lecture. And yeah, I'll see you later. Alright, now you should have a good understanding of the main methods of file handling in Python. And so I have a list of all the other modes here that you can use for file handling. And so we did R and W and A. Now you also have these combinations. So for instance, R plus. What this should do is it opens a file both for reading and writing. Because with R you can only read, and with W you can only write. So this allows you to open for both reading and writing. And so this also, W plus, it also opens a file both for reading and writing. So we're talking about reading and writing in the same session. So you open a file, and before you close it, you can apply a write method between these 2 expressions, and read method as well. Now the difference between R plus and W plus is that with W plus, it will overwrite your existing file. But with R plus, it doesn't overwrite the existing file, but it places a pointer at the beginning of the file. And then if you write something, then you'll write that text above the existing text. And we'll be using this in one of our applications, so you see how this comes in handy. And lastly, we have A+, and this will place your pointer at the end of the file. So like in here, if you were reading this. And then you can append things under that. So this makes sure that you have all the possible combinations there, so that you can manipulate and adjust what you want to do, what you want to accomplish in working with your files. So spend a few minutes trying this out, and if you don't understand anything, just drop a question. And yeah, we have one more lecture to go, so see you there. Hey, welcome again, and this will be a very short lecture. What you're going to learn now is how to use the with statement. Now, what with statement does is it lets you write cleaner code when handling files with Python. So that's one thing, and the second thing is the with statement makes sure that the file is closed without you having to write a close method explicitly. And yeah, this is what I mean. So everything starts with, and then you use the same method, so open to open a file, and you say example.txt, And let me use a method, maybe append plus for reading and appending. And you say as file, so you create a variable on the fly. And notice the colon there, which underlies that you need to indent the code under that. So every time you have a colon in Python, everything that goes after the colon is indented. And these lines now are part of the with statement block. So we're talking about a block of code in here. And then you do the same thing as you do with a normal file handling, except of when you finish this block, you don't have to close the file. So what we could do is, with the a plus method, when you open a file with a plus method and then you want to read that file, the pointer will be at this point currently. So if you read now, you'll read an empty string. So what you could do first is maybe file seek and 0 there. And that will place a pointer at the first line, just there. Okay, and execute that. Then you could do content equals to file.read. And what that will do, it will create a variable named content, and then you can reuse that variable inside the with statement or outside of it. So the variable stays there. And then maybe write something there, alright. Probably we need a break line there. And then line 6, yeah, 6. Execute again, and you're done. As you can see, I didn't have to close the file. The changes will be written in the file once the block of code ends. So the syntax is similar to when you write a for loop with this indentation in here. And our content, you see that you have these lines there. And also, if you open example.txt again, you see that line 6 is there. And yeah, that's about the with statement. In rare scenarios, you'll still want to use a file.close, especially if you have a long code to write. So if you want to open a file in the beginning, and then you do a lot of work with that file. So maybe you're interested to keep the file open. But for quick writing and reading, use the with statement, because that will make your code look cleaner. And yeah, that closes this lecture, and I hope you learned from it. And I hope you're enjoying the course, and please leave a review if you're feeling like so. I would appreciate that. And yeah, I'll see you in the next lectures then. We have more to go, still a lot of things to learn. I'll talk to you later. Hi there, and welcome again, and here we are with a new section. And at this point, you know how to use things like loops and functions and conditionals, and even you know how to do file handling with Python. And in this section, we're gonna have some lectures where you'll learn how to perform some more advanced functionalities that will really help you understand and do things in certain scenarios when programming with Python. And these are things like understanding and using external libraries, and handling dates and times in Python, and commenting and documenting your code. So quite a few interesting things, and after that you'll be ready to build the first real-world program along with me. So yeah, let's go quickly through this section, and I'll talk to you in the next lecture. Now, when you install Python, what you do is you make available the Python built-in code. An example of this built-in code would be the print function. So let me open a command window here and call Python. So when you say print, you execute and everything works perfectly. So where did you get this print function from? Well, when you start a Python session, like here in the interactive shell, or when you run a script, a Python script, the session loads together with a bunch of built-in functions and methods. And this is one example, so the print function. Now, there are also commands that are not loaded when Python loads, and these are considered to be less frequently used by programmers. So it has been judged that it's not a good idea to load everything into memory when you load Python. So the solution here, the workaround, is that you can load these commands explicitly yourself when you need them. And to do that, you use the import keyword. So let's say you want to concatenate, so to merge a bunch of text files that you have in a directory, in a folder. So you want to merge the text in one single file. And what you need first is you need to create maybe a Python list where you have, as items, you have all the file paths that you want to concatenate. And to generate a list of file paths in the current directory, you need a module called OS. So you need to import OS, because if you just do os.list_dir, which is a function that lists the file paths, you'll get an error. It says a name OS is not defined. So what you do is you import OS, and that is successful if you don't get an error. And then os.list_dir, and yeah, you get an empty list because I have nothing in here at the moment. So I'm going to create a file, sample1.txt, and now you get a list with this file name. So what you did is you access the list_dir method of the OS module, and you can see a list of available methods that you can apply to your OS module. So dir OS, and yeah, among them you'll find list_dir, which is here, so just here. And yeah, don't get scared about this entire code. You don't have to know this. I mean, I don't know most of them. I've just used only a few of them. When the need comes to do something, you just try to Google, and you'll have people who have had the same issue. So you'll get the answer in some forums like Stack Overflow, and you'll see what other people have used. And yeah, this is called introspection. So when you inspect your code, when you see information about the code, like we did here with the dir function. And yeah, OS is a module. We also have libraries and packages, which basically are the same thing, but I'll go through them one by one. So let's focus on module first. And a module is just a Python file, a .py file. So if you apply the file method with double underscore in front and on the back, and you'll get the path of the module. So you can see here it's the module name is OS, so the file name is os.py, and you can go ahead and locate that file now. I think it should be this one here. Yeah, here it is. So this is my Python installation, and you have a lib folder in there, and just inside that you have all the external modules that you can import in Python. So you can try any of them if you like import pickle, and if you don't get an error, that is successfully imported. And you can also ask for help, pickle, to see what the module is about. So create portable serialized representations of Python objects. And this particular module is used for network programming. So if you're interested, you can look at that. And yeah, if you can open this file with any kind of editor. And yeah, this is quite scary. You don't have to understand this code. This will do the work on the background. But it's just good for your information to know what a module is. Alright. Now, there's also the concept of libraries. And libraries have usually more code, so people who build them, they just decided to write the code into different files instead of just one .py file. So you have a collection of .py files for libraries. However, the way you use libraries in Python is the same. So let me locate a library here. So we're still in the lib folder, and all these folders that you see now are libraries. For instance, SQLite3. If you go ahead and say import SQLite3, and that is successful. So you did the same thing as you did with modules. And if you look at SQLite3, you'll see a bunch of Python files, as I said. And here you have files as well. You don't have to know this, but basically what happens is when you import a library, this init.py file is executed in Python, and this contains the code that loads all the available methods in Python. Now, this particular one, what this does is it imports yet another file into Python, so a module SQLite3 DB API2, which is this one here. So it refers to SQLite3, the folder name, and then a dot, and then DB API2, the name of the file, of the Python file that is imported. And then inside here you have other code, and so on. You don't have to know this. It's enough to understand the structure. And yeah, that's about libraries and modules. And these modules and libraries, they come with your Python installation by default. However, they don't do every possible thing that is out there. That's why third-party modules and libraries exist. And these are often referred to as packages. Now, these packages, they don't come with the default installation of Python. And the good reason for that is there are lots and lots of packages out there, and you don't want to get a heavy installation there on your computer by default. There are packages of biology and astronomy, web scraping, everything, and so there are things that you're not really interested. And yeah, the solution to that is you install these packages, and then you use them just as you do with modules and libraries. And the way to install them is you just open your terminal, so command line on Windows, terminal on a Mac and Linux. The directory doesn't matter. And all you do is you say pip install, let's install glob2. So this is a package, or you can refer to it as a third-party library. And you hear people referring to packages as third-party libraries. And yeah, this installs glob2 for you. Now you can go ahead and access it in any Python session, glob2, and yep, you're done. Similarly, you can ask for help for that package, so help glob2, and yeah, you see what this is about. Sometimes though they don't say what they're about in the help file, so you'll have to search on the internet for glob2. And every package has its own page almost. Glob2, just like that, and yeah, you go here. So what this does is it captures patterns and supports recursive wildcards. Basically what this do is, if you say glob2.glob, and you just need to pass a file path there. Sorry. And yeah, what this does is when you pass an asterisk there, it lists all the files in there. But if you want only the text files, you do want to say asterisk.txt, and it gives you every file that has a txt extension. So in this case, you have this particular file in that directory. This is useful over a list dir, because if you want to only access the txt files, and you'd want to do this because in a directory you may have lots of files. This allows you to access only a few of them. And yeah, now about pip. So you saw me use this pip package. Actually, pip is a library that comes installed with Python, and you can find it in the scripts folder. Pip, so pip.exe is for Windows. Pip is normally in the computer search path, which underlies that when you are in your terminal and you do pip, your computer knows where to get pip from, so it gets this pip.exe. Pip then, what pip does is it downloads the package, and once it downloads it, it installs it. So if you go up here, it says pip install glob2 and downloading and then installing the package. And then the package is there in your system, and you can use it as you do with modules and libraries. So to sum it up, modules are Python scripts that you can import into Python, and libraries are collections of Python scripts, and you can import libraries as well. And also packages are third-party libraries. So 3 different terms out there, but library, you can use the term library as a general term for anything that is imported in Python. Just for the sake of simplicity, people do this. So that's about this lecture, and you could even make it through without knowing this information. that you got from this lecture, but it's good to understand these things, as you can also understand and be able to fix problems that you might get with modules and libraries or packages. So yeah, if some things look unclear to you, then just drop a question. And I'll talk to you in the next lecture. Hey, hi again. And in this lecture, you're going to learn how to comment and document your code. That is very simple, actually. So what do I mean by commenting and documenting? Well, commenting, let's suppose you write a script and then you want to give that script to other programs, or you're just working in a team or with other developers. And what you want to do is you want to find a way to document your script to your colleagues. And that's what commenting is about. So comments are this. So you start with a hashtag and you write whatever you like. Let's say create empty file. So what I did here is, I had this script that what this script does is it has a function that function creates an empty file called sample1.txt. And if you give this script to someone else, they may try to read the code and understand what you're doing there. But alternatively, you can help them by adding here a line that is not read as code by Python. So Python ignores everything that goes inside a hashtag. Basically, the way you do this is, before writing the function, you write this comment. And then comment basically means that you're pointing to this block of code. Now be careful, if you click enter and start something here, this will be read as code by Python. So comments are in line. You cannot have them in another line. If you want, you can, of course, do this if you want to add more lines. You can also write something besides some code. So for instance, writing empty string. And yeah, everything will work fine. And yeah, that's about comments. And we also have doc strings, which allow us to document our code. And with documentation, what I mean is, let's say you import OS, and then if you do os.doc, you'll get the doc string. So this is called the doc string. And what it basically is some basic information about the library or the module or the package that you are importing, that you are using in Python. And yeah, you can do the same. So if you import example, what to do, you are importing the example.py as a module. And if you say example and __doc __, in this case, you don't get anything because you don't have a doc string in your file. So if you want to give some information about your script to other people, you may want to add a line here with triple quotes, like that. And between those triple quotes, it comes a doc string. And that would be something like, this script creates an empty file. And if you save that, you go to the command line. And if you, you don't be able to access it right away if you try like this. So it's still empty because Python is still holding the old version of your example module. And by the way, to import Python script as a module, you need to be in the same directory with your Python script. So I open this command line in the current directory. And yeah, to get the doc string, you can either close this session, so the interactive session, and then open a new Python session again and import example.py and then access the doc string. Or if you want, you can do another trick. You import the imp library, and then you say imp reload, and then you pass example, so the name of the module you want to reload. Yeah, then you do the same thing, and then you get the doc string in there. And similarly, you can have doc strings inside functions as well. This function creates an empty file, like that. And yeah, go to the command line. Let me try exiting this time. So exit the script, start again, import example dot create file. dot doc, and you get the line in there. So this function, it should be this function. Anyway, this function creates an empty file. And as you can see, you can access functions from your module using the dot notation. If you do like that, that will execute your function, your Python function, and it will create the sample.txt file. So let me try that by deleting those. Delete that and we'll execute again. And sample1.txt is there now. And a last illustration, doc strings, you can find them in Python modules as well. As you see here, we have os.py, which I demonstrated earlier, and you see the doc string in here at the beginning of the file. You can see R as well, which what this does is, if you look at this doc string, this has some special characters, like this \n. And what \n does, it normally creates a break line when you are inside a string. So as you see, when you pass \n, that will create a break line, or like that. We'll use \n later, so don't focus on that for now if you don't understand it. You'll understand it very well when we use it in real-world examples. So if you think you're having such special characters, it's good to pass R there, and that will treat the string as a raw string. So it will ignore such characters. So it will not treat \n as a special command for break lines, but it will treat it as a single character. So it will print it along with your line as \n. That is clear, I believe, and we close this lecture now. We have some more lectures to go, so let's move on. Alright, dates and times in this lecture. And before going through the code, I would first like to mention a few examples when you'd use dates and times. Because for now, I believe you don't have much of an idea on how you're going to use dates and times in Python, or how does this code look like. So dates and times, you may use them, let's say you want to create a script that generates files automatically. And you want those files to have as a name, to have the current date. Instead of sample.txt, you'd have like 2016 and 5/14 and so on. So that could be, you could have a Python program where you call the program and you pass a balance of your bank account if you want to store the balance. Then you want to create a single file every day when you call a script. So that file would get as a name the current date automatically, without you having to type that down. So Python is able to give you the current date and time up to the microsecond accuracy. Also, other examples would be, you may want to know the difference between two dates. So how do you do that? You know how to use numbers and strings, and you can probably do that with numbers, but that would be not very efficient. So you really want to know how to use date and time objects, which are special objects in Python, are not just strings and numbers. So, or other example, you may want to plot some time series data along a date-time axis. And you can generate that graph with Python, and we'll do that in the course later on. So we will be using dates and times in many of our applications that we'll be building. And we have two modules that provide date-time object for us. The first module is called datetime, and the other is time. The most important one is the datetime module. These two modules are built in Python, so you don't have to install them. And datetime is basically used to manipulate dates and find differences and many other things. And also the time module is more frequently used to control the time when the script runs. And we'll go through that in just a bit. So first let's start with the datetime module. And I'll open a command line and start a Python session. Import datetime. That's what you have to do. And let me go through an example. Very frequently you'll be using the now function of the datetime class. Just like that. So datetime is a module name, and then you have a class with the same name, and that class has a method called now. If you execute that, you get a datetime object. And you know that's really a datetime object, so it's a special object if you check class datetime. What this has is, it has a series of numbers where the first one is the current year, and then the current month, the current day, the current hour, minute, seconds, and microseconds. That means every time you execute that, you get the current time. So it was 58, now it's 59 seconds. Sorry, minutes, this is seconds. And this is dependent on your computer time. So if I change the time now, change time settings, change date and time, go 11 and press OK. If you execute that again, now it goes up to 11. So what datetime does, it just grabs the time from your computer. Yeah, let me set that back. All right. And I seem to have put it PM, sorry about that. So yeah, this is good because you now know that this is a 24-hour system. Yeah, I put it PM, and it's 11, and that should be good. Great. Now, what if you want to find the difference between the current time and a specific time? In this case, you want to pass that specific time manually. So you'd want to write that down manually. And to do that, you access the datetime class, and there you pass the numbers of your date. Let's say 2016 and 5. Let's say yesterday, and 11, 0, 0, and 0. Now I can either subtract the datetime now from this, or I can store this in a variable. Let's say yesterday equals to that. And then now you can also store this in a variable. So now is this yesterday, is that, and you can see that this has truncated the seconds and microseconds because you passed 0. So it's doing something intelligent. Something that you should be aware of, is that whenever you print out now, you get the same time because that time was stored in the moment you called datetime.now. So you get the same value again. And you have to make the difference. You do now minus yesterday. And what you get is yet another datetime object, which is called a time delta. And what that gives you, it gives you an array with the day as the first element, and then you have seconds, and then you have microseconds. Now, if you want, you can subtract from that. Let me store that in a variable. Let's say delta. So delta is that. Delta dot days. And you get a number of days there. And if you want, you can get the number of total seconds. You need to pass brackets in there. So that would be the total number of seconds, the difference between those two dates. And yeah, let's now look at an example how would we use datetime in this example. So what this does is, we are passing this file name to this variable, and we use this variable to name the file that we are creating. So what this will do, it will create a file with this name, and that file is here, so sample1.txt, and that will be an empty file. Now, how about creating a file that has as name the current date? And for that, what you do, is datetime.datetime.now. And you also need to import datetime, like that. And yeah, let's go one step at a time. I'll open a command line in here. Terminal Plus is not working at the moment, so it has some problems, and I hope it will work in the future, but that will not affect any of the activities we're doing here. So it's the same as keeping the command line in here. Terminal plus is just a bit more convenient. And yeah, Python example.py execute. Nothing happened, we didn't get an error, everything is working fine, no file. Yeah, we haven't called the function in here. So create file, and yeah, just call it like that. Try out again, and you get an error. And the reason for that is, this is not a string object, this datetime.datetime. This is a datetime object, so when you name files, you want to use a string. So let's do just that and say string convert datetime into a string. Because that's what that will do is like now is a datetime object, but if you say string now as argument, that will be converted into a string of this format. So let's execute the script again. This time you get yet another error. This says invalid argument. The reason for that is, Python is trying to name a file that has a colon in the name. Now that is not allowed by the operating system, so you'll get an error. So the solution here would probably be to convert the date and time into a format like 2016, maybe 05 and 14, 11, and so on. So you use dashes there, which are acceptable. And to do that, you want to use formatting characters. And the way you use formatting characters is like this. You have now there, so the datetime object, and then you apply the string from time method, strf time. Then you pass a string with formatting characters. There are quite a few formatting characters actually, which you can find in this site. So for instance, if you want to use to get the year out of your date as a string, you'd want to pass %y with a capital Y. Or if you want to just get the year as a zero padded decimal number like this, you'd want to pass %y with small y. And yeah, let me try this. So we would want to get the year, and then we'd want to have a dash, like anything will be reflected in the string. So let me pass dash there. And then we may want to have the month, then the day, and then the hour, the minutes, seconds, and microseconds. Execute that, and this is a string. So this is a string object, and you get the year, the month, and so on. And of course, you can do any kinds of combinations that you like. So for instance, you could say B, %B, and maybe a space there, and then the year, and maybe the day. Execute that, and you get May 2016 and 14 for the day. So you can literally make any kinds of combinations that you like with this format. And yeah, let's apply this in our example. So we remove string, and what we do is, file name .str time, and then inside the strings here you'd pass year, month, and day, hour, and minutes. That would be enough. So let's keep it like that. Save that. And go here to execute it. Yep, so we got a file with this name, as you see. Great, so that is working, and if you want to add something there, if you want to add an extension, txt, you'd want to say plus.txt. And execute again, and you get a file with a txt extension, as you see here. And lastly, about the datetime module, we were able to subtract between 2 days, but how about adding a period of time to a date so that we get another date? Let's go to our Python shell. So we have now, and let's add 2 days in now. What you do is, let's say after would be equal to now plus date time dot time delta. And then here you pass, days equals to 2, execute. And here is after, so it's 2 days after 16. You can also pass seconds in there as a parameter, say like that, after, and this is what you get. So Python will actually get the seconds out of this, will add to the seconds, and then it will convert the remain to minutes and hours if necessary, and so on. And it will give you a correct date. That is exactly this period of time after this now date time. So that's about date time. And very quickly now, we also have a module called time. Now this comes very handy when you want to delay some actions, some operations in your Python script. For instance, let me create an empty list. And what I want to do with this list, I want to add 5 items in there. And each of these items will be the date and time. And there will be a difference of 2 seconds between these date times items. And so what you want to do is create a loop. Let's say for I in range 5, 1, 2, 3, 4, lst.append date time dot date time dot now. So what I'm appending is the first iteration of the loop. I am appending the current date and time, and then I want to wait for 2 seconds or just 1 to keep it quick. So the number you pass there is seconds. And if I execute that now, what it will happen is, the script will record the first date time in the list, and that will wait for 1 second, and that it will record the second time, and the second date time, and so it will wait for another second, and so on. And LST will be this now. Or let me print that out for I in LST. Print I. And yeah, this is what we got. We got 5 dates and times. And as you can see, they have 1 second of difference. So this second, 6, 7, 8, 9, 10. And you can also see the microseconds here. And this reveals the accuracy of the time module. So your computer is recording the microseconds at this execution of the loop. And then the time module does the loop to wait for 1 second. But that 1 second of the time module is not exactly, a million microseconds. So there's a certain flow and accuracy, which is not a problem practically. So yeah, this is the time module, and we're done with this lecture. I hope you learned lots of things from this. I will be using time and datetime a lot in the course. So yeah, let's move on. Hi and welcome to this new section of the course, and in this section starts the real deal. So in this section we're going to develop the first application of the course. Until now you went through the basics of Python, you learned functions, loops, conditionals, and handling files, etc. And now we're going to practice all those concepts by actually building real programs that can be used by users, instead of just looping through trivial strings and numbers and so on. And so what are we going to build in this section? Well, you're going to build a program which you can give a word, an English word, and the program will return the definition of that word in English. So let me go ahead and demonstrate the program. I'm using Python 3. app1.py is a script. So the program asks you to enter a word which you want a definition for. For instance, let's say mountain. And so you get the definition for mountain, and in this case it happens to have 2 definitions. So a mountain is a feature of the Earth's surface that rises high above the base. And also a mountain has another meaning, which is a great number of large amount of things not placed in a pile. Anyway, there are words who have only one meaning, like mathematics, I hope, yeah. So you get only 1 definition for mathematics. But also, the program has other features as well, such as, if you put rain with double N, so with an extra N, and press enter, the program, instead of crashing, it displays a message. It tells you, did you mean rain instead? So it's quite an intelligent program that guesses the word that the user may have had in mind when typing the word. So enter Y if yes, if you meant rain, or N if no. Oh yeah, I meant rain, so Y. And you get the definition for rain, which happens to have two definitions. This is the first one, this is the second one. The program also, if you enter a very random word that doesn't have any meaning like that, you get the message that the word doesn't exist. Please double check it, because the program cannot find a similar word to this. It cannot find a word first, and also it tries to find a similar word to this one, but it doesn't, because I don't think there is a match for this. And so it prints out this message. And there's also other things like, if you have mix of letter cases there, like uppercase R and A, you still get the correct input there. So that's a program. It has a command line interface, which means you're passing the input through the command line and you're getting the input again from the command line. However, later in next sections, I'm going to explain you web applications, how to create web applications with Python. So you then may get back here and actually create a web application using the code that you will be learning in this section. So you can extend this program to make it more user-friendly with a web interface where the users can enter the input through a web form, through a web page, and then press a button and then get the output on that web page. However, the code that you'll be learning in this section is very important. It's called Python, so you're going to learn about conditionals and loops. So you're going to implement all those that you learned in the previous section by developing this program. So I hope you like this, and I wish you success. See you in the next lecture. Hey, hi again! In the previous video I did a demonstration of the program so that you know how the program looks like and what is the output that the program generates, and also the interface of the program, which is a command line interface. So you input the data through the interface, the user inputs the data through the command line interface, and you get the output again from the command line. Now I have created a folder here somewhere, and I have give it a name. You can give it any name that you want, and inside this folder I'll be putting all the files of this project. So we're talking about the data files, like data.json. This is a file that contains the vocabulary where the program will extract, so we'll ask for a word, and this file has the definition of that word. And also the .py files will be put in here. So we know the output. Now we need to figure out the way how to go to that output, and we will take the approach step by step, which means that first we're going to develop a simple version of the program, just like give the program a word and the program will return the definition of that word. But this will be very simple because, the user sometimes they may pass a word that doesn't exist, and as a programmer you need to count for that word, for that non-existing word. So instead of interrupting the program, showing an error to the user, you need to show a more user-friendly message to the user. And we'll do that in the next videos, but for now, the very first thing we need to think about is the data. So I did some research on the web and I found this dataset of words and definitions. Now this is around 5 megabytes of data, so in Atom it takes a while to open, so I clicked it and I'm still waiting for it to open. Now it opened. So if your Atom freezes, then you can open this with a more lightweight editor such as Notepad or Nano on Mac or Vim. So anyway, this is a .json file. So what is JSON? JSON is like a language Some say it's not a language, it's just a set of rules how to format some data. So JSON follows this format. It starts with a curly bracket, and then all you have is pairs of keys and values. So this is like a Python dictionary. So the key is separated by the value by a colon. In this particular case, our values are inside square brackets, which suggests that sometimes you may have more than one item inside the brackets. For instance, let me search for the word Control F or Command F, rain. So that will take us in here. First, let me go to View and toggle Software Wrap. So what that will do is it will fit the text inside my screen. So for the moment, you see precipitation is outside of the screen bounds. So look, this also takes a while because we have quite a lot of data here. Now the data looks better, so let me search for rain again, find. And so this is the key rain, or let's say the word rain, and this is the definition of the rain. And in this case, we have two definitions because, for some words, you may have more than one meaning. Or you have more than one form. For instance, this is the noun, rain as a noun. So it's a precipitation, and this is the verb for rain. So when it rains, to fall from the clouds in drops of water. So it's a verb and a noun. And they are separated by a comma. So this is just like a Python dictionary. And now we need to figure out how to load this data into Python. Because to access data from this file, you first need to load it into Python as a specific Python data type. And then you access data from that data type. So think for a moment what Python data type would be more appropriate for this JSON file. So think about that, and I'll show just that in the next lecture. See you there. So I believe it was quite easy to realize that the best way to load this data in Python is a Python dictionary. So this looks just like a Python dictionary, and once you will load it in a Python dictionary, then it becomes very easy to access a value for a key. So how do we load this into a Python dictionary? Well, let me open a command shell here. For now, I'm just going to demonstrate something quick in an interactive Python shell. But first, you may need to close this JSON file because this is slowing down Atom. Don't save the changes, I didn't do any change anyway. So Python 3, that will open my Python 3.6.1. But anyway, even if you have Python 2, this program will work the same. So how do we load JSON into a Python dictionary? Well, for that we need to use the JSON standard library. With a standard library, it means that you don't need to install JSON, you just need to go ahead and import it. Once you do that, there is a nice JSON.load method there. And this load method, this expects, actually I can show it like this, help JSON.load. So this gets this argument here, which is a file-like object that contains a JSON document. So we're talking about the file object in Python, and we need to create that file. The way to do that is simple. So JSON again, .load. The way we create a file object is by using the open method. You know that already. And then you pass the path to the file. Now, since my terminal here is pointing to this folder, I just need to pass the file name. I don't need to pass any full path in there. So like that, you can either pass the R method, which stands for read mode, or you can just leave it like that, and the read mode is by default. Make sure to close brackets 2 times. So we have 2 opening brackets here, 2 closing brackets in here. And that's all. Now, what is data? data is a dictionary. So it's a Python dictionary, and you can print it out. Yeah, it's quite a lot of data. So that took a while, but normally you'll not have to print out the entire dictionary. What you could check is to access a word and a key from the dictionary. Let's say the key rain, you need to use quotes for the key. This is what you get. So you get the value for the word rain, for the key rain. So now that you know how this works, more or less, try to come up with a function that gets as input a key and then returns the value for that particular key. And also try to incorporate the loading of the JSON file and also print out the output. So if you have issues with that, in the next video I'll show you how we do that. See you there. I hope you figured out how to create a function that gets a key, so a word, and it returns the definition of that word. So let me quickly build that program. Let me call this app1.py, import JSON, data equals to json.load, open data.json, that's it, and define the function translate. Let me call this translate word, and yeah, all you have to do is return data word. That's it. And then you can either let's say you can either do something like word equals to rain, or you can do this dynamically by asking for input from the user. Enter words like that, leave a space, and then all you have to do is print out the output of the dictionary. Because you know this dictionary, for now, it just returns a string, but you are not printing any output. So if you want to show that output in the command line, you need to print out translate word, and that's it. Now, don't get confused with these variable names. This is a global variable, and this is also a global variable. So we define the variable here, and we pass it here. And then this, whatever is passed in here, goes to this one here. This could be a different word, a different variable name. So let's say W. So this is a local variable. It has a meaning inside the function, and it can be everything. So if you pass W here, it has to be W in here too. And this passes this value into this value in here. So usually programmers, they prefer to just enter the same name here and there. But for you as a beginner, I wanted to show you this difference, that this doesn't have to be the same with this. So save the script, maybe open another terminal. Python 3 app1.py, execute, enter a word, rain, and this is the output. How about this word? Oh, we got a nasty error there. But you don't want to show that to the user, right? Because this is not very readable. Traceback most recent call last. Okay. So how do we count for this scenario in our code? You need to figure that out. So think about it. In the next lecture, we'll do just that. So we need to take into consideration that word that the user passes may not be in the dictionary set of keys. So rain was a key of the data.json dictionary, but this name here was not, so we need to count for that. I'll show you that in the next lecture. See you. Alright, let's go ahead and make this program more user-friendly. So instead of showing this block of error, we're going to show a message that says the word doesn't exist, please double check it. or something like that. So the way to do it is, let me go to the Python interactive shell. You can check something like that, rain in data, and you get true. If you do this in data, you get false. So we need to make use of this and say if word in data, sorry, this has to be w, we're talking about this variable, and so if w in data, what you want to do is return the value. So this is the value, and so if this returns true, this is executed, right? Else return the word doesn't exist. Please double check it. So when this is false, then else is executed. This actually the expression under else is executed, and this is not executed. As you see, this is quite readable, very human readable. This is the good, one of the great features of Python actually. And so I can save this now and go here, execute the program. Rain would work as before, and this says the word doesn't exist. Please double check it. So as easy as that. So the program is taking shape. However, you need to do more tests to check for different inputs, in order to take into consideration every possible input that the user may put there. So let's say the user puts rain in uppercase letters, and this says the word doesn't exist. But actually, rain is a word that exists in your data set. And so how do we count for different uppercase letters? You also may have like mixture of letters like that, and it still says the word doesn't exist. Or even rain like that, the word doesn't exist. So think about that again, and in the next lecture I'll implement that, which is very easy. See you there. Great, we have this program now that returns a value from a word that we put. So it returns the definition of that word, and it also counts for non-existing words in our dataset, which is data.json. To count for different cases of letters that the user may input, you may look at the dir str should show you the methods that you can apply to a string. Here is there's a lower method, and what that does, is if you put rain there, it's so the method should be applied with brackets. You get rain, so the lowercase version of the letter. So since our data are all in lowercase in our data.json file, then what you do is, as soon as you get the input here, the string, you can convert it to lowercase, and then you pass that version to the dictionary access expression in here. So that would be something like, w equals to w.lower. So we are updating the w value here, the string that the user inputs, and then the w here will be passed as lowercase. So as easy as that. Let me do a quick test. Rain, and you get the correct definition of rain. So let's think about more possible values that the user may input. Let me clear the command line so you see better. Let me call the program again. Weather works fine. But how about instead of putting rain, the user types in an extra N there, the program says the word doesn't exist, which is true. But as a programmer, you want to make your program as more intelligent as you can. So in that case, you may want to consider checking for strings that are similar to what the user input. Rain, you need to check if there is some string that is similar to this word. And instead of saying the word doesn't exist, you want to suggest the user that, maybe you meant this word, similarly as you do a search on Google. So that's a bit complex, but not that much. And I'll show you how to implement that in the next lecture, step by step. So, see you there. Good. As I mentioned previously in the previous video, now we need to take into consideration whether the user mistypes something. So instead of rain, they enter an extra N there or something like that. And in that case, you want to let the user know that they typed something wrong there. So how do we do that? Well, if you have no idea how to do that, the best practice is to actually do some research on Google. Because the world of programming is very wide, and you don't necessarily need to know every possible workaround or solution to do something. So basically we need to figure out an algorithm to compare, let's say, the word rain with double N and the actual word rain with one N at the end, and say that decide whether these are similar or not. But you don't have to reinvent the wheel if someone else has done it already. So that's why you need to do some research on the web and see if this is something that, if there is a library that exists there, or someone has a source code that does it, a function or something like that. But often you'll find a library for that. So if you do some research, you realize that you can do that using a few libraries, and one of them is a standard library, and it's called difflib. By the way, you can get a list of Python standard libraries in this page. So python.org, library index.html. This is the link. Here are all the standard libraries that you can import into Python. So let me go here and import difflib. So this is a library to compare text. And one of the methods is sequence matcher. It's a long name, so what you can do is say from difflib import sequence matcher. What that does is sequence matcher. You need to pass none there. None is the value for the argument isJunk. So the first argument is an argument called isJunk, which means that, if you're comparing two blocks of text, in this case, we're just comparing words. So if you're comparing two blocks of text and you have some junk there, you have like break lines and spaces, then you need to pass here a function that ignores those lines. We don't have that scenario for now, so let's keep it simple. We pass none there for that argument, and then you pass it to strings. So you want to compare the word rain with a double N against the actual word rain, and that will return a sequence matcher object, which is nothing interesting. So you need to apply the ratio method to that to get the actual ratio. So this indicates a similarity between these two strings in a scale from 0 to 1. So they say that these are quite similar. Now this is about getting the similarity between two strings, but what we need instead is basically we have a list, a sequence of strings. So we have these keys of dictionary. We have a dictionary with lots of keys, and the user passes a word, let's say rain with double N, and you need to compare that word with all those keys of that dictionary, because you cannot compare rain with double N with rain with one N. in your program because you don't know that this is actually similar to this. So it's the reverse problem, so to say. But difflip has another feature for that, and it's called get close matches, like that. So you need to import that from difflip, import get close matches, but I'll consume this feature in the next lecture. See you there. Great, the program is going well. I hope you're enjoying this. It's not a big program, so we don't have lots of code here, but however, this implements quite a lot of aspects of Python. So we're loading data in Python into a Python data type, and we have functions, we have conditionals here, we have user input, and later on we're also going to implement for loops in this code. So we'll talk about that later, why we need for loops. And so we have libraries, we are importing libraries here. And so this is JSON. We also need to import the difflip library, which we are currently working on. So let's focus on difflip for now. And what we have is, we pass this rain string with double N here. And we got a set of suggestions. So the best matches of the word rain out of the keys of our dictionary. But the user may also pass a word that doesn't exist at all and it doesn't have any similar matches there like that. So basically you have three scenarios. The user enters the exact word like rain and immediately you return data so with that particular key. That's the first scenario. The second scenario is when the user enters a word that is very close to one of the words you have in your dictionary, so like rain with an extra N. In that case, you want to return the first item of the list that the getCloseMatches generates. And the third scenario is when you get an empty list, which means that there is no such word or similar to that in your list. And so we have three scenarios, which means we need to sort of apply three conditionals in the conditional block here. At the moment we have only two, so we need one more which says, did you mean this word? So please double check it. For now we we'll just pass a message and also note something. You may also want to pass a higher cutoff value there, like 0.8, because sometimes if this is a low, like 0.5, and you pass like some random word, that will suggest you a few words which maybe you don't want. So you may want to play around with that. In that case, you get an empty list. I think I'll use a 0.8 value for the cutoff when I implement it in the script here. So let's go to our code. The first thing we need to check is if the word is in data and return the value for that word. You may ask, what if you want to check for similarities first and not this? Well, I think the first conditional you need to apply is the one that you think will have more occurrences. So if you think that most of the users will enter the correct word, then you need to check for that conditional first. You don't want the program to go through the conditionals that have less probability to happen. So you first want to go through this, and then the others are ignored if this returns to true. If this doesn't return to true, if it's false, then you want to check for another conditional. And when you check for more than two conditionals, you need to implement the elif statement. So for multiple conditionals. And so we need to we need to check whether this list is empty or not. So if it's not empty, that means we got a match in the dictionary. In that case, we want to suggest that match. We want to mention that match in the message. So which means that if get close. Sorry. Let me import it first. From diff-lib import get close matches. So if elif get close matches with the word given in data.keys, like that. So this is a list object, right? That's the same thing as this one here. So this is a list object, and you want to check whether the length of that list is greater than 0. If it is, you want to return a message. Let's say, did you mean? We use a string formatter here, %s. I'll explain what that is. Instead, did you mean that instead? And after the string, after you have closed quotes, you use the percentage operator, and here you pass a variable that will replace this formatter inside this string. So this will be replaced with whatever variable you pass override to this here. In our case, we want to pass get close matches for w and data.keys, and you want to get the first element of that list and put it here. So this is to understand it. Let's say we have a variable which has a value of 1, and you say, hey, s, like that, %a, and the %s will be replaced with 1. That's the same what we're doing in here. And yeah, that's all we have to do. Else, so if this evaluates to false, and this evaluates to false as well, then what that means is we're dealing with an empty list. So the user entered a word that didn't have any match in our dictionary and didn't have any similar word in our dictionary. So you want to return the word doesn't exist. Let me save the script. Go to the terminal, the upper arrow key to call a previously executed command. So Python 3 app1.py, execute, enter a word. Let me start with a correct word, rain, and you get the definitions for rain. Let me execute again, rain with an extra n, and yeah, we get this message, did you mean rain instead? So the %s was replaced with the first item of the list returned by get close matches. And again, if you pass a very random string there, it says the word doesn't exist, please double check it. And yeah, that's it. However, I still see an issue with this, so we still can make the program more user-friendly. The problem now is that when the user enters like rain by mistake, what you say, you just pass a message there saying that, oh, did you mean rain instead? Oh, yes, I mean rain, but how can I enter rain? Why do I have to execute the program again? So I'm thinking of a solution where instead of just passing a message here and ending the program, instead of that, you execute another input statement. So another input statement, another input function like this one in here, where you ask the user to enter, let's say, y if they meant rain, or n for no, so y for yes, n for no, if they didn't mean rain. So if yes, then you basically pass, you return the value for the rain word. If they pass no to the input message, then you say sorry if that's not the word that you meant, then we don't know what you have in mind. So we say the word doesn't exist, please double check it. And that's what I'm thinking. And yeah, think about this, and I'm going to implement it in the next lecture. Talk to you there. Great, as I mentioned previously in the previous video, now we're going to implement an extra input, user input message into the program. So instead of returning this string, basically what I want to return is an input message. So if the program finds out that the user passed a word that has a similar words in the dictionary, then you want to ask the user to enter Y or N. So how do we do that? Well, with an input function, of course. Like that. So let's add another message after this. Enter Y if yes, or N if no. So basically, whatever the user enters, you need to process that input. And that input, so Y or N, they will be basically stored in a variable, but not yet. So in this configuration that we have here, nothing will be stored in the variable. It will just be a value on the fly. So you need to store this in a variable. Let's say yn, so for yes and no, equals to that. So now either y or n will be stored in yn variable, and you need to process that variable. So if yn equals to yes, what do we need to do? So if the user meant to say rain, then we return data. Here we need to pass the correct word. The correct word, we get the correct word from this expression. So get close matches will give us the best match, and we need to pass that match into the data dictionary so we get the value of the definition for rain. Because so we use that match because the user agreed that the best match was rain. So this will be replaced by rain, and the user agreed for that. I hope this is clear. Please ask questions if this is complicated. I'll be happy to answer you. So if yes, then return this. Let me execute this intermediate step. Oh, sorry, I used the equal operator here, which is an assignment operator. So you need to check to use the comparison operator, which is constructed of two equal operators. Save the script again and go ahead. Enter word rain. Did you mean rain instead? Enter Y if yes or N if no. Let me enter Y. And yeah, we correctly get the definitions for rain. Great. Maybe I need to improve the message here. Delete the dot and use a colon there and a space. And that should be better. If you pass rain again, and if you pass yes or no, you just say N, you get none, because you are not taking into consideration the N string. So you get none because the function is not returning anything. You know what happened here is user passed rain in here. So word is equal to rain. Word is passed in here. So this y is equal to rain. And then we check if rain in data is not in data because it's with 2n, right? So this is not executed. The function does not execute this statement. It doesn't return the definition for rain, but it goes to this statement. And this finds a similarity, so the list is greater than 0, and then it goes and executes this. So that's why we got this another input message here. And then we continue there. So we are indenting under elif, we have another nested conditional, which is no problem. But yeah, be careful, you need to indent it. So this is one level of indentation deeper than this one in here. So here we are. If the user passed y, we return this statement. If the user passes everything else, then you are not counting for that particular scenario. Therefore, there is no return statement executed, so the program will end here and it will return none because nothing was returned. This will also not be executed because this is one level of indentation with this one, and since this was executed, the program never goes to this level here. So what we need to do is we need to count for other user inputs such as n. In that case, if the user enters n, well, all we can do is return the message word doesn't exist. Please double check it, which is the same as this one here. And we need to count for another condition. You know, the user may pass y, may pass n, but they may also pass another random string, and you don't want the program to return none. You want the program to return a message such as we didn't understand your query. And that's it. That's all you can do. Or your entry. Maybe that's better. So this is a program. Again, we have a scenario where the user enters rain, exactly, and this will be executed in that case. And the scenario when the user enters a word which does not have any match. So A is D, like CA, 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 C, something like that. In that case, this will not be executed. And yeah, that's it. Let me test the program now. Enter word rain. We get the definitions for rain. Again, enter word rain, like that. Did you mean rain instead? Enter y if yes, enter no if no. Let me try yes. And we get the definition correctly. And rain. Enter n for no. The word doesn't exist. Please double check it. Okay, that was good as well. So we got this executed. The other scenario would be like that. And instead of entering y and n, you just type in something. And you say we didn't understand your entry. Good. And the other scenario is when you enter a word that does not have any match at all. And in that case, this will be executed immediately. And that's it. By the way, even if you enter numbers, let's say 1, the word doesn't exist because it's not included in the dictionary. And yeah, I think our program is quite smart now. It's considering lots of scenarios there, and yeah, it's quite user-friendly, I'd say. However, there is one last thing that we can improve, and that's the way that the program displays the definitions. So when you pass, let's say 3 also has two definitions. Let's pass a word that has one definition. Structure, maybe. Oh, this has 3 definitions. All right. Pyramid. This also has 2 definitions. Anyway, you get the idea. I was trying to get to find a word that has 1 definition, but basically what you get with such a word that has 1 definition is you still get a list which ends in here, so it doesn't have a comma and it doesn't have any other items, so it's a list with 1 item. And when you have a word that has more than 1 meaning, you get this list with more than 1 items. So you don't want to show the user a list with brackets like that. The best thing to do to show the user is, if you have 1 meaning, 1 definition for the word, you just show this definition, no quotes, no square brackets, just the definition. And if you have more than one definition, you only show one definition per line. So basically you have like multiple lines with definitions. And yeah, we need to implement that too to say finally that our program is good and can be used by anyone, and the output is easy to read. So think about that. We're going to implement it in the next lecture. See you. Great, we have a working program now, and we added every feature that we wanted. The only problem now with the program is that the output is not very user-friendly. With that, I mean, let's say yes here. So this is the output, and you get a list here. So it's a Python list. And what we want to do instead is we want to show each of these lines in one separate line in the terminal, so that output will be more readable to the human eye. And let's go ahead and do that. So how can we implement such a thing? So this output now is a list object, which means that the call here, the function call, this produces this list object. And so what can we do is we could maybe iterate through this list object. Something like we can store the list object in a variable, so output will be assigned this list. And then what you can do is you can say for item in the list, in the output list, print out the item. Let's save this and try out. We're going to have an issue here, but one step at a time. Enter y, yes, y. And so this is what I wanted to have. So the first definition, precipitation in the form of liquid water, goes in the first line, and the second definition, to fall from the clouds in drops of water, goes to the second line. So that's good. However, we should keep in mind that our program does not produce only lists, but sometimes it produces strings as well. So such as this one in here. No, I didn't mean that. Anyway, so this is what you get, and you don't want that. This is a message saying that the word doesn't exist. So what the program is doing, what Python is doing, is it is iterating through every type of output that the function generates. So our function generates a list sometimes, and sometimes it generates a string. How can we fix that? So we have a list and a string. Let's think of a difference. How can we discriminate a list from a string? What's the difference between a list and a string? Well, the difference is clearly a data type. A list is a list object, and a string is a string object. So how about implementing a conditional here, which says something like this: if type of output is a list, then indent this with 4 spaces and that one as well. So this loop now is nested inside the conditional and will be executed only when this evaluates to true. So only when we have when we get returned a list from the program. So else, if it's not a list, it has to be a string. So in that case, we want to print out the output without iterating through it. So let me check. And we get the output correctly this time. The message, the word doesn't exist. Please double check it. Let's check another time with a correct word. And we get the correct definitions in there. Let's try another word. Mathematics. And this time the mathematics word has only one definition, so we get the definition printed out in here. So it's a science. Let's try the other scenario as well. Rain. Did you mean rain instead? No. The word doesn't exist. Please double check it. So we got this line here executed. So yeah, this is the complete code. And I think we can consider our program complete now. So that's what I thought of adding to the program. Now the program is quite user-friendly, and we are considering many scenarios there that the user may input to the program. However, the interface is still a command line interface, so it's not a desktop graphical program and it's not a web application. The interface is the command line, so you send input through the command line and you get output through the command line. And what I'm trying to say is that you can actually extend this program so that you can transform it into a web application where the user, instead of entering the input through the command line, they can enter input through a web page. So through a live website, they can enter input, push a button, and then get the output dynamically on the HTML web page. So that is possible with Python, but you're still not ready to do that because we have quite a few more sections to go. We have some applications where I'll teach you how to develop web applications with Python. And after that, you can go back to this code and extend it and create a web interface. And also you'll be able to create a desktop graphical user interface with the knowledge that you'll gain through these sections, because we're also covering graphical user interfaces in the course. And also we are also covering databases. So why I'm mentioning databases? Well, because in this program we're using this file where to store our dataset. The problem with this is that if this gets too big, for now this is just 5 megabytes, oh that's good. But if the file gets too big, then you need to load the file in Python every time you execute the script. Like here, we are loading the file into the Python session when you execute the script. Now, if the file is too big, that will be very costly in terms of time. So what you want to do instead, you want to use a database, maybe. With a database, what happens is that you make a query to the database, and instead of getting the entire dataset, you actually get only that row or that value which you queried for. So databases are very efficient, and we'll cover databases later in the course. And so after a few sections, I'll get back to this program. I'll give it to you as an exercise so that you can extend it by creating an interface, a graphical interface for that, or a web interface. And also I'll give you access to a database where you can query data for this program so that it becomes a real robust with a very friendly user interface. So I hope you like the idea, and I hope you are enjoying the course. And yeah, let's move on with some more sections. I'll see you later. Bye. Hey, welcome to this new section. And in this section, you will learn how to use pandas, which is a very important Python library, and you really don't want to miss that. So what is pandas? Well, pandas is a library providing data structures and data analysis tools within Python. Or if the word tools confuses you, then you can say pandas is a library providing data structures and data analysis code. So basically, pandas allows you to load data from different sources into Python and then use Python code to analyze those data and produce results, which can be in the form of tables, text, and also visualization with the help of visualization libraries such as Bokeh. Bokeh, which is covered later in the course. So for now, we'll focus on data without visualizing them, and pandas is great for that. So practically, how do we use pandas? Well, you learn how to open text files using Python built-in file handling methods earlier in the course. Now, what we opened from text files was just plain text. But what if you want to load text files with data constructed of rows and columns? So things get a bit complicated. But here is where pandas comes into play. So you can probably do that using built-in Python methods that we have learned in the course. But to be more efficient, and to be much more efficient, you need to have a high-level library such as pandas, which is able to recognize such data structures automatically. So I use pandas for loading data from data mining activities such as web scraping. So you scrap data from a website with Python and then store those data in pandas data frames. So you use pandas to provide data structures for you in Python. And I use pandas for loading data from Excel files, and also use pandas for analyzing those data instead of using Excel. Excel can be good for analyzing a small table of data that fits in your screen, in your computer screen, but for data larger than that, you really want to use code. So you write Python code once and then you use it with other data as well. And you don't want to do selections and dragging and many other cumbersome operations that you normally do in a graphical based program such as Excel. So code is the way to go if you want to be efficient with data. And Python is great for that with pandas. So you really want to get a good hang of pandas, and you will learn that in this section and also practice it with real-world applications that we'll be building as you progress through the course. Now that's enough with words, let's go ahead and install pandas. And you want to open the terminal, and the process is straightforward. You say pip install pandas. Now I mentioned that pandas is a high-level library, and pandas is based on NumPy, which you can see in here. So pandas is now trying to install NumPy, because without NumPy you cannot use pandas. And NumPy is a more low-level library than pandas. We'll cover NumPy later on, but I wanted you to know pandas first, because that is more easy to understand. So once you know how to use pandas, then we think about NumPy, and I show you how NumPy is the base of pandas. So let's not think about NumPy now. And yeah, this was successful, but if for any reason it wasn't successful on your side, and I know that in some Windows distributions you may get an error such as this one here. So it says unable to find this bat file. And that happens because pandas is trying to compile itself, but it cannot find a compiler. So in that case, the easiest solution that you can do is to use precompiled Python libraries, which you can find in this case in this website. So they are provided by Christoph Gölke. And yeah, you want to locate NumPy first. So here is NumPy. You click that and that goes down here. And then you want to pick up your version. So if you have Python 3.5, you'd want to go for this CP35. And then you have 32 bits of Windows and 64. So you want to pick your own bits. And so what you do is you download that. And that is a wheel file, which is the same file that you install with pip. But with pip you download it and then you install it. In this case, the download is being done manually, and then we point to this file with pip again to install it. I'll show you how to do that. And yeah, once that file is downloaded successfully, I've put it in here in my C drive, CPP, and then you want to either cd to that directory, and then use pip install, and then start typing the name of that file, and tab to get the complete file name. And yeah, now you should press enter and that will install NumPy for you. Once you're done with NumPy, then you go ahead and get pandas as well. Pandas, yeah, these are the distributions. Again, you get 3.5 if you have the 3.5 version for Python, and the Windows version as well, and you repeat the same process. And yeah, I hope that is clear. Once you install pandas, then you can simply go ahead, import it, and if there's no error, then you're good to go. So that was about an introduction to pandas and how to install it. Let's go ahead and dive into some code now in the next lectures. See you. Great. Again, Pandas is a library that provides data structures and data analysis tools in Python. So in this lecture, you'll see what I mean with data structures and data analysis. So you'll see the main pandas object, which is a structure that contains the data. And you'll see that how we get data from this structure and analyze them. So I'll open a simple command line. And for now, we'll use IPython, which is great for data analysis and working with data. But even better is Jupyter Notebook. Jupyter Notebook is like a Python shell. It's actually a combination of a Python shell and a Python editor. And it's a browser-based tool where you can write Python code. And it's very efficient, so it really boosts your productivity. But for this lecture, I want to start with simple things, so one step at a time. And I'll introduce you to pandas using IPython only. And then in the next lecture, I'll show you how to set up a Jupyter Notebook, previously known as the IPython Notebook. So you'll set up Jupyter, and I'll show you how to work with Jupyter. So for now, let's go ahead and use the plain IPython console. Import pandas. And yeah, normally the first thing you do is you want to import some data, let's say from a CSV file or from a text file, or even an Excel file or JSON or other formats, which we'll be covering later. But there are also other ways to create a pandas data structure. And now the first thing you should know is that this data structure that I'm talking about is called a data frame. So that's a special object that will hold the data. And you can create one. You can store a data frame in a variable, let's say df1, pandas data frame. So I'm creating a data frame manually, passing values manually via Python. Normally you want to use other files, like I mentioned. So data frame, and now think of the data frame as a table. So you may want to pass a list of lists, where each list will be a row of that table. So let's pass some data there, 2, 4, 6, and 10, 20, 30. You execute that, and that was successful because you didn't get an error. df1, and here is the data frame. So 2, 4, 6 is the first row, 10, 20, 30 is the second row. And these 0, 1, 2 are the names of the columns. And these are referred as indexes. So 0, 1 here are indexes for the rows, and these here are the column names. The beauty of pandas is that you can also have your own column names, if you like. So I'm gonna call this expression again, and I want to pass here a parameter called columns, that expects a list of names, which has to have the same number of items with the number of columns that your data frame has. So if you pass list with 3 items, you want to pass 3 columns here as well. Let's say price, something random, age, and value. You execute that, and let me expand this. df1, and this time you see that you have your own column names there. Now similarly, you can pass custom names for the indexes as well, by passing index as parameter, and then you'd want to pass a list with 2 items because we have 2 rows only. Let's say first, second, df1, and you have custom indexes. However, normally you won't have to pass custom indexes. Data normally have a defined number of columns, but the rows, you may have hundreds and thousands of rows or millions there. So you really don't want to mess up with index names. However, the feature is just that, in special cases. So there's one way to create a pandas data frame, and you also have other ways as well, which are not very common to use, but I just wanted to know that they are there. So again, you pass a list here, and then what you could do is you could pass 2 dictionaries inside that list. So you can see the similarity. Here we used a list of lists. Here we are also passing a list object, but it's a list of dictionaries. And yeah, what you could do here is You could pass values, keys and values for the dictionary, and here as well. So let's say name John, name Jack. Execute that df2, and yeah, this is yet another data frame. If you wanted to have more columns there, such as surname, you would want to add here another key and value for the dictionary. So something like surname, and now if you execute that and df2, you'll get the surname column added there. But for Jack, you get none because you didn't pass a surname in the dictionary, in the second dictionary. So if you do the same for Jack, if you pass a surname, you'll get the value in here. So those are two basic ways to build data frames on the fly. And as I said, normally these values will come out of files, of CSV files, Excel files, etc. I will do that throughout the next lectures. And one more thing I want you to know is, so this is a data structure, and now what data analysis means is, out of this data structure you want to get out information. So you may want to extract, for instance, the average of all these values. So 2, 4, 6, 10, 20, 30. So here we enter the phase of data analysis. And the approach to do that is, this data frame object now, which you can see the type df1. So it's a data frame of pandas. Now this data frame object has methods attached to it. If you do dir, and yeah, you see that it has quite a lot of methods that you can apply to it. Let's locate the mean method there. Here is mean. So what you could do is you point to df1 and then mean and brackets, and you get the mean of all the columns. And if you want the mean of the entire data frame, you could apply again the mean method after that. So what this does is it applies the mean method over this series here. So this type is a panda series object. Series have more or less the same methods that you can apply to a data frame. So df1 and df1.price, and you get the series of the price column. So that is also, if you check the type, that is also a panda series. So a data frame is made of series. And of course you can apply the mean method to price as well. And similarly, you can apply other methods as well that are available there. So max, and you get the maximum value. And yeah, that's about the introduction to pandas. In the next lecture, you will learn about Jupyter. It's very pleasant to work with Jupyter, so don't miss that. And then we'll go ahead and open data frames, create data frames out of files. So I'll see you later. Well, in this lecture, I'll show you how to set up the Jupyter Notebook, or Jupyter for short, and also how to use it. So far, you've worked both with a Python or an IPython interactive shell, but also you've worked with an editor such as Atom. Sometimes you may have the need for a hybrid between an interactive shell and an editor, when you want to test things out, but you also want to save your blocks of code that you're writing. Because an interactive shell is great for testing things quickly, but you can save the code, and the editor is good for saving the code, but it's not great for testing things. But I can tell you that such a hybrid tool exists, and that is called Jupyter Notebook. And that is an amazing tool that will boost your productivity. And Jupyter is especially good when you're working with data, as it's a great environment to explore data, and you'll see its usefulness in just a bit. Of course, you still want to use editors such as Atom when you're working with multiple Python scripts that interact with each other. That's the case of web application, for example. When you're developing web applications, you'll have to deal with multiple Python scripts and also HTML files, CSS, and other files as well. We'll build a web application later in the course, and you'll see how Atom is good for that. But for data, use Jupyter. So Jupyter, let's see how to install it. Well, you can go to the installation, so install, and you can go through these instructions. But instead of going through this, I would advise you actually to use your command line to install Jupyter and typing pip install Jupyter. So that will download Jupyter and it will install it in your system. And then to start a Jupyter session, a good practice is to go to a folder. Let's say test3. And here you can open a command prompt. And then you type Jupyter notebook. And that will open a Jupyter session in the browser. So the Jupyter notebook is actually a browser notebook. The reason I opened the Jupyter notebook in the command line was that at least on Windows, when you do Shift and then right click on a folder, your command prompt is opened in the current folder. So in this one here. And then when you create a notebook file now, every file will be saved in this directory here. Alternatively, you can open your command prompt everywhere you want, and then you can cd to the folder where you want to save your Jupyter notebooks. Alright, now we don't have anything here, so what you can do is create a notebook. And we install Jupyter as a Python library, so under notebooks we have Python 3 available. So the kernel will be Python 3. If you have associated other languages here, you'll see them under here, under notebooks. So this is an empty notebook. And this is the name of the notebook, and you can change this to, let's say, testing. Press OK. And if you go to the folder, you'll see that a file with a testing name and IPython notebook extension was created. So that is created automatically every time you type something here, you do some changes or something. Now let me show you how you can work with the IPython notebook. So you can consider every cell, this is a cell, and you can consider every cell as a line in a normal Python shell. But here in this shell, you can actually write multiple lines of code. Let's say print 1, and then if you don't want to execute this right away, you can press enter. So with enter, you enter a new line in the cell, and then print 2, and so on. And if you want to execute the cell now, you can press Ctrl enter, and you get the output. Now if you want to create a new cell, Alt enter would do that. And here you can write another block of code. With enter, you go to the next line, and so on. And if you want to go to the next cell right away, so before we pressed Ctrl enter, now you can press Shift enter and you go to the next cell automatically. And with Shift enter, you also execute the cell where you were working on. You can create new cells with Alt enter, and you can delete them by pressing first you press escape, and then you press DD 2 times. DD again. So it's quite flexible. Something you should notice is that we have two modes, basically. We have the command mode. So when you are in the command mode, you see a gray rectangle around the cell. And when you are to go to the edit mode, then you press enter. So while you are focused on the current cell, you press enter, and then you edit the cell. So in edit mode, when you type things, you're inserting text in the cell. You're inserting code in the cell. Escape and command mode, DD, and you delete the cell. Alt enter and you enter a new cell. So these are the most used shortcuts, keyboard shortcuts. But if you want to know more shortcuts, you can go to help and then keyboard shortcuts, and then you see a list here. But these are good to get started. When you're done with this, you can just close a tab, and you can also close the directory tree here. So notice that Jupyter actually opens in a localhost session, and if you want to open again your notebook, so you can go here again and go to open command window here and Jupyter notebook, and here is the file, and it's just as we left it. Now, a Jupyter notebook is best used for doing explorations, and especially data explorations. So if you're working, let's say, with data analysis or data visualizations, the Jupyter notebook is perfect to use. You can use the Jupyter notebook, for example, to load a table of data in the session. And for that, you'd use pandas. So you import the library, you press enter, or shift enter to go to the next cell, and you press enter again to write something. So let's say df equals to pandas.read csv, and I have a csv file somewhere in my system. Press enter and whoa. So you get a nice HTML table which was loaded from the CSV file. And you can also plot graphs in the Jupyter notebook. So that's also something you're learning in the course. And so data analysis and visualizations, you can also use the Jupyter notebook for web scraping. And that is very convenient because you have these blocks of code, and then you have to continuously tweak the code. So you may want to change something here, and then you get a nice display. Not this one exactly, because this is a messed up string, but this one, for instance, you have a slider here, so you can scroll up and down inside a separate window that doesn't affect your your main window. So I hope you've gotten a good idea of the Jupyter notebook. Just take a note of the shortcuts, of the keyboard shortcuts to execute code, the edit and the command mode, enter, escape, and enter again, and so on and so forth. And you just practice them a little bit, and you'll get used with Jupyter very quickly. See you in the next lecture. Great, now that you have a basic understanding of pandas and you know how to use Jupyter notebooks, we can go ahead and learn how to load various kinds of files in Python using pandas and Jupyter. So I've got 5 files here. They contain exactly the same dataset, and this is a text version, or let me open the Excel version that will show a pretty overview of the data, as you can see. So we've got 7 lines of code, including the header, and we have also 7 columns. So it's just some basic data of supermarkets, so the address, city, state, country, and the name of the supermarket and number of employees. And similarly, we have exactly the same data, but in different formats. So we have CSV, and CSV means comma-separated values. So it's basically a text file where the values, the columns, are separated by commas, as you can see here. So every column is separated by a comma. But it has a CSV extension, and it can be opened with Excel. So if I open this now, you'll see the same dataset that you saw in the XLS file. We also have the same data in separated by semicolons, as you can see in here. And yeah, if you're working with data, you're probably familiar with these kinds of files. So this is how to store data. You need to have some conventions, and using such convention, then you use other programs such as Python to load these data. So when you load a CSV file, Python knows that the values will be separated by commas, and it knows how to separate them. It knows how to extract values. So we'll open all these one by one. We also have a JSON file, which is yet another format to store data, and looks like a Python dictionary actually. So we'll learn how to convert them to a pandas data frame as well. So all these will be converted to pandas data frames. Yeah, I'll go ahead and start Jupyter notebook. Here are my files. I'll go ahead and create a new Jupyter notebook for Python 3. Before I go ahead and load those files in Python, there's a trick I do usually. I import OS and then os.list there and Alt-Enter, execute that. You go to the next line, and what you get is you get a list of files and folders as well, of file names that you have in the current directory. So now I don't have to switch to my folder to look at the names. I have everything in here. Now I can go ahead and import pandas. And let's start loading these files one by one. Let's say df1, so data frame 1, and that would be equal to pandas.read CSV. And then you have to pass the name of the file that you want to open. Supermarkets.csv, and just enter. And maybe you want to print that out, so df there. And we got an error. Let's see why. It says supermarkets does not exist. Yeah, I forgot an R here. Just there, and this time it worked. So dd to delete that cell. Yeah, what we got here is, so we loaded the data frame first and then we printed that out, so that we got this table, nice table in there. That's how easy it is to load data from CSV file. Now, if you see this, this is in bold, this first row there. And that's a special row, so that's the header of your data frame. And Python pandas was able to automatically recognize the header from your file. So this method, the readCSV method, has a header parameter, and that is set to true by default. But if you want, you can set it to none. And that's how you tell Python that my data don't have a header. So what Python will do is it will treat your first row of your file as a simple row. So it will just dump it amongst the other rows. And what it will do, it will create a default header for your data frame with numbers. So I'm going to remove this and leave it as it was. Notice that we also have an ID column there, which if you want, you can use it as an index for your data. So if you want to use ID as an index instead of letting Python define your index, what you do is you apply the setIndex method to your data frame, and then you say ID there, execute. What Python will do, it will search for the column with name ID and it will set it as an index. df.1 shape, if you want to know the shape of your data frame, so you get 6, 7, meaning that you got 6 rows and 7 columns, including the ID column. And yeah, that's how you load CSV files. Now let's go ahead and load df2 pandas. What's next? Well, next is JSON. So instead of doing read CSV, you want to do read JSON. And then you just pass the name of your JSON file, including the extension, of course. I executed that, I forgot to print that out. So this is a JSON file. And similarly, if you want, you can set the index to ID and execute again. And ID is set as an index. Now you can also notice the order of the columns is not the same as the previous CSV file that we opened, which is not a problem. Every column has its own name, its own identity, so having columns without an order is not a problem. And let's go ahead and load the XLS file, XLSX actually, an Excel file. So pandas read Excel, and You pass the name of the Excel file, and normally you should also pass another parameter here for Excel files, because Excel files might have multiple sheets inside them. So you want to specify the sheet name, which starts from 0, so you need to pass the index actually. If you want the first sheet, you want to pass 0. If you want the second sheet, you want to pass 1, and so on. So I'll pass 0 there. I had only one sheet in the Excel file. df3, execute. And we were able to successfully read the Excel file as well. Let's move on with the txt file. So it's a supermarkets separated by commas. So it's a data structure separated by commas. For that, so for txt file separated by commas, again you use read CSV. Just like that, df4, and here is the data frame. So this supermarkets.csv, actually, some say it's a comma separated file, but to be more accurate, you would say character separated values. So C is for character. And there might be different characters there. In this case, when you have commas as separators, you don't have to pass any separator parameter here. But when you have other values as separators, you will have to pass that. That is the next scenario. So df5 pandas.read CSV. So we're talking about supermarkets semicolons. Supermarkets semicolons .txt. And let me try this as it is now. So if I execute that, Python will not be able to recognize the semicolon there. The reason to that is because the separator parameter has a value of comma by default. So you want to change that to your separator, which is a semicolon in this case. Execute. We got an error there, unexpected keyword argument separator. So it seems like read_CSV doesn't have a separator parameter. In that case, you want to ask for help. Here is the parameters that you want to pass. So it's actually a sep, and you can see that the default value of sep is a comma. So close that and go here, change that to sep, execute, and here is the data frame. Great, what's left to do? We consumed everything, and that's about reading local files. Now, Pandas also allows you to read online files directly from the web. For instance, here we have a CSV file in this website. So I browsed to that, and then it was downloaded. And if you want, you can go ahead and put that in your Jupyter folder and then open it as we did. Or you can grab this URL, go here, say df6.read CSV, and then pass the URL just there. df6 to print that out. And boom, here is the file. So it's the same, exactly the same CSV file that we opened earlier up, but we were able to get it from the web. And similarly, you can get other files as well, JSON. You can pass it as URL. Just there, and print that out. And here is the file. So this can be very useful when you want to automate things. Let's say you have some data from a website, from a data provider. Or maybe you have multiple files and you want to write a loop in Python that accesses these URLs, and then it gets the data, and also you then analyze the data and so on. So that's about loading data in Python via Pandas and using Jupyter. So I believe you find this very easy. And we'll move on and do some data analysis in the next lectures. So I'll see you there. Alright, now that you know how to load data in Python via pandas, and you know how to do that using different data sources, as you saw CSV, JSON, text files, and Excel, and now you want to understand how and learn how to manipulate these data frames. And by manipulation, what I mean is deleting rows and columns from your data frame and adding new rows and columns, and also modifying existing rows and columns. So that's what you're going to learn throughout these lectures. But first of all, I'd like you to understand how data frames are indexed. And with indexing, I mean, we have this data frame here, and this can be a big one. So this happens to be a shorter one with only 6 rows. But if you have big data frames with lots of columns and rows, then you may want to extract information out of that data frame. And to extract information, you need to have like a coordinate system in that data frame, like an embedded coordinate system. So that if you want to access, let's say, from here and 15 to, and then maybe this other portion, so these 2 rows here, this portion in here, you want to know how to do that. So that's what you're going to learn now, how data frames are indexed and how you can slice them. So let's try to extract that portion of the data frame. Let me create some empty lines here. I don't want to confuse you with that data frame, so we're working on this one. And yeah, df7. And what you want to apply now, there might be different ways to access that portion of the data frame. The first way is to use label-based indexing. The other way is to use position-based indexing. So your data frame has column labels and index labels. So these 1, 0, 1, 2, 3, 4, 5 are index labels, and these are column labels. Now, these, the index label, in our case, it's a bit confusing because normally it can be text, such as, let's say, in our data frame, the address is a unique column which you can use as an identifier. So if you want, you can set that as an index. Address, execute. And now you see that this is in bold. So the first column is in bold, meaning that this is the index column of your data frame. So now you can use labels from your index column and labels from your header, your column names, to access portions of your data frame. Just be careful though, because with this operation that we just did here, if you print df7 now, df7, you'll see that you still have the old index column in there, so 0, 1, 2, 3, 5. The reason to that is this set index method, as many other methods in pandas, is not an in-place operator, meaning that all this will do, it will spit out an updated data frame, but it will not store that data frame in your variable. So the variable, the data frame, remains the same. It just prints out a new data frame on the fly, just for printing purposes. So what you want to do to store that is you create a variable, which can be the same variable as this if you just want to update your variable, but it can also be another variable like df8. I'll just want to update the existing variable like that, and that will not print out any output. So you want to do that manually, like this. So now when you print df7, you see that df7 is updated with this address column as an index of the data frame. So be careful with in-place operations. You can see that df.set index question mark to ask for help. Oh, sorry, it should be df7 set index. And you can see that you have this in-place parameter there that is set to false by default. So which means you can also pass in place after this and set it to true, and that will update the existing data frame without the need to save the data frame to a new variable. But I would recommend that just get used to creating new variables when you apply methods to your existing variables, existing data frames, and it should be good to go. delete that, and yeah, let's get back to our original purpose now, which was to slice this portion of the data frame. I will first do it using label indexing. With label indexing, you want to use lock in there, so the lock method. And then you pass square brackets in there, and then that gets two elements. And the first element could be a range of the index column. So we're talking about labels, about strings, so you'll have to pass, 735 Dolores ST, then a range, so with a column there, 332 heal ST, and then from country to ID. Execute that, and yeah, this is our portion. So when you use labels, you're including the first label that you pass there and the last one as well. So everything between those. And like here, country and employees is included as well, but ID also. And of course, almost similarly, you can access, single cells from your data frame, just like that. So the intersection between this index label and this column name is USA, which should be this one here. If you want all the USAs, then you just pass everything there and you get everything here. Which, of course, if you want, you can convert it to a list. So a simple list using the Python built-in function, which is list. And that's about label-based indexing. Now, this is not the common way to extract data from the data frame. More common could be to access data based on indexing, not based on labels. So to do that, you do df7, and instead of lock, you do ilock. That again expects two items. So the first would be the range of your indexes. Actually, let me print out the data frame here so that you can refer to that. So let me access from Dolores to 23rd Street. That would be 1, 2, 3, I believe, yeah. And also from country to ID. So again, 1, 2, 3. And yeah, you can see the difference now. The ID wasn't included there, and either was 23rd Street, because this is, as you do with list, this is upper bound exclusive. So with Python list, 3 is not included in the slice. But with labels, the last item of the range was included in the slice. So in this case, you want to pass 4 there and 4 there. And that's how you get your portion. And of course, similarly, you can do things like that. So you get all the rows or only one of them. So that would be a row with index 3, which is this one, but only 4 columns country, employees, and ID. So USA 10 and 4. Oh, right. That is position-based indexing. Now we have one more very useful kind of indexing, and that is combined indexing. So in certain scenarios, you might need to access a portion of rows without having to pass names for the rows. So you want to access rows based on indexing, based on their position. But on the other hand, you don't want to access columns based on positions. You want to access like a certain column, so which name you know about. So you don't want to count the column. And here comes in handy the IX method. So that allows you to enter a combination of indexes and labels. So that will return you the row with index 3 and the column with the label name. So you get Ben's shop. And you cannot do this neither with ilock nor with lock. That's why IX exists there. And of course you can put 2 positions if you like. So name would be 0, 1, 2, 3, 4, you get the same output, Ben's shop. Which brings us to the point that if you want, you can always use IX and forget about iLock and lock. But IX is not recommended over iLock and lock. So these are more explicit, and they will avoid errors sometimes when you do position-based indexing. So I also suggest you use iLock and lock whenever you can, and then switch to IX when you want to do these kinds of combinations between labels and positions. And yeah, that's what I wanted to teach you about data frame indexing and slicing. And I'll talk to you in the next lecture, where you'll be learning how to delete columns and rows from a data frame. See you there. All right, now you know how to extract portion of a data frame, but how about deleting columns or rows from a data frame? Well, for that, you'd want to use df7.drop, solid drop method. Note that this is also not an in-place operation, so your df7 data frame will not be updated with the deleted column. And yeah, let me delete the city column. You'd pass city for the column name, and then 1. And so the one argument means that you're about to delete columns. That's how you tell pandas or Python what you're about to delete. When you delete rows, you want to pass 0 there. So, and yeah, here, this is the on-the-fly data frame without the city column there. So again, df7 with city and drop. Let me drop 332 heel st 0. And yeah, Hill Street is not there. And of course, if you want to update your data frame with the changes, you do that. And then when you print out your df7 data frame, the Hill Street is not there. And yeah, if you want to drop columns or rows based on indexing, you do a trick like df7 and then point to index, and then what do you want? Well, 0 to 3 maybe. So you're deleting rows, execute that, and you get the 3 rows only. Similarly with columns, and 1 in here. So you get ID, name, and state, the first 3 columns. So if that confused you, df7.index, what that gives you is a series with the names, so with the labels of your index column. So all this. And similarly, columns gives you the names of your columns. So that's how you access the header of your data frame and the index column. And yeah, that was about deleting columns and rows from data frame. If you have questions, just feel free to ask them. And I'll talk to you in the next lecture. Good, we're continuing our series of lectures about manipulating pandas data frames. So you learn how to drop a row or a column out of a data frame in the previous lecture. Now let's see how we can add a column or a row to a data frame. So we have df7 here with address as index column and this series of column labels. Now just to clarify something, I know this is difficult to wrap up your mind how you'll be using these operations in real life. So I just want you to know the syntax of doing these operations. And throughout the course, you'll learn how to actually put this into work with real life examples. So don't worry about that. And yeah, let's add a column there. To do that, you'd want to say df and in square brackets, you pass the name of the new column. Let's say continent. That would be equal to, now you would have to pass a list of values that you want to populate that column with. Let's say North America. Now, if you execute that, you'll get an error. Name df is not defined. Actually, I didn't mean this error. This was another thing. You'll get this error. So it says that the length of values does not match the length of index. So the length of index is, length of index is df7.index. The length of your index is 5, but you're trying to pass their list with a length of 1. So you've got only one element there. So the solution here is to pass a list with the exact number of items that you have in your table, in your data frame. So we have 5 rows there, 5. And yeah, you could add 4 more items here, North America, etc. Or you can do some fancy things in there. So you could say df7 shape, then 0 times that. Execute, df7, print that out. And yeah, we have a new column. So if you're confused with this shape, 0 times North America, what I did is, df7.shape, what you get is 5, 7, which means you have 5 rows and 7 columns. Now what I want to get is the first item of that tuple. So I get 5 by doing shape 0. With this, I always make sure that I'm getting the number of the rows that my data frame has. And then when you multiply 5 by a list with 1 element, you get a list with 5 elements. America. That's the idea. Delete that. And note that this is actually an in-place operation. So that will update your data frame. And now that was about adding a new column, and how about modifying a new column? So modifying the continent column. That could be something like country, and you can also add some strings in there. Let's say plus, comma, plus maybe another string, North America. Execute that, print out the data frame, and yeah, see what we got. So what we did here is we updated the continent column by referring to an existing column, which was country, and then for each value of the country column, we concatenated the comma string, which you can see in here just after USA, and we also added another string, so North America. And this could also be another column if you liked. So if you passed here, let's say employees, you'd get 8 instead of the first North America, and then 15 and so on. So that's how you update a column. Now, how about adding a new row? Well, this can be a bit tricky, but still understandable. What you could do here, because there's no easy method to pass a row to a data frame, what you could do is you could say df7t, so I'm creating a new variable, that would be equal to df7.t. So t actually is a method that what it does, it transposes your data frame. And with transposition, I mean, df7, if you check your new data frame, what you get is this. So your rows have become columns, and your columns have become rows. So spend a few seconds looking at this. Yeah. And what we can do now is, we can use the same syntax, df7t, and then add a new column in there. So for the name of the column, you'll have to pass an address. Let's say my address. Now that would be equal again to a list. And you want the list to reflect this order. So city first, let's say my city, country, my country, and 10 for employees, and 7 for ID, my shop for the shop name, my state, and my continent. Execute that, df7t. If you look at this now, you'll see that you get a new column in your data frame. Now, what you do so to complete the trick is, let me say df7 equals to df7 underscore t dot t. So df7 now will have the new row added at the end. So let me wrap this up. Again, what I did is I transposed the original data frame, df7, And then I added a column there. And now if I transpose the data frame back again to its original position, this column that I added will be converted to a row. And that does the trick. And similarly, you can modify a row if you like. So in that case, you don't point to my address, but you'd point to an existing column with an existing address name. For instance, this one, if I pass it here, execute that, and that, and you'll see that the values of this row with this address name have been updated now, as you can see in here. And that closes this lecture as well. And yeah, I'll see you later. And yeah, let's close this section on pandas by looking at a real-world example. And in this example, what we're going to do is we're going to grab the address of each of these rows that we have in the data frame. We're going to convert it to a latitude and longitude coordinates. So geographic coordinates, in other words. Now, addresses, they define a unique point on the Earth. So if you pass this address to some service, let's say you throw it on Google Maps, and Google Maps will point you, so it will generate a marker that will tell you where this point is located. Now, on the background, that marker actually has a pair of latitude and longitude coordinates. And every point on Earth has this pair of coordinates. And if you follow the section on building web maps with volume in the course, then you know what these latitudes and longitudes, how they come in handy when you build applications such as web maps or other maps. Now, the process to convert from addresses to coordinates is called geocoding. And if you want to convert from latitude and longitude to addresses, that is called the reverse geocoding. In this lecture, we're going to be looking at geocoding. So basically, what we're going to do is we'll add here a column to the data frame, actually two columns, one for latitude and one for longitude, for each of the rows. Now, pandas cannot do that directly, so you need the help of another library that is called GeoPy. And you can install GeoPy with pip. So pip install and GeoPy. And just wait a while. Oh, great. And then, before going ahead and applying the geocoder to my data frame values, I'd like to actually convert a single address, an address string with geocoder. Something you should be aware of is that to use GeoPy, actually to use the geocoder, which is, if you say import GeoPy, and if you say GeoPy, like that, you'll see that you have a geocoder module among them, which is this one here, so geocoders actually. And for the geocoders to work, you need an internet connection. Because what geocoders will do, it will get your address and then it will send that to an online service that has all these addresses in a database. And then for your address, it will calculate the corresponding latitude and longitude values. So you need an internet connection. And yeah, what you normally do is, you want to import from geopy.geo coders import. Actually, there are a few geocoders there, but we will use Nominatum, which is a tool of OpenStreetMaps. And then what to do is, you create a Nominatum variable object. So you store that object in a variable. And that would be equal to the Nominatum class. So like that. And once you have that object, then you point to the geocode method of the Nominatum object, and you pass an address as a string in there. Let's say 3995, 23rd, then maybe the city, and the zip code, 94114. If you execute that, you'll get a location data type there. So all this. And what that includes is, it includes the address that you pass there. So this one. And it has also added United States of America, so the country in here. And you also get the latitude and longitude. And this one here, just ignore that. It's just a response from the geocoder. So it doesn't mean much. Now, sometimes though, it's rare, but sometimes you may get a non-object. So for instance, if you pass this address, which probably is not a real address, I'm not sure about that, I don't know. But if you say San Francisco, CA 94119, if you execute that, nothing will happen. And actually, you can see that if you store this in a variable and then print n, this will say that it's a non-object, so it doesn't have anything inside. So yeah, be aware of these scenarios as well. And yeah, we had our working address, this one here. Let's store that in this variable. And once you have that, to extract the latitude and the longitude, you apply a latitude for the latitude value and longitude for longitude. And that should do it, because n, type n is a special object. It's called a location object of GeoPy. So you need to apply those methods. And yeah, that's how you convert an address string to a location or to latitude and longitude values. But how about converting an entire column of a data frame into latitude and longitude? So we've got this data frame, df equals to pandas.read csv, so super.csv, and this should be an underscore. And let me import pandas first and print out the data frame. So this is our new data frame. Actually, this is the old one that we've been using. We have 6 addresses there, 6 rows with an address, a city and state and country. Now, the geocode method, more or less, it accepts this kind of format. So it expects from you the road name in here, and then the city, and the zip code in here, and the country. So what we can do is we need to construct such a column in our data frame first. And yeah, you can either create a new column or you can add it to an existing one. So let's say I'll edit the address, the existing address column. So that would be equal to df address, so this value in here, plus, well, I'll need a comma in there, so a comma and maybe a space, and plus df city, so a comma between address and city, and then another comma, and then plus df state again, and yeah, yet another comma, like that, plus again df, and lastly country. That should do it, df. And yeah, we've got a complete address column in there. Great. And now we need to send this string to the geocode method. And we need to do it for all the rows. Now, you're probably thinking of iterating, but with pandas, actually, you don't need to iterate. I mean, pandas is designed in a way that it allows you, it has some methods that allows you to apply a method or a function to all the rows of the data frame without having to write a for loop. And to do that, you need to create a new column. Let's call it coordinates, where you store the string. This string in here. So this actually it's not a string, it's a location object, but you can store it in your data frame. So we need to store locations for each of the rows. And the way you do that is, you point to the column that you want to pass to your geocoder, and then you use a pandas method called apply. So what method do you want to apply to the values of the address column? Well, that would be n. So n is a nominatum object that we have here. Oh, sorry, it's nom. Sorry. So that would be nom.geocode. And so the same as this one. So nom.geocode. But in this case, you don't pass brackets there, because the apply method will do it for you. So just like that, and then you print out the data frame in there and see what you get. I got a service timed out. The geocoder is not working properly. Maybe I have a problem with my internet connection. So if you get this long error, that is not your fault. It's a problem with the geocoder, with GeoPy. I'll try that again. And yeah, this time it worked. It was able to fetch the location objects in here. I mean, you cannot see the latitude and longitude because it's a long string. But if you do it like that, coordinates, you get the series for coordinates. And yeah, that is not showing it either. But you can do it like, df coordinates, and then you access the first item only, like that, and then you get the entire text for the location. If you want the latitude, you get latitude only. And that brings us to the point that you may want now to add another 2 columns in your data frame, where you fetch the latitude and the longitude values. So our data frame is this one at the moment. And what you could do is, you could create a latitude column in there that would be equal to df coordinates apply. You cannot apply latitude directly in there because you'll get this kind of error that says series has no attribute latitude. So you're applying a latitude method to a series, but a series doesn't recognize that. What series recognizes is the apply method. So there you can write your other methods. Now, latitude will point to the values of this coordinates column, and in such scenario, you use a lambda function. So which is an inline method to build a function. So you'd say lambda x. X is a temporary variable there. You say x latitude. And yeah, let's keep it like that for now. Df there. And let's see what we got. Well, it says that a non-type object has no attribute latitude. So this can be quite tricky if you're not experienced with geocoding. Yeah, the reason we get this is that we have a non-row value in there among our rows. And the non-row, which is not a location data type, does not have a latitude method. Because, what we did here is we're storing all these values, so it is like a loop. We are storing all these values in the temporary x variable, and then for each of these value, we apply the latitude. So what Python will do is it will go through the first row, and it will apply the latitude methods to the first row, and it will store it in the latitude column. And then it goes to the second value, but in this value, latitude is not existing for none, so you get an error. To do that, you could apply a conditional, an inline if conditional. You say if x is not none, else none. Yeah, I know it's a bit confusing, but what we did is, apply latitude if x is not none. So it will apply this method for those rows, for those values. Otherwise, it will store none in the current cell of the latitude column. So I hope that is clear. I'll execute here. And yeah, we got the latitude column in there. Great. And we can do the same for longitude. Longitudes, and here as well. Yeah, that was quick. And yeah, that's it. You have a latitude and longitude column in your data frame. So please have a second look at what I wrote in here. And if there is something that doesn't make sense, just drop a question and I'll be happy to answer you. So yeah, we have quite a lot of flexibility working with data frames. I hope you enjoy this, and I'll talk to you in the next lectures. See you. Consider this grayscale image. Now, this image is made of pixels. This particular one has 3 by 5, so it has 15 pixels. So it's quite a small image. Now, each pixel has a value, and that's what defines the intensity of the gray color for each pixel. So in reality, these are numbers, but our computer display shows them in a color format, which is easy readable by us humans. Where I'm trying to get is that programs use numbers to store images. Then the computer display, or so the screen, converts these numbers to colors. Python can also do image processing, just like Photoshop does. Probably it cannot do all the cool stuff that you can do with Photoshop, but you can make use of Python to automate things. For instance, we'll be using the image processing capabilities of Python to detect faces from photos, from images, and also detect moving objects in videos as well. So videos are made of images, so it's the same thing basically. And Python stores and reads images using arrays of numbers. For instance, this image could be represented as, a list of 3 other lists. So 3 lists because we have 3 rows there with pixels, and then in each of the lists you'd have like 5 numbers, and so on and so on, and the 5th, and the same for the other 2 lists. We've got 5 numbers because we have 5 columns, so 5 pixels for each row, and that's an image for Python. And here is where NumPy comes in handy. So while you can represent images with lists, as we did here, this is not very efficient because for big images, lists occupy lots of memory and therefore they slow down operations on them. So this is solved by NumPy, which is a Python library that provides a multi-dimensional array object. So let me go ahead and create this array object. First of all, what you need to do is you need to import NumPy. And if you have installed pandas, NumPy should have been installed with pandas because pandas is based on NumPy. If you haven't installed NumPy just yet, just go ahead and pip install NumPy. And if for some reason you have some problems on Windows, then just go ahead, as I've showed you, and find the precompiled Python libraries. Go to this side and then search for NumPy. And then figure out if you're on a 3.5 version of Python, then just get that version. And then you point to this file with pip install and the name of the file. Great. Now I have NumPy installed, so I'll create this multi-dimensional object and store it in the n variable. And that would be numpy.arange, and let's say 27. Execute that and print out n. So this is a NumPy array. That's how it is called. This particular one is not exactly a multi-dimensional array because it only has 1 dimension. So it's like a plain list, a Python list, but still it's not exactly a list type. Sorry. So it's a NumPy n-dimensional array. It can have 1 dimensional, 2 or 3. So we have 1, 2, 3. And I'll show all these scenarios. So that was the 1-dimensional array, and if you want to print it in a nice form, and that would be the array. Now, I'm just creating a NumPy array using numbers on the fly here, but normally you'd have to create arrays from images, and we'll do that in just a bit. So for now, let's create some arrays manually. Now, let's see what a 2-dimensional array is. Shape 3 by 9. So we already have this 1-dimensional array, and we want to convert it to a 2-dimensional array. If you execute that, you get a 2-dimensional array. So that's a 2-dimensional array because it has 2 dimensions. So think of it as this image file. We have 2 dimensions, vertical and horizontal. Now, what's a 3-dimensional array? Even though 3-dimensional arrays are less frequently used, it's still good to know about them. And yeah, let me create a 3-dimensional array. I could say 3 by 3 by 3, because you have 27 elements, so 3 by 3 by 3 gives you 27. And yep, that's a 3-dimensional array. Think of that as a cube that has 3 dimensions, so 3 by 3 by 3. And practically you'll see that in just a bit in this lecture. Where do we deal with 3-dimensional array? So bear with me. And yeah, you're able to see the similarities between a NumPy array and a plain Python list of lists. So this here would be like a 2-dimensional array, or if you like to call it like that. Yet the structure in the low level is different between Python lists and NumPy arrays. And also NumPy arrays allow you to make some more efficient operations such as iteration between the array items and so on. And you can also create NumPy array out of Python lists. For instance, I'll get this list here and I'll create a new object and then point to NumPy. And to convert a list to a NumPy array, you'd want to use as array method. And then between the brackets goes the object that you want to convert. And that's an array, which is almost exactly like this one in here. And if you print that, you wouldn't be able to see the difference. They look exactly the same. But they are not, because this is a list and this is a NumPy array. Great, let's move on. So that's NumPy, and as I mentioned earlier, NumPy is a base library for other libraries, such as Pandas, and also OpenCV, which is an image processing library. So Pandas data frames are based on NumPy arrays, and OpenCV objects are based on NumPy arrays. So what Pandas does is it just adds some cool features in there, such as it gives capabilities for having table headers and indexes, which you can't have in NumPy, because NumPy is meant to be a more simple and in a more low level of storing objects and doing operations. And so NumPy is a requirement for many libraries. And yeah, let's stop this lecture in here, and in the next lecture we'll go straight ahead and create a NumPy array out of our image in here. So this image. Okay, see you there. And yeah, CV2 is installed. And now what I can do with CV2, among many other things, what I can do, the very first thing, is to load an image in Python using CV2 methods. So I'll be loading that image, which is a very small image, by the way. It only has 15 pixels. A normal image that you use to take pictures or on your phone or whatever, it has like 1,000 by 1,000 pixels, which is 1 million pixels, more or less. but we should keep things simple so you understand what is going on. CV to import that. And yeah, that was successful. And now I'll create a variable and call this IM for image and G for gray. You can call it whatever you want. And CV to read an image, to load it in Python, you want to use image read method. And then you pass the name of your image. You can find this image in the resource section. So just go ahead and download it. And now this is here in the same directory with my Jupyter notebook. So I can go ahead and point to the name of the file, including the extension, smallgray.png. And here the image read method also expects one other argument from you. And that can be either 0 or 1. So 0 means you want to read the image in grayscale. And if you pass 1, you're reading the image in BGR, which means blue, green, and red. And you'll understand what each of the versions mean. So let's do this one first. And yeah, I'll print that. And yeah, that was it. So what we got is a NumPy array. It's a 2-dimensional array. So it has dimensions 3 by 5, which is the same as our image. 3 rows and 5 columns. Now the reason we pass 0 there, so we're reading that as a grayscale image, is because, you know, this PNG file, in reality, it has 3 bands, or you can say 3 layers. And each layer has a certain amount of colors. So for the first layer has a certain amount of blue, and the second layer has a certain amount of green, and the last layer has a certain amount of red. So combining each pixel is a combination of the intensity of blue, green, and red. I know in other programs they use RGB, in OpenCV uses BGR. Now practically this file here, this image, practically is a grayscale image. However, each of these pixels has its own bands, so the combination of them always creates, in this case, these gray, white, and black colors. But if we had a color image there, this would convert it to a grayscale, this function. So again, what we have here is, 187 is the value, the intensity for this first pixel. And then you have the other number, and for white, you see white here, we have 3 white pixels. And those are 255, all of them. And yeah, colors range from 0. 0 would be black, pitch black, and 255 for white. And everything between them is in the grayscale. So now if I change this to 1, I'll get a 3-dimensional array where this represents the blue layer, the green, and the red. Or you can even print that out. Be careful though that this is a bit transposed. So the matrices are 3 columns in here and the rows are vertical. And basically what this says is this pixel has these corresponding values. So it has an intensity of 187 for blue, 198 for green, and 209 for red. And yeah, that's how you create NumPy arrays out of images. But how about the other way around? So creating images out of an NumPy array. Well, to do that, you'd use CV2 again, CV2, and then you'd point to the imWrite method, so image write, and then you want to pass a name for your image. Let's say new small gray.png, and then of course you need to pass your NumPy array. So let's pass image gray. Execute that, you get true, which means that your file should have been created now. Yeah, new small gray, and yeah, that's the file. And I hope that strengthened your knowledge about NumPy. Now we'll go ahead and do some more things here. And specifically in the next lecture, we'll learn how to do indexing and slicing and iterating of NumPy arrays. So basically you'll learn how to access these values. See you there in the next lecture. Alright, you know how to slice lists. So 0 to 1 will give you the first item of the list, and 0 to 2, the first and the second item of the list, and so on. With NumPy arrays, you do basically the same thing. Except with NumPy arrays, sometimes you have 2 or more dimensionals, or 3. So let me go ahead and I'll start with a 2-dimensional array. So I'll get that from this variable. So this is the NumPy array that we'll be working with. And yeah, if you want to extract this number here, this one, and this. So these 4 numbers. Well, you'd first need to set the index of the rows that you want to slice. So that would be 0 to 2, which gives you the first 2 rows. Actually, we can try that, and you'll see that you get the first 2 rows. Now, if you want only this portion here, so these 2 numbers and these 2, you'd want to pass a comma there, and then the index for the columns, which would be, 0 here, 1, so 2, 3, and yeah, 2 to 4 maybe, yeah. That should do it. And that's it. And that means you have this indexing system. So it starts from 0 for rows, and then the second row is 1, and 2, and so on. For columns, the same thing. 0, 1, 2, 3, and 4. And actually, if you like, you can see the shape of your NumPy array. So it's 3 by 5, which means 0 to 2 and 0 to 4. Great. And of course, you can use the convention of list indexing. So you can pass 0 and everything after that, or just like that. So you get all the rows and only columns from 2 to 3. Similarly, you can get only one value if you like. Not particularly this one, because 3 is out of the bounds for axis 0. So axis 0 is a horizontal axis, which says that there is no row with index 3. So we set it's 0, 1, 2. So let's pass 2 there. And you get 182, which is the very last item of the NumPy array. And yeah, that's about indexing. How about iterating through a NumPy array? Well, there are 2 ways to do that. The first way is to say, let's say for I in your NumPy array, print I. What that will do is it will print out the rows of your NumPy arrays. So what this I accesses in your NumPy array is the rows. So in each iteration, it gets the first row and it prints it out in the first iteration, then the second one, and then the third one. And if you want to iterate through columns, you'd want to access the transposed version of your NumPy array. And that's how you do it. And lastly, if you want to iterate value by value, you'd say for I in image and dot flat print I. So this property, what it does is it allows you to access values of your NumPy array one by one. And that's about indexing, slicing, and iterating. I'll see you in the next lecture. Alright, now that you know how to do slicing and iterating through NumPy arrays, let's do some more specific operations. And that would be stocking NumPy arrays, so concatenating NumPy arrays to each other, and also splitting a NumPy array to smaller arrays. Yeah, I have this NumPy array still here, so let's start with stocking 2 NumPy arrays. To do that, you may want to create a new variable where you'll save your big array, and that would be equal to NumPy and the method to stock two numpy arrays, actually there are two methods. One is horizontal stack, so H stack. That expects from you to pass two or more numpy arrays that you want to stack horizontally. So let me pass OMG and then the same array. It's not a problem. If you had two different arrays, you could do that, but I'm just passing the same array there. Now, if you execute this, you'll get an error, and I want you to see this error so that you understand it. So it says hstack takes one positional argument, but two were given, which means that hstack inside the brackets, it gets only one argument, but we're passing two. So how do we go about concatenating two numpy arrays? We can't just pass one numpy array there. So the solution here is to have a tuple of numpy arrays. Just like that. So a tuple inside the input of the hstack method. You execute that. And here is a stacked array. Yeah, so this is the first array and then the next array, which in this case happens to be the same one, but if you want, you can add more. And you get a longer array, which is not very good looking like that. So you can print it out. And yeah, now you see the difference. So the first array, the second, and the third one. And if you want to stack vertically, you'd want to do V there. And yeah, as you expected, this will concatenate the arrays in the vertical position, in the vertical axis. Be aware that if you try to concatenate arrays that have different dimensions, you'll get an error. So IMC has 3 dimensions, if you can remember that from up here. Now you'll learn how to concatenate and how about splitting an array into smaller arrays. Well, to do that, you could create a variable and then numpy dot horizontal split for splitting horizontally. And then this expects a numpy array and how many arrays you want to produce out of that. So horizontally, let's say 3. And yeah, this says array split does not result in an equal division. And the reason to that is, this array has 1, 2, 3, 4, 5 columns. So you're trying to divide 5 by 3, and NumPy cannot decide how to do that. So should it give to you a NumPy array with these 2 columns first, and then another NumPy array with 2 columns, and then a last NumPy array with 1 column? So NumPy cannot do that. Yeah, what you should do is maybe 5 there, and LST. And that should give you 5 different NumPy arrays, which in this case happens to be, 1 array for each column. And you can do vertical splitting. This time we can try 3 because we have 9 rows there. And yeah, we get 3 small arrays. Note that this LST, so the split, what it produces is a Python list of NumPy arrays. So it's a plain Python list. And out of that you can access each of the NumPy arrays if you like. You know that. So it outputs the first array. And yeah, that's about concatenating and splitting NumPy arrays. Hope I gave you a good overview of NumPy. I tried to do some practical examples like opening images, but this is still yet in the theoretical part, so NumPy is quite theoretical, and you only understand it when you get to use like these real-world examples like working with pandas as we did previously in the course, and also working with images. So we're going to do some hardcore image processing in the next lectures, in the next section. and you'll see how NumPy comes in handy in there. And yeah, I hope you enjoyed this, and I'll see you later. Hey, hi again, and welcome to this new section of the course. And in this section, you're going to build the second application of the course. And specifically, what you're going to build with Python is this web map that you see here. So a web map is a map that is displayed through a browser and can be visited through the web. So this map was built with Python and Folium. Folium is a Python library, and the map has 3 layers. It has a base map layer, the one that you see here, with its names on the back, and it has a polygon layer, which represents the population of the countries, and also we have this point layer here with these dots, and you can turn on and off these layers. You also have these pop-up windows. So this is what you're going to build, and yeah, let's go ahead and do this. See you in the next lecture. Hi again, I hope you followed the previous video where I presented to you the map that you're going to build in this section. So that was a web map, and as you may realize, to build that web map, the default Python installation is not enough, because logically, a Python cannot have every possible functionality by default, because if it had all the functionalities, then Python would become very heavy. Therefore, it's a smart choice to have external libraries that you may choose to install or not. And this is the case of web mapping. So to build the web map that I showed you in the previous lecture, you need a library, a third-party library, which is called Folium. So as you may realize, you need to install that library. Now, just a note, I had some previous videos about this section, some old videos, but I had to change them, so I'm recording new videos now. This is a new video, updated video, and all the next videos of this section, because Folium had made some changes in the code compared to the previous versions, and therefore I had to remake the videos. Now, this time I'm using a Mac computer, but that will not make any difference. So if you're on a Windows, Linux, or Mac, everything will work exactly the same. The only difference is the way you open Atom, of course. So on Windows, please create an empty folder where you will be keeping the files for this project. So my folder here on Mac is mapping, and on Windows you can hold the Shift and right click, and then go to Open Atom here to open Atom in this folder. On a Mac, you can press Command space Atom, and then go to View, Developer, open in Dev mode, and then locate the folder and click Open. And yeah, that's it. I'm going to close all this. Let me open the terminal. And now go ahead and install Folium. To do that, you need to type pip install Folium. Normally, you'd have to do this on Windows. On Mac, if you have 2 installations of Python, you may need to do pip3. So that will explicitly say to install Folium for Python 3. So Folium was installed successfully. If you have a message saying that Jinja 2 is required for this package, then just go ahead and do pip3 install Jinja 2. However, I expect that Folium will install Jinja 2 by default, as it did for me, so it should be good to go. Once you've done that, I'm going to open Python, actually Python 3. On a Mac, you need to specify Python 3 explicitly. And what I'm going to do now is I'm going to create a basic web map. And I'm going to use a Python interactive shell for that, so that I show you things around. So try to import Folium. If you get no errors, that means Folium has been installed successfully. Now, how does Folium work? Well, everything spins around a so-called map object. So the very first thing you need to do once you import volume is you need to create a map object. So I'm using a variable to store that map object, and then equal to volume.map. So this is the class that creates this object. If you want, you can actually check dir volume to get a list of available objects that you can use on volume. So here is map. Ignore the others for now, we'll go through them later. You can also ask for help now, volume.map, to see what you can pass to this map object. Create a map with volume and leaflet.js. So what volume does is it actually produces, you use Python, so you write Python code, and that Python code will convert automatically to JavaScript and HTML code and CSS code. Because you need JavaScript, CSS, and HTML to create web maps. You cannot do that with Python code directly. So the browser reads HTML, CSS, and JavaScript and renders the code of these three programming languages to elements, so like text and lines and points and pictures. So that's what volume does. And that's a wonderful thing that you can do that with Python, through Python. Anyway, you can look here, down here in parameters. You can pass a location parameter in here. And you can specify the width. Anyway, if you don't specify the width, a default width of 100% of the browser area will be used. So you don't have to pass width and height as well. And then you have tiles. Default is OpenStreetMap tiles. So tiles is the background of the map. You're going to see that in a minute. You have other parameters as well, which you can look by yourself, I believe. Okay, I pressed Q to exit the help, and let's go ahead and create the map object finally. Volume.map. So location, you need to pass a location parameter there so that the map knows where to open. So it may open, let's say, near Alaska or near Greenland or South Africa. We're talking about the initial view, but then you can zoom in and out. So let me pass a random location. Locations, by the way, are given through coordinates. And by default, you need to pass geographic coordinates, which is latitude and longitude. And so latitude ranges from -90 to 0 to 90. So let me pass 80 there. By the way, this goes inside the list actually. So 80, a comma, and then the longitude. The longitude ranges from 0 to -180 and 0 to 180. Let me pass -100 and close a bracket. So you pass a list of coordinates to location. And actually that's enough. You can have a map object with that. Execute, you don't get an error. That means everything is working fine. So now you have a map object, but that's just an object inside Python. You haven't translated that object into HTML and CSS and JavaScript code just yet. So what you need to do next is point to that map object and then use the save method and then pass a name for the map file that will be created. And of course, the maps will be created in HTML format. So HTML is what contains all these elements that render on the browser. So text and visuals and so on. Close the bracket, execute, and as you see, a file was added in here, map1.html. But let me go to the folder, double click that, and that will open in your default browser. So this is just a random location. I don't know what it is. Mega Island. That seems to be in Canada, very north of Canada. Yeah, this is it. This is the web map. If you zoom in, you'll see more details on the map, like that. So the more you zoom in, the more elements you see. Yeah, that's what I wanted to show you. And if you want another location, you'd want to change the coordinates in here, in location. But if you don't know what coordinates your favorite place has, then there may be different ways to discover that. But a quick way is to go to maps.google.com. Let's say you want to know the. Let me zoom in here. You want to center the map around this location. So right click there and go to what's here. Copy these coordinates. Copy those coordinates. Or if you cannot copy them, just remember them. So 38.58 approximately, and minus 99.09. Okay. Then you need to save the map again, map1.html, and that will override the previous map. So go here, reload, and you see now we have a different center of the map. And of course, you can also play around with the zoom. So you can add a zoom parameter in here. This is called the zoom start. Let's put it at 6. Don't forget to close the brackets in here. Okay. Execute. Upper arrow key to call a previously executed statement, like map save. Well, you can also choose to go to the browser and reload with Control R or Command R, and that will show you the new map with another zoom factor. And yeah, that's about it. Try to play around with this a little bit, and in the next lecture I'll show you how to add points to this map. I'll see you there. Great, we were able to build this map in the previous lecture. So we have a base map and we have a marker feature here. And this is our code. Now in this lecture I'll show you how to add multiple markers to your map. And the way to do that is to, one of the ways to do that is to write this expression multiple times. So like that. And of course you need to change the locations of those markers. Save the script and execute, reload, and so you have multiple markers. So as you realize, it's not possible to add multiple markers with one single method. So with one single marker method, you need to apply the method multiple times. However, this is not very smart to do. And that's the beauty of programming. You can use a for loop to actually add multiple markers to the map. So we're talking about the Python for loop, which is one of the fundamental features of Python. So the for loop has nothing to do with volume. Let's say for coordinates in, of course you would need some sort of input with the coordinates. I don't know, let's say like that. Let's say a list of lists. So we have these two coordinates. Let me copy this, put it there, and another time, and let me change them to 9 and 7. And then you need to indent this with 4 white spaces. I'll explain this in just a bit. And then in location, you need to pass coordinates. Before explaining the code to you, let me try this out. Execute. Go to reload. And yeah, we still have the markers there. Of course, the location changed from the previous one because I changed the coordinates in here. So how is this working? Well, I'm iterating with a for loop through this list of lists. So the items of this list, of this main list, are two other lists. So the items can be anything. In this case, there are two lists. So what happens is that the coordinates variable, in the first iteration, it will get this first item of the list, and it will put that small list, so 32.2 minus 99.1, it will put that list in here. And so basically this will be put in here, more or less. That's the idea. And then in the next iteration, coordinates will fetch this other list and it will put it in here again. And so the marker method will be executed 2 times. And so in the first time it will generate a marker with this coordinates, and then in the second iteration it will generate a marker with these coordinates. And that's it. However, we have a small issue here, and the issue is that, in reality, you cannot just type the coordinates in a Python list. Let's say you have 1,000 coordinates that you need to map into a map, and you cannot and it's hard to type them in here or even paste them, copy and paste them from a document in here. So the solution to that is that your coordinates normally in real life, they will come as maybe a text file, like a comma separated text file, CSV, Excel files, etc. And you want to load that file into Python, and then you want to add the values of that file into the marker method. And you can do that using a for loop. And how you do that exactly? Well, I'll explain that in the next lecture. Well, I'll give you a comma separated file with lots of coordinates, and we're going to use that in this script. So I'll talk to you later. Hello, in the previous lecture you were able to build this map with multiple markers. This map happens to have only 2 markers, but you get the idea. And the script was this one here, so you can add as many coordinate pairs as you want in here. But in this lecture I want to show you how to add pairs of coordinates out of a text file, which is this one here, volcanoes.txt. If you like, you can just rename the name of this from volcanoes.txt to volcanoes.csv, and then you can open it in a program such as Excel. If you like, you can show it on a plain text file as I'm doing in here. Python can read both CSV and text files. So what we have here are some data about volcanoes. Basically, we have the number of the volcano, which is some sort of ID. So volcano 020. We have yet another number then. And as you see, every column, so we have columns in this data file, and every column is separated by a comma. This is the name of the first column, the first value of this first column is this one here. Then is the name of the second column. The first value of the second column is this one here. Then the second value of the second column is this, and so on. And then we have the name column, the name of the volcano in here. The name is here, Baker, and then the comma starts here, which means that location is this one here, US Washington. Then we have the status historical for the first volcano. And then we have the elevation, which is this one in here. I'm not sure whether these are in feet or meters, but you can find that out. If you're curious, you can do a research for this particular volcano and compare the elevation. Anyway, then we have the type of the volcano. You have the time frame, which is D3. I'm not sure what this means. D4. And so, then lastly, this is where we're interested about. We have the lat and lon columns. So this is lat, which means latitude, and this is longitude of the volcano. So you need these two numeric values in order to map the features, so the volcanoes, into a map, in this case into a volume map. So this has around 63, actually 62, 63 including the header of the data. And so how do we load this file into Python? Well, to load that file into Python, let me clear the terminal. And you'd first need to install a very useful library called pandas. We're going to use this library later on, so I'm not going to explain pandas in detail for now, because we were just using one or two of its functions, which I'll explain in this lecture. So go ahead and install pandas if you don't have pandas. Pip install pandas or pip3 install pandas, depending on how you have configured Python. And then you can go ahead and open a Python session. Import pandas. And the way to load a file with pandas is by pointing to pandas.read csv volcanoes.txt. Make sure that your Python session has been opened in the directory where your volcanoes.txt file is. So for instance, my session is inside mapping folder, which is this one here, so I can just pass the file name. Otherwise, you may have to pass the absolute path of the file, which starts from like C / and so on, depending on what operating system you are in. And execute that and call data, and you get the data printed out. Just like that. So pandas is able, actually the read CSV method is able to distinguish between these commas, where the commas are, and so it creates a well-structured data format with columns. So if you go down here, so you have some columns here, column, and then up to the end. But then you have other columns because Python cannot print out. Actually, the terminal doesn't allow you to have all the columns in one inside with this area here, because it would be too much. Anyway, you have status, elevation, type, time frame, lat, and lon. So that's about the data. Now you need to figure out a way to iterate through that data frame. So this is called a data frame. So the data object is called a data frame. You can check its type actually. Pandas core frame data frame. So what I'm thinking of is to actually create two lists out of these data frame columns. So to put the latitude column in a Python list and the longitude column in another Python list. And so that we have a native Python object, which is a list, and then we can iterate through that list using the for loop. So let me try to do that. Import pandas, and then create the data frame object. So loading the data, read csv volcanoes.txt, and yeah, that's it. So how do we convert a data frame column into a list? Well, the way to do that is by just doing, let's say, L or lat equals to data, and then the name of the column, which is lat. So you can get a list of columns, by the way, by doing data.columns. Here you see you have a lat and a long column. Then you do lat equals to list data lon in square brackets, close it. And so what you did here is data with the lone attribute there will return a series object, but that series object we are converting it into a native list. So that will be a Python list. This will also show up as a similar object. So this is a series object. And this is a list, but I prefer to work on a list because working on lists is faster than working on data frame series. So the idea is to have two lists here. That equals to list data lon. Copy that, paste it here. And the same thing goes for longitude. So lon, lat, and lon lists. So now we need to be careful here on how we iterate through these two lists. Because, what we have is we have two lists and each of them has 62 items. You can check that using len here, down here. Lat. So it has 62 items. And the same goes for the longitude list. That means that the first item of the latitude list corresponds to the second item of the latitude list. Of the longitude list. So the first two items make up the first location of the first marker. That means that in the first iteration we need to extract both locations. So actually this sort of structure won't be appropriate anymore. What you need to do is you need to go through, let's say, lat and lon variables. When you iterate through two lists at the same time, you need to use the zip function. And then it goes lat and lon. So basically what this function does is like this. Now let's say for I, j in zip. Let's say the first list is 1, 2, 3. And the second is 4, 5, 6. Print I and j. So this is what happens. This loop will go through these two lists at the same time. So what happens is that I will go through the first item of the first list, while j will go through the first item of the second list. And so in the first iteration, 1 and 4 are extracted. So 1 here and 4 here. And you can do such an extraction by using the zip function. Otherwise, you won't be able to do that if you don't use the zip function. So zip sort of distributes the items one by one. And so the same goes here. LT will get the first item of this list. L1 will get the first item of this list. And then here, what you need to do is you need to construct a list with LT and LN. Yeah, that's it. Save the script, go to the terminal to execute. It's not here, the terminal. I'll just exit that. Python 3 map1.py execute. No errors. Go to Firefox and reload. And I've got no markers for some reason, but I didn't get an error. So this is one of those scenarios where you don't get an error in the terminal. So in that case, you need to double check your code carefully. So data pandas 3 CSV lat this data lon. Here's the error. So what's happening is that I'm assigning the wrong column to the latitude list. So let me change the order and try again. So don't get intimidated by errors. Errors happen all the time. You just need to be cold-blooded and read the errors if you get any error here, and also look at the code carefully. Let me reload. I've got some markers now. So these are the locations of volcanoes in US actually, United States. Okay. They also have this pop-up, which is working well, but I assume you don't like it very much because it's not showing any information. So what we need to do here is to actually make this pop-up dynamic so that it shows some actual information. And I'll show you how to create dynamic pop-ups in the next video. Talk to you there. Hi again, in this video I'm going to show you how to add the elevation values, so these ones in here, to the pop-up window. Currently our script simply prints out this string in the pop-up window, so we're going to change that, and the way you do that is by first loading the elevation data into a Python list. And then in the loop here, you want to say, let's say L in zplat-lon elev, like that. And here in the pop-up argument, you pass the L attribute. So again, we create a list which is named elev, so variable elev. That will be a list of all the elevations, and then we iterate through these three lists. So LT will get the first item of let, LN will get the first item of lon, L will get the first item of LF, and those items will be distributed in this function in here. So LT in here, LN in here, and L in here, EL in here. Now I want to save this and execute, but I expect to get an error. And I want you to see the error so that you get familiar with handling errors as well. So the error is happening on line 14 in this file, map1.py, which is our file. Line 14 is here. So this is the line. And then we have add child pop-up. So it seems this error has to do with the pop-up object. I would say this is not a very good error message actually. It's hard to read this error and to troubleshoot it. So not very good information given by volume here. But anyway, we have some clues. So pop-up, and this says name child get name attribute error numpy.float 64 object has no attribute get name. So it seems that volume is trying to apply this getName method, which is a method inside the volume code base, and it's trying to apply it to a number. So I think that this L here is actually a number, and I can check that by saying print type L, save, execute the script. Again, here is the type. So this is a numpy float 64. So basically it's a float type. It's actually a special float of the numpy library. But anyway, you can call it a float. So it's a number, it's not a string. But if you look at help volume dot marker, you'll see that the pop-up parameter expects a string from you as input, but instead you're passing a float number. So you don't want to do that. What you want to do is simply convert that float number to a string. Save the script, go to the terminal, execute again, go to Firefox, reload, and you get the elevation displayed correctly. yeah, that's about it. You can also you may also want to stylize what you're displaying. So to add more information there, such as plus space meters. So I'm adding the M string to every pop-up window information for all the elevation numbers. So we're talking about 2447.0 meters. That's the elevation of the volcano. Yeah, that's the idea. I hope this was clear, and I'll talk to you later. Hey, hi again, and welcome to this new lecture. What we have so far is this map with these 62 markers, each of them representing a volcano location in the United States. However, this map is not very smart, so to say. The only information that this map conveys is the locations of the volcanoes. And you also have a base map. There's also a good aspect of this map because you can extract information like that if you click the icons. However, you may want to transform this map to actually show an attribute instead of just volcano locations. The way to do that, there may be different ways, but that's up to your knowledge about cartography. But I could make the map show an attribute here. For example, I could change the colors of these markers to actually show the elevation range. Let's say we can categorize these markers into three colors. Let's say green, orange, and red. Green would be for elevations from 0 to 1000 meters, for example, or 2000 meters, and orange would be from 2000 to 3000 meters, and then red markers would represent volcanoes with an elevation of higher than 3000 meters. So how do we do that with volume? Let's get back to Atom. Here is our code, what we have so far. Currently, what we're passing to the icon argument is a color argument with a value of green. So basically what we need to do, we need to make this dynamic so that the color changes depending on the elevation. And unfortunately, we cannot do that with volume. So volume doesn't have native functionality to create dynamic colors for your markers. Therefore, we need to be a bit creative here and use Python core functionalities to do this. And when you think about dynamics, I think about functions. So basically, this loop is going through latitude, longitude, elevation, and then it passes those three values into this expression in here. However, color is being passed as a string always. But how do I change it depending on the elevation, for instance? Well, the way to do that is by creating a function that gets as input elevation, and then it does some actions inside the function, and then it returns a color depending on the elevation value. So you can say, if elevation is less than this, give me green color, a green string here, and so on and so forth. So to give you an idea, the way this would work is, let me write the function here. This would be a good place to do that before creating the map object. But always you need to create the function, because I will be calling the function in here. So you need to create the function before this expression. So from here and upwards. I'll be creating that in here. Let's call the function color producer. Let's keep it simple for a while just to demonstrate you how this would work. So let's keep it very simple. Let's say return green, and if you change this to color producer, and don't forget the brackets, by passing brackets that means you are calling the function. If you don't pass the brackets, that means you're just calling the function name and you are not executing the function. So just keep it like that. And Go ahead and execute map1.py. Alright. Reload and you'll get the same thing, right? Because what happens is that this thing in here, this function call, will be equal to whatever you return here. So the type of this object is actually a string. So it's exactly the green string. Therefore, now you can add some conditionals here. Basically, you need to pass an input here. So elevation, let me write whatever variable you like. I'll write elevation, and here you need to pass L. So L for let long L. So, let's say we have 62 rows in the data table, and for loop will go through the first row of the table. It will get elevation and it will pass it to this function call. So the function will pass L into elevation, and then you say here if elevation is less than 1,000, then you want to return green for elevations less than 1,000 meters. If elevation is between 1,000 meters, so it's greater than 1,000 meters, or less than, let's say, 3,000 meters, return orange. Else, return red. So red will be returned if none of these conditionals is satisfied, which means elevation is neither less than 1,000 meters nor between 1,000 and 3,000 meters, which means what is left is greater than 3,000 meters. In that case, we will return red. For finding out those values, actually, you need to do a little bit of data exploration. For instance, you may want to look at the data quickly like that to see what values you have, and then decide on the category thresholds. But you can also make more significant statistical analysis, like you can make a histogram and see the data distribution and then decide on these values. But let's keep things simple and let's decide on these values. Okay, I'll save this. Check if everything is in place just quickly. Yeah. Let me try the code. Go and reload. And yeah, we have some different colors here. Yeah. This is looking good. Let me double check the values. For instance, orange is between 1,000 meters and 3,000 meters, so we're doing good. Red is above 3,000 meters. Yeah, it seems it's working. Alright, I hope you solved the exercise, but don't worry if your map looks a bit different from mine. Anyway, here are my markers, circle markers actually. I have green, orange, red and orange markers. You get the idea, and they also have some sort of opacity. So I've set an opacity value of 0.7, which means 70% to them. As you see, you can see the marker that is underneath this one here. Anyway, here is the code. So let me explain what I changed from the original code. So I changed marker to circle marker. The location remains the same. Also pop-up attribute remains the same. And then I added a radius here of 6, which means 6 pixels. That's the size of those circle markers. Then I added a fill color. The fill color attribute is for the inner area of the circle. So you see this orange area, but you also have this outer color here, which I set to gray, and you do that with the color argument. So color equals to gray for all of the markers. The default color would be black, which I think is a bit heavy for the eye. Anyway, here is the fill opacity. For the transparency, I set it to 0.7. And that's it. I hope this is clear now, and I'll talk to you later. Hi, welcome again, and in this lecture, I'll show you how to add another layer to this map. Currently, we have two layers. We have the base map, which are map tiles by map box, you can see here. And the data are served by OpenStreetMap. And you also have your custom layer as well, which is a layer containing circle markers. So in GIS, Geographic Information Systems, these are referred to as layers. Now I'd like to add a third layer to my map. That will be a polygon layer. So this current layer with markers, this can be referred to as a point layer. You also have line layers and polygon layers. So with points are better to represent locations, and you have lines. Lines are best for representing geographical features which resembles lines, such as roads and rivers. And then we have polygons. Polygons are best to represent areas. So for instance, in this lecture, what I'll show you is how to add a polygon layer that represents world population by country. So countries are represented as areas. And what we're going to do is each of the countries will have a specific color which will indicate the population of that country. So points for locations, lines for lines, and polygons for areas. Now, of course, you need to have some data to create a polygon layer. You know, just like as we did with markers, we had some data in CSV in text format. And then we use those data, we open them with pandas, and then we iterated through those lines of the data, and we added the markers to the map. Now, for polygons, the way to add polygons via volume is by using the volume.geojson method. So basically, let me make some space here. The way this would work is you want to add to feature group the variable here. You want to add a child, which will be a volume.geojson object. So this is the method with brackets here that creates a GeoJSON object. And for GeoJSON data, we will use this world.json file. You can find this attached in this lecture. Let me explain what this is, but careful, don't open it on an Atom, because if your computer is a bit slow, your Atom may crash. So try to open it with a lighter editor, such as Notepad, for instance, or Cat on Linux terminal or Mac. Anyway, this is the JSON file. You can refer to it as JSON or GeoJSON. Actually, GeoJSON is a special case of JSON. Basically, the format is always the same. It starts with curly brackets. And basically, it contains a string which is like a Python dictionary with keys and values. Keys, key, and value. Where this curly bracket ends, somewhere here, I believe, if I'm not wrong. No, this one ends in here. Yeah. And then you have the other key, geometry. So what is geometry? Well, the type of geometry is multi-polygon. So basically you have these kind of attributes that describe the data. Type multi-polygon coordinates. So this is now starting to describe the features. the polygons. So these are the coordinates of the first polygon that will be displayed on the map. Let's say this is one specific country, and that's Antigua and Barbuda. Yeah, a small country, but anyway. And these are the coordinates that will determine the location of that polygon in your map. So basically, path volume will read all this information and it will decide where to put the polygons. And then you can also use other attributes of this, such as population, which is here. Yeah, you'll use this population value to put a color for that population. And so on and so forth. You have all countries of the world in this JSON file. So spend a few minutes looking at this file to understand its structure, and in the next lecture I'll go ahead and load the JSON file into Python and display the polygon layer. See you there. Great! In the previous lecture I showed you how a JSON file looks like, and in this lecture I'll go ahead and add that JSON file to the code. Remember, I provided you with the JSON file in the previous lecture. You could download it from the lecture resources. And so, this GeoJSON method gets a data attribute which is equal to the file object of the JSON data. So basically, you need to create a Python file object which you can create with open. Remember, open is a classic Python method for creating file objects. So there goes the path of the file. This happens to be in the same directory with my map1.py script, so I'm just passing world.json. And basically you're opening it in read mode. And now I'll leave it like that for now. Save, execute. I think we'll get an error here. Yeah, we need to add an encoding parameter there, as suggested by the error message. So that goes inside the open method. Equals to UTF-8 sig. Save again, go and execute. Reload. And yep, we have the polygons displayed on the map. So that was quite easy to do. And something you should know is that you can also add points through through GeoJSON. So in this case, we added polygons, but that JSON file could also have lines or could also have points in its attributes. So, this one, we had an attribute that was stating these are multi-polygons, but this could be points or lines. And in that case, volume will display those features depending on this type attribute in here. Of course, you'd also have the coordinates attribute with the coordinates of the line, so the points where the line breaks and turn. And in the case of points, you'd have pairs of coordinates here. So I hope you get the idea. That was about this lecture. In the next lecture, I'll show you how to create a choropleth map, which is a map that uses coloring of areas to represent features. In this particular case, what we'll do is we will have these polygons with different colors to represent the population of the world for each country. We'll do that in the next lecture. See you. Hi again. In this lecture, I'll show you how to make a country by population map. I will be showing population of each country through graduated colors. So we'll think about a range of colors to represent population from low to high. And we have that piece of information in our world.json file. which is stored in this pop 2005 attribute. So pop 2005 means population from 2005, which is quite old, but it shouldn't be a problem for educational purposes. So let's get back to the code. And the way to change the color of those polygons, because by default we have this green color, and there's also transparency on the polygons. You can see the base map on the background. And so to change that, you need to access the style function argument. But I have messed something here from the previous lecture, which could cause some problems later. This doesn't have to be in round brackets, so delete that. And one here as well. So we have 1, 2, 3 open brackets and 3 closing brackets. Now it should be fine. So we need to add another argument to GeoJSON. This is the first argument, so data is the first argument, which ends in here. So add there another style function argument, and you can actually break the line in here. You are free to break lines in Python when the expression is inside brackets, round brackets, square or curly brackets. So in this case, this expression is inside brackets, so we are able to break it. And it's good to break it at the comma. So style function equals to. Now this expects a lambda function. Lambda functions are just like functions, normal functions, but they are written in single lines of code. For instance, let's say L equals to lambda. This is a lambda function, x in power of 2. Oh, sorry, I had a typo there. Not lambda, but lambda. Okay, another typo. All right. So L is a function here, just like you'd have a normal function, and then you can call L. You can pass a value like 5, and that will return 5 in power of 2. So as you can see, you can write the function in one single line. And this can also be useful in other cases like this one in here that you'll see in just a bit. So lambda x. This also allows you to write anonymous functions. So this function now, it doesn't have a name. Like here, I assigned a name to this function because I needed to call it later. But this one here, we don't need to call it later, so you don't need to give a name. So here, the syntax would be correct if I do just like that. So let's go ahead and do this. Fill color with a capital C, lowercase f, uppercase C, and that should be in quotes. Let's say yellow. Now, if you want, you can leave it like that. So save the script. Exit the Python shell and execute the script. The execution went fine. Let me check the map, reload. And you'll see that the colors of the polygons changed to yellow. So that's how you can change the attributes of your JSON file. So to say, basically you add another, you add this attribute, which is not in the JSON file. If you search for it, you'll find nothing. And so now you can play around with this by adding conditionals inside this dictionary, such as if x properties pop 2005 is less than, let's say, 10 million, So 10, 1, 2, 3, 1, 2, 3. So what I'm doing here is I'm saying that set yellow to fill color if X represents the feature, a JSON feature here. So if the properties, actually if the pop 2005 attribute of this attribute, which is here, this is pop 2005. I know this is a bit complicated. Let me Google software wrap. So now I have all the text wrapped here in the view. And here, pop 2005 is actually part of this dictionary up to here. So this dictionary, these are a set of properties. This dictionary is the value of this key, of the properties key. So what that means is that, we are accessing the value of the properties key using this syntax, which is known in Python. Meanwhile, X properties, what that is X here represents features. So you are accessing properties from features. And on the background, this is a bit of a black box. But what volume will do is it will go through all the features of all the polygons, and it will check if the value of pop 2005 is less than 10 million. And if it is, then it will set this this color to fill color attribute. That's more or less about it. I think it's better to put this green. So if it's less than 10 million, put it green. Else orange if between 10 million. Do the same thing here. Properties. Actually, you can break the code in here. So properties pop 2005. And let's put here 20 million. So these are just arbitrary numbers. You can put everything that you want, but that will affect how your polygons are classified, are colored. So for population between 10 million and 20 million, we'll get orange colors. Else, red. So everything above 10 million will be colored as red. Okay, let me save this, and I hope this will work. No errors. Reload. We have US colored in red because it has a population of higher than 20 million people. And yeah, this seems to be working fine. Portugal has a population of around 12 or 15 million people. I'm not sure. So it's in the middle range of our classification algorithm. And yeah, that's more or less about it. And if you like, you can ask questions. And I'll be happy to help you. And I'll talk to you later. Thanks. Hi, and welcome again to yet another lecture on web mapping with Python and Volume. This is the map we built this far. And it contains a base layer, a polygon layer, and a marker layer. This is our code. Now, what I want to do in this lecture, I want to implement a feature that allows me to turn the custom layers on and off. With custom layers, I mean the polygon layer and the marker layer. Because it's not possible to turn off the base map, at least as far as I know. And it wouldn't make sense to turn off the base layer. You don't want a blank page. So let's see how to do that. The key feature here is layer control class of the volume module, which can be added like this. You want to point to the map object and then you want to add a child. So layer control is added as a child. So volume layer control. Now, this will not work, but I still want to execute this so that you don't make this mistake later on. So let me reload the page. You only see the base map here, no layers at all. The reason this doesn't work is that when you added layer control to the map, you still hadn't added the feature group, which is an object that contains the JSON layer and the marker layer. So basically, layer control will be looking for the feature group added to the map, but it doesn't find it at this point. Therefore, things are messed up. So it's important to put that after you have added the feature group layer to the map, right here. Save and execute again. Reload the map and you see the layers there and you see this box here. Map box bright. This is about the base map and you cannot turn this off. And you also have this My Map item here of the layer control panel. So this is the layer control panel. And you can turn on and off this layer. But as you see, this is turning off and on both the polygon and the point layer at the same time, which is something you don't want. So we go ahead and change that, and I'll explain why this happens. So this is happening because, layer control, what it does, it looks for objects added to map with add child, like here. So you have added a child, and you have added only one child to the map object. Therefore, layer control will consider that object as one single item of the layer control panel. But that feature group object, it contains the circle markers, but it also contains the GeoJSON layer. Therefore, you need to change your strategy here. So how can you do that? Well, there may be different ways. One way is to actually create a feature group for volcanoes. Let's call it AFGV. So you add AFGV here. And then you want another feature group. Let me copy this line, paste it here. You want another feature group for population. Let's call this population. Let's call this volcanoes. Like that. Change the variable name, FGP here. Okay. FGV there. Add another child, which has to be FGP for population. Yeah, now everything looks good. So let's see if layer control will be able to read these two feature groups now. Okay, go and reload. The map looks fine. Volcanoes, working well. Population, 2. So everything is working fine. This is the map. And yeah, if you were able to build this as I did, then good job. You can also choose not to use feature groups, actually. So you could have added GeoJSON to the map directly. However, for this case, for volcanoes, where you are adding, you are executing the addChild method multiple times, in that case, you'd have one layer for every volcano. So you'd have added 62 children to your map object if you did map without feature group here. So that means in this control panel here, you'd have 62 entries, 62 layers, and that's not what you want. So feature group comes in handy in here. For volcanoes, it is necessary. But for GeoJSON, you could have used map here and everything would be fine. But for consistency, it's good to add both to specific feature groups. Volcanoes here and population here. So now this is the code, and I hope you enjoyed this program, and feel free to ask questions. And I'll talk to you later on. See you. And here we are with a brand new section, and as you may have realized, this is one of those hands-on sections, as you're going to build yet another real-world program. And I use this particular program every single day for my personal use, and I wouldn't go as far as to say this has changed my life, but I can certainly say that this program has multiplied my work productivity. And there's no magic there. It's a simple Python program, yet tricky, that runs on the background. And all it does is it doesn't let you browse certain destructing websites, such as Facebook or your email account, during your working hours. And the program is tested to work on Windows, Mac, and Linux. And the idea is that once you build this program, you pass to the program website links that you think are distracting. So you pass links as strings, and also the time that you're working on your computer. And the program will block these websites during these working hours. And in that way, you not only are much more productive, but this also reduces stress, as distraction is also known to cause stress. If you don't have any problem with distractions like I do, you probably won't need this program. So yeah, I don't want to go further with the usability aspect. So usability is one of the benefits that you get from this program. The second benefit is, of course, the Python part, because this program is quite tricky to build, even though it's less than 30 lines of code. Here we're focusing on file manipulation and working with dates and times, and also the aspect of running a Python program as a process in the background, which is something we haven't yet learned in the course. And yeah, I'll do a quick demo now of the program. This is a program, so it's a Python script, a .py script, which later, if you want, you can attach to a graphical user interface if you want to give it to other people who don't know Python. And this Python script runs as soon as your computer starts. So now this program, this Python script, is actually running as a process. As you can see, this is a program running, and you also see that this occupies very little space actually. For instance, if you compare this with other processes like Chrome, like the browser, you see that this is very insignificant, which means that you can have the program run continuously on your computer and it will not cause any problem. So the program is running, and if you try now to access Facebook, for instance, you'll get this. This site cannot be reached. Same for Hotmail. So I have a Hotmail account, so I have blocked that too. That means I have to go back to work, making up my mind that it's not the time to spend on such things right now. Maybe after 6 o'clock I can browse those websites if I want. And yeah, that's about it. I know you probably have not much idea on how to start with this, and I understand you, but I'll explain the architecture of the program in the next lecture, and then start building it. So see you in the next lecture. So how do we go about blocking websites with Python? Well, Windows, Mac, or Linux, they have a hosts file, which is something like this. So this is the host file, and if you open this host file, you'll see some lines there. And what this host file is for is that if you want to block certain websites, such as Facebook or this Mail Live here, what you do is you type them here, as I have done here. I have typed them via Python in this case, but you can also type them manually, but in that case you don't have control on the times when you want them to be here. So if you have a look at this, this is saying that the IP address should be placed in the first column, followed by the corresponding hostname, which means this is a redirect IP address and this is a hostname, which underlies that if you want to block Facebook, you want to redirect the browser to this IP address, which is a local IP address of your computer, which means when you try to access Facebook, you'll be redirected to that IP, and that shows this error web page. Good. Now this host file on Windows, it is located in this directory here. So Windows System 32 drivers ets, and then you have the host file, which doesn't have any extension, but you can open it as a text file in Atom or other text editors. On Linux or Mac, that host file path would be something like this and hosts. So, very straightforward. This is both for Linux and Mac. And on Windows, that was this one here. So I'll copy that and just put it here. So that's for Mac and Linux and Windows. Good, now that we know how this host file works, we can open that as a file via Python using file handling methods. And we can add lines of text at certain times of the day in this host file. For instance, let's say I work between 8 AM and 4 PM. In that case, I'll write a Python script that runs the entire day and checks let's say every 5 minutes. It checks the time, and if it's past 4 PM, then it will delete these 2 lines. But if you are between 8 and 16, Python will add these 2 lines in this host file, and the host file will block access to these 2 websites. So that is starting to make sense, I believe. And all we need to start off is you have to think about, let's say, 2 websites that you want to block, or more, or just one. And also figure out where your host file is located, which I already showed you. And yeah, we should be good to go to start writing the program. And we'll do that in the next lecture. Okay, I think it's now time to code. And I'll be putting everything in one script. So let's call this website blocker.py. And yeah, again, the idea is that I'll be accessing this host file, which is in this directory. So if you are on Windows, you'll get it here. If you are on a Mac or Linux, that would be directly at this folder, and then you have the host file. So you get the idea. And so let's keep that path in a variable. Let's say host path, and that would be equal to, I had copied this earlier, so I'm just pasting it here. And so on a Windows, these are backslashes. On a Mac or Linux, you'd have a / and then etc. And then you have, of course, the host's name, so the name of the file. If you're on Windows, you should be careful about something. These backslashes, sometimes you might have something like, let's say n, a folder that starts with the n character. What that will do is Python will read this as a special character. And what this special character means is, it means a break line. So when you pass \n, Python thinks you're passing a Python keyword, and not actually a string. In that case, what you could do is you could pass the R prefix there, which means a row. That means, remove this, with this, you tell Python that you're actually passing a row string in there. So you're not planning to pass any break lines in there like a \n. And yeah, I hope that is clear. Or alternatively, you can remove this and you can add 2 backslashes in each of these directory separators. So that would be an alternative solutions, but let's keep it like this. Good. And maybe 2 other variables, let's say redirect equals to this string. So the IP where your browse visit will be redirected when you browse Facebook or other things that you find distracting. And then let's say websites. So you need to pass the websites that you want to block. That could be a list. So I'm calling this website list, and here I'll pass www.facebook.com. And also you want to pass facebook.com as well, because sometimes these websites use 3 W's there for their domain, but sometimes they don't use. So you want to pass both these domains in the host file. And then maybe my Hotmail account. So how do I know that this is the domain? Well, if I type hotmail.com and I can see that hotmail.com is sending me to this domain in the browser, so I can see this domain in the browser. When this opens up, my email displays. So this is what you want to pass there. You want to see the final landing domain, and maybe the other version. And yeah, we should be good to go. We have a list with 4 elements, and that means in the host file we will have 4 lines. I currently have these Facebooks here, so I'm gonna save the hosts again with all those, and I'll make sure I don't have any Python script running here in the processes. Yeah, I don't have any. Good. And I was afraid that I had a running script, a Python script there, so that's why I checked in the processes. So how are we gonna do this? Let me put this here and this here. Well, our goal is to have this file modified at let's say 8 a.m. So at that time I want these 4 websites, these 4 lines to be added in here together with this IP. And then I want these 4 lines to be removed at let's say 4 p.m. And there are maybe 2 ways to do this. One way would be to write a simple Python script that all it does is it opens this file, let's say with open host path as file, and then write these elements of the list in that file, in that host file, and that's all. And then what you do is you may use this task scheduler on Windows or cron on Linux or other packages that do schedule tasks, and you may set this Python script to run in certain times. And that is one solution, but why would I use third-party tools when I know Python? I mean, I know Python better than these tools, and I'm not 100% sure that with these tools I'll do exactly what I'm after. But with Python is a programming language, so if you set to do something, if you think about something, that's almost 100% sure that you'll do that, because you have lots of flexibility with a programming language. So it's good that if you know a programming language, and then you should seek for a native solution. And yeah, that's what I'll do in this case. I'll not just write a simple script that adds to these 4 lines of code in this host file. Instead, I'll have this script running all the time. And to do that, I'll use a while loop. While true, and then everything goes inside this while loop. And what a while loop does is it executes an action very, very fast, so it depends on your processor speed. But in my case, for instance, what this will do, it will print out 1 every, let me guess, 1 millisecond. So it depends on your processor speed, but maybe faster than 1 millisecond. And so let me open a command line and execute this script. Shift right click here, open command window here. This terminal plus package of Atom is having a problem at the moment. It has a bug, so I'll be using the simple command line. Terminal Plus is probably more convenient, but this shouldn't be a problem. So Python, and the script name is website blocker. And here one is being printed out, as you see. Control C to interrupt the process. What I'm thinking about is to have some code here that checks the time every millisecond. So that would be something like, is time between 8 AM and 4 PM? If it is, then keep these lines in this host file. If it's not, then remove these lines from the host file. And that action would be performed every, I'm saying millisecond. But that's not a very smart thing to do. Why would you want your program to run every millisecond? That doesn't sound very memory efficient. So what we could do here is a simple trick. We import time, and then here we say time sleep, and let's say 5. And this time we execute this, and 1 will be printed every 5 seconds. So yeah, that's it. Which means if we right now the code that accesses these lines here, this host file, that code will run every 5 seconds and not every millisecond. So that's enough accuracy for us. That means that if time is 4 PM and then it goes 4 and 1 second, we will still have these lines here. We'll have this website blocked yet at 4 PM plus 1 second. So there will be a delay of 5 seconds, which is not a problem. And you can also put this higher number, so you can make it 5 minutes, which would be 300 seconds. But let me keep it 5. 5 is good. 5 seconds. And yeah, I think this is starting to make more sense for you now. And I'd like to stop here, and in the next lecture we will go ahead and write the code that writes these lines in this host file. Great, we have a while loop there that will make sure our script will run all the time, specifically every 5 seconds. Now, inside this while loop, we want to check the time. So we're talking about a conditional. When we're talking about conditionals, so we think about if and else. So while true, which is always true, and that means the script runs all the time, if, and start thinking about how we can check if time is between this and that. Well, first of all, we need to import the datetime module. So we have the datetime class inside the datetime module, which should be, so the datetime class from the datetime module. So import datetime class, maybe as dt. So this will be assigned the dt namespace. I'm doing this because this expression will be quite long, so it's good to have a short name there instead of doing datetime, .now, etc. Instead we do dt.now. So we want to check the current time against 8 AM and 4 PM. Now the current time would look something like, let me open a Python shell here, and from datetime import datetime as dt, and dt.now. So this is current time, the year, month, day, hour, minutes, seconds, and milliseconds. Sorry, this is microseconds, not milliseconds. Now this current time is being generated automatically, and as you know, this is a spatial object, so it's not it's not a string or a number, so it's a datetime object. And what I'm trying to get here is that to compare this object against a datetime that we pass manually, and you see what I mean with passing manually, we need to compare this datetime object with a similar object. That would make sense. If you just pass, let's say, something like a tuple of 2016 and let's say 5 for month, 5 for day, and then 8. And then you compare this with, let me call date.now. So let me compare this with this tuple 16 and 5, 8. You of course you'll get an error. So what you have to do instead is you'd call date.now, so this object here, and then you create another object manually. So you call dt, which is the datetime class that we have imported earlier, just here. And then inside the bracket, you pass the values. Let's say that, and let me pass 8. And this is saying false. So which means this value is not less than this. Let me check the time now again. And don't expect to get the same time as you did here, as you see. So now it's actually 9 p.m. And if you're wondering why, is that I had to interrupt the video. So I had to pause the video around this time, and then I went back like 12 hours later. So now it's actually 9 p.m. in here. And my computer was sleeping during this time. So that's just that, if you were wondering why. That means this time is not less than this. So it's not earlier than this. If you do, for instance, is it greater than this? Then you get true. Now in our case, we need to check actually against 2 date times. So that would be something like dt, and you would pass 8 here, so 8 a.m, and then here would be 16. So let's do that in our script instead of writing this in here. Yeah, if we are here, so if dt, and now I could pass here 2016, and this would probably work for this year, but it's not very sustainable. So what you want to do is work with variables instead of values. What I'm trying to say is that instead of passing 2016 in there, you can have Python generate a year on the fly for you. So dt.now.year. And that would return 2016. Actually, we can try that here. Now.year. Yeah. So this returns this value, which is a string. Type. Sorry, it's an integer. I meant to say an integer. So it's a number that the dt class reads it as a year. So the year, and then dt.now, again, the month should also be a variable. Month, and then dt.now day. The only thing that we want to have fixed is the time. So 8. What we're trying to do is check if dt.now is greater than 8. So if it is greater than 8, that means we are in the working hours. And also, we want this to be less than 16. So what you do is you just copy these, and I forgot the bracket here. Yep. So you copy that, paste it here, a bracket there, and say 16. And then you have a column there for the if statement. So if this is true, then you want to execute your other statements. So let's write something more informative. Working hours. Yeah, let me execute this now. Python website blocker. We've got an invalid syntax. I think I messed up the brackets in here. This is okay, but this one should be inside brackets. Yeah, this closes in here. this one closes there, and this should be fine now. Let me try again. And unnotable types, this is comparing against a tuple. Sorry about that. It's actually not a good idea to copy and paste things. So as a general rule in programming, you shouldn't copy and paste things. You should write them, because when you copy and paste things, you're prone to making errors, like I did here. Now I'm doing copying and pasting here for the sake of video recording, so this is probably more convenient for you, as it saves you time watching me to write the things down. So it's better to use your logic and just write things so that you focus on what you're doing. And yeah, I think this error was good that it came up, because now you know that it's good to write things, to write the code instead of pasting it. So we have DT here that creates a datetime object. This also creates a datetime object, and this one as well. So let me go again, execute, and nothing is happening. So actually the code is running, but we don't have this print statement executed. The reason to that is that now it's 9 p.m. in here, so we are not within the working hours. That brings us to the point that if I'm interrupting this, if you want to print something when you are not in the working hours, you'd want to add an else statement in here. So say else print fun hours. Save. And yeah, what we have this for is while true, check for this condition and do this if that condition is true. So print out working hours. Otherwise, if this condition is not true, so if it is false, as it was when I just executed this script, then print this statement in here. And then sleep for 5 seconds, so don't execute the loop for 5 seconds, and then go again and check the current time again against these two values. So yeah, now we are in our fun hours. So every 5 seconds we get fun hours there printed out. Great. Yeah, I think we have the structure of our script, but we don't want to just print out these strings. What we want is we want to modify this file. So if it's between 8 and 4 p.m., we want to add those 2 lines in there. Otherwise, we want to make sure those 2 lines are not there in the file. So it's quite a bit tricky to access that file and add these lines and check if these lines are there. But we'll crack that in the next lectures. So, see you there. Good, I have the script running at the moment, and as you can see, the loop is doing its job, so it's printing out working hours in the command line here every 5 seconds. And now it's 15 past 12, so that is between 8 a.m. and 4 p.m. Now we'll go ahead and add some lines here. So I'm thinking of keeping these statements here, these print statements, but also adding more lines here which correspond to file handling methods, which will access this hosts file and modify it depending on the time. Now, something that you should be aware about is this host file can only be modified by the administrator, which is if I run the Python program, I would have to open a command line to run the command line as administrator. So if you're on a Linux or Mac, you do the same by using sudo. For instance, in this case, I open this command line by just right-clicking in here. So shift right-click and open command window here. But that will not run the command line as an administrator. So, which underlies that with this simple console, I cannot access this host file. So, in other words, you need to run your Python program with a command line or terminal where you have administrative rights. And for the sake of building the program it's more wise to just copy this host file and just paste it here, where your script file is. The reason I'm doing that is because here I'll not have to open a command line as administrator every time I test my script. So once I make sure that the things are working well, then I just change the path. So at the moment I'll not work with this path. I'll work with this, let's say, hosts temp for temporary, and which is directly equal to the host's file name, because host is just here in the same folder with website blocker.py. And besides making a working copy of this host file, you also want to make a backup copy of the host file, just in case you make some errors there in your Python code and you delete the file, or you just delete some content from your existing host file. And I'm just gonna copy this and just put it here. So paste it there in my D drive. And yeah, I'll just close the path of the real host file for now, until I have a working script that modifies this host file successfully. This one here. Great. Now I can open this, actually here on the right, close it here. Good, I think this is a good layout for you to see the code well. And yeah, what do we have to do now? Well, we're checking the current time against these two other datetime values. And we have two scenarios. So in the first scenario, we are between these two times. And in that case, when we are between these two times, we want to make sure that we have 4 lines of text here in the host file, where each corresponds with each of these list items. Of course, together with the redirecting IP in the front. So the same format as you see here, but without the comment tag. And here we can go ahead and open this host file now with the open method and write the list items in the host file. However, we may also want to check first if these 4 lines already exist in the host file, because the host file can have 2 statuses. So the first status is the host file is without these 4 lines there, and the other status is the host file has these 4 lines. Therefore, you want to check for them. And to check these lines, you first need to read the host file in Python. So you want to apply a read method to your file, and then maybe add a loop that iterates through this list. And in each iteration, you apply a conditional that says, if a list item in content, where content is text you have read from the host file, so if that item is in the content, then don't do anything, otherwise add that item in the host file. So let's go ahead and do that. With open hosts path, sorry, that would be host temp. Host path is a path that we'll be using later. So host temp, we want to open that file using, well, if we use the read method, so R, we could read the file content, but we wouldn't be able to write within this statement, within the with statement. And if you pass W, you wouldn't be able to read. The middle solution there is to use R+. With that, you'll be able to read and write. So as file. And yeah, before writing anything, we want to first check there. So let's say content equals to file.read. And what content will contain is the entire text of the host file. And actually we could print that out just to see what we have this far. So normally you don't want to print that out, but in this case, just for demonstration. And it's also good to check where we are this far. So Python website blocker, and so yeah, we got the text of the host file printed out. And before that, working hours was printed out. And now every 5 seconds, the working hours and the content of the host file are being printed out. So I'll stop this. We're doing well. Now that we have the content, we want to iterate through the website list. So for website, in website list, for instance, the first item will be this one. So if facebook.com, if website, in content, so if this is in this content, in this text, and we are in the working hours in this part of the if conditional, so if Facebook is there already, we don't want to do anything, because that will already block our Facebook website. So we pass there, which means that Python will go ahead and check for other lines. So it will go here. So it says else will not be executed in this case because if was executed. So if that is not executed, then Python goes to the next line and it sleeps for 5 seconds. And then once it sleeps for 5 seconds, the loop starts over again and the condition is being evaluated again. Working hours is printed out if we are between these two times. And then we open the file again in the second iteration of the while loop. And we read the text and then we iterate in our list and check if any of our list items is in the text of the host file. And then we pass to the next lines if it is not there. And if it's there, we want to file.write. You do something like website. And yeah, we're almost there. We can check what we get this far so that you understand. So I executed this and now you see that www.facebook.com was added in the host file, and then the next item of the list, facebook.com, and then my Hotmail account, and so on. So the 4 items of the list, which means the structure of our code is working well. We just need to work a bit on the style, on the text formatting. And so we're printing out the website, but we also want the redirect IP in there. Actually, the first one should be redirect variable, this one. And then according to the host file style, we should have a space there. As you can see, it says the IP address and the host name should be separated by at least 1 space. And that's what we'll do. So redirect, what you can do here is plus 1 space within double quotes. And then we have plus website. And then to avoid the text being passed in one single line, you want to pass here the \n special character. That will create break lines between these text items. Great, now I can check this. Well, nothing will happen because Facebook is already there. So I'm just gonna stop this and delete this. And yeah, now it's working well. And by the way, if you have an antivirus in your system, you probably have some warning there because the host file is a bit sensitive. So your antivirus will be notifying you that some program is modifying your host file. If you want, you can just you can cancel this. Don't do any cleaning. You don't have to clean it because you know that you're the one who is accessing that host file. So cancel that. And yeah, it's working well, I believe. And we are done with the first part of the conditional. So now we are in this time, which is between these 2 hours. But if you were, let's say, 13 here, stop this, check again. In this case, we get printed out these fun hours, but the text in the host file will be still there. So what we want to do next is remove this text from the host file when this part of the conditional is satisfied. And we'll do that in the next lecture. So, see you there. Great. What we have so far is a script that checks if the current time is between these 2 times, and then it appends these 4 lines in the hosts file. So we're talking about appending because this R+ mode there means that you can read and append text in your file. And you know that writing differs from appending in that when you write text in a file, you are writing the text in the empty version of the file. So with write, you'd have only these 4 lines in your host file and not the other ones. Good, that makes sense. And yeah, that's the first part of our conditional. And if that happens to be false, then we want to execute something here. And that would be to delete these 4 lines. Now, as you know from the previous lectures of file handling in this course, there's no direct method to just pass some lines as arguments or as input and then have a delete function that removes those lines from a file. And that makes the situation a bit tricky. So our input here is this list with these names, with these items. Which means what we can do is, well, first logically you want to read this file and then check if these names are in here again, actually as we did in here, more or less. So let me start with that. Just open hosts temp, that's a file path. And again here we are reading and appending at the same time. So we want to use R+ there as file. And let's store this text in a variable. Good. And yeah, this will load the text in our content variable as a single string. So that's probably not the best solution. So the best solution would be to use read lines instead, which will produce a list with all the lines in our host file. So for instance, this has 25 lines. We'll have a list with 25 items where each item represents a string with each of these lines. So for instance, this will be the first string of the list stored in the content variable. So content is now a list. Now that we have a list, we can start checking these items against the list that we have grabbed from the host file. So if these items are there, we want to delete them. But as I said, there is no direct way to delete these items. We have methods to write content, so we have methods to append content in that file, but not to delete. However, we can make use of the append method. We could start iterating through these items in the content list and check if Facebook is in that particular item. So in the item string, if Facebook is there, then we ignore that line. And if Facebook is not there, we write that line in the hosts file. So something like this. Let's say we iterate through this and say Facebook is not there. So create a host file, like a new host file, with this line there, and then go to the next line. If Facebook is not there, then append this line to that host file. So we'll have 2 lines and then 3 lines. And then we will remove the lines which contain Facebook. I know this sounds very confusing at the moment. But once I write the script and I explain line by line, I'm sure you'll have that moment where you say, aha. So you'll get that once I write the lines here. So we're here, we read the lines, But as you know, when you apply a read method there, like read lines or read, the pointer will be placed at the end, at the last line, so here. So we read the lines there, we have a list, and now we can say for line in content. So we start looping through the content list. And here I'll use any method. So we want to check these items against the lines of content. And that would be something like if not any website in line for website in website list. File.write, so append the line. So what I did here is, let me simplify that by talking about the first iteration only. So we have this line here, the first line, copyright, etc. And we are saying that if not any website, so any item, which is still a variable, in that line, so in this line. And so what is this website variable? Where the website is the first item of the website list, which would be this one here. But this will create a loop. So it will check the first item there and it will compare it so against the first line. So we are in the first loop and we say if not www.facebook.com in that first line there, then write that line in the file. Otherwise, we wouldn't do anything. And so that would check the first item of the list, and that would go to the second item and check it against the first item of the host file, the first line of the host file, and then it will go to the third line and fourth line until this list is consumed. So that's for the first line of the host file. Then it goes to the second line and performs exactly the same thing. So it checks the 4 items of the website list again against the second line of the host's file. Yeah, I hope that makes sense. And yeah, I'll check what this does. But now it's 20 past 4. So we are in the working hours, and let me modify this. Let's say 16 to 17 are our working hours. So outside of this, we want to remove these 4 lines, which will be the case when I run the script now. Python website blocker run fun hours is executed, and 2 times. I'll interrupt this and check what we got. So we have this block here. We have this block here, and then the block is repeated. So it's not exactly what we want. And this ends, and then it repeats again. And it ends in here. And then it repeats another time. So the loop, the while loop, ran 3 times. And the first block, so this one here, was the block that we had already in the host file. And then what happened is that we opened this host file in read and append mode, and then we iterated through the lines of the host file, and then we said append only those lines where there's no Facebook or this mail.live in those lines. And Python did just that, so it appended those lines under the existing content. And it did it 2 times. Yeah, so sorry, I said the loop ran 3 times earlier. Actually, the loop ran 2 times, but we had 1 existing block here. So the other 2 times, Python appended this block again. Great. Even though we are not there yet, I'm satisfied with the progress because I think you are now able to understand how things are working. And now we need to put our logic into a very active state in order to make this work. So there are no new things that you need to apply here. It's just tricks. So you know about this truncate method, which what it does is it truncates, it deletes the content of the file from the current point and downwards. So for instance, if we apply that in here, what we would get is, so think about the first iteration only. So the first iteration will add the first block after the existing block, which is this one here. So this is the first block with all the Facebook things. And then the truncate method, what it will do, it will delete everything that is under this, which is not exactly what we want because we would still have these things above. So we need to figure out a way to put this block of code above this, above the existing one. And to solve that is by using file.seek. So you know that when you apply a read method to your file, for instance here you apply the first read method and the pointer will go here. So just after the last character of the file content. So when you apply a write method and append, you append lines, the lines will append after the pointer. Now, if you want to append these lines, as I said, if you want to append them before this existing block, you'd want to apply the seek method so that you replace the pointer, place the pointer just before the first character of the file content. What that will do is, it will get all these lines, so cut it from there, just to illustrate it, and it will place them in here. And then what the file truncate method will do is it will remove everything that is after that. And this as well. So we will end up with this text, which is what we want. Good. I hope I explained that well. And let me try that now. So I'll delete these and these. And this is the initial state of the hosts file. So we have these Facebook and Hotmail domains there. So I'll save this and the script as well. And I'll go ahead and execute. So it seems to be working well. Yeah. And if I change the hover, so let me, or I'll do a software wrap there. Okay, so that you see both the host file and the script. So now it's 3 to 4, and let me put this 15, so we are in the working hours, and execute this. And the lines are there. Interrupt that, put this 16, and try again, and the lines are gone. So this is working. Again, just to wrap up, what we did here is, so we're talking about the else section, and we open the host file in a read and append method, and then we store the lines in a content list. And that puts the pointer in here, which means that everything you do after that will be applied under these lines. But by applying the seek method there, we tell Python to put the pointer in here. Just here. And so then we iterate through this content list in this line and check that if any of these website list contents is in the current line of the content list. Actually, if it's not in the current line of the content list, then we write down that line in the host file. And then we truncate everything that goes under that line, which means we wrote all these 21 lines and everything that we had down here, so which was the previous existing host's text, that content was truncated, so it was deleted from the file. And yes, we're basically done. I mean, we still have some things to make this work, to be able to run this script as a Python process on the background, because at the moment the way we run this is by opening a command line and then calling Python and then pointing to website blocker.py. And also we need to implement one thing. So at the moment we are accessing this fake host file, but what we want to do instead is access the actual host file, which is here. So hosts, and to do that, you would first want to change host temp with host path. So host temp with host path. So where do we have host temp? Hosts. Yeah, it's here. So host path there and here as well. Now that's about it. But if you try this, you'll get a permission error because you're running that as a normal user. What you want to do instead is run that as an administrator. On Linux or Mac, that is straightforward. So you'd want to say sudo and then Python and then point to website blocker.py. However, sudo doesn't work with Windows. And so the workaround here is to open the command line from the terminal and right click and go run as administrator. Yes, and then you'd have to cd for change directory and then /d, which means I'm going to the D drive. So when you switch drives from C to D, you want to use this \d, and that would be Dropbox. Block websites and demo. Then if I run the script now, Python and website blocker, now it runs normally. So we are during the fun hours. It's 16 past 6. Oh, so yeah, we are in the fun hours. And if you check the script, the hosts file, you'll see that you don't have any websites there being blocked. So let me try this. Let me change this to 90 so that we fall inside the working hours. And run the script again, so we get working hours there. And if I go and check the notepad now, this is saying this file has been modified by another program, which is Python. And do you want to reload it? Yes. And yeah, we have these 4 lines there. If I try Facebook now, I won't be able to access it. But be aware though that sometimes if you have your browser opened and you just block Facebook or another website in your host file, the browser may not reflect it immediately. So it may take some time until the browser can get the information from the host file. If you want to speed up that process, you may want to restart your browser, so close it and open up again, and then check Facebook. And yeah, it should be the same for Hotmail as well. So it passes Hotmail, but then Hotmail, their servers redirect you to this website, which I'm blocking. And you cannot access that either. So this is working well, we're doing great, and yeah, what's left now is to implement this program to run it in the background. So there's just a few minutes of video left for this section and we're done. So talk to you in the next lecture. As you were able to see in the previous lectures, our script is now running very smoothly. So what's left to be done there is to make this script run on the background as soon as the computer starts, which means that the Python program, the script that we built, will run and it will check for the time, and then it will do something depending on what time it is. But at the moment, the way we are running this is by opening a command line and then pointing to the script. That command line remains open as the script is running. So probably we don't want that. We don't want to have the terminal open there all the time as we do work in our computer. So a better solution would be to find a way to run the script on the background. And there exists a solution. It's just that the workaround is different on Windows and on a Mac and Linux. So this lecture is about making the final touch to the program so that we can make it work on Windows to have the Python program run as a process in the background. So for Linux users and Mac users, you can safely skip this lecture and go to the next one where you can implement this script as a background process. So yeah, hello Windows user. I'm on Windows 7 here, but the solution should work on other versions of Windows as well. So how do we make a script run in the background as a process? Well, there's a simple trick you can do on Windows. You know, you have the installation of Python there. Let me go open file location. So when you're running a program, when you say Python and script.py, you're using this python.exe file, so which is an executable of the Python program. You use this program to run your file. Now, to run Python files on the background, you want to use python.w.exe, which is a specific subversion of Python for running Python scripts as a background. And there's a simple trick you can do. You want to change the extension to pyw. And once you do that, now you can go ahead. So here is the file, which extension I just changed. And what you can do now is just double click this to execute it. And there is no terminal shown, so the script should be running now. And you can verify that in the task manager. So this one here, which you can open, by the way. Right click in here and start task manager. And then go to processes, and then you should be looking for Python, for a process named Python here. And this time I expect this not to be here. So Python, yeah, Python is not here. So you should expect python.w.exe to be here. And the reason it's not there is that the script wasn't able to run because when you double click this, you are double clicking it as a user, not as an administrator. And if you're not executing it as an administrator, you're not being able to access this to modify this host file. Because as you know from the previous lectures, this is a protected file by Windows. But if you change this host file, let's change it to the host temp, which is this local file here, so the fake host file, where we don't need administrator rights to access it. Host temp. And now I go ahead and double click the Python file again. And now I should see python.w.exe in the processes, as you see here. So you don't really see any output printed out, but you can see maybe the results of this. So this is a host file, which hasn't been added the domains in here because this says the working hours are between 4 and 7 p.m. Now it's 2:38. So let's change this to 8 and 16. Save the script and go and stop this process because this is running the old file and process. And now run again the file and check the host file. And now you should see these 4 lines which have been added in here. Great. Now, let me stop this and process. And yeah, now we are able to run our Python file as a process in the background. Now let's go ahead and implement the scheduling part. So we want to run this program as soon as the computer starts. To do that, you want to go to Task Scheduler. Just there. And then create a create task. Put a name for the task. I'm calling this website blocker. And configure for, I'm on a Windows 7, so I'm going to choose that. So Windows 7, and one important thing to do is you want to check this run with highest privileges. Because if you don't do that, Windows will try to run the script from the normal user, so you want, in our case, we need administrative rights. So check that, and then go to triggers, and then new. So begin the task. When do you want to run the program? Well, we want to run the program at startup. Well, they should be fine. Then go to actions, and you want to create a new action. So what do you want to do? Well, we want to start a program. And normally you want to point to your program script, which is this one here, website blocker.pyw. Open that. Okay, conditions. And you may want to uncheck this option. You also want to run the Python program when you're on a battery on a laptop. And yeah, we should be good to go now. Press OK, and here is the website blocker task, which is ready to be run when the system starts up. So you may also want to disable it, but that's for another case. And yeah, now when you start your computer, the program should be running, and your Python loop will run every 5 seconds, and the Python program will check the host file and so on. So you may want to test to restart your program now, or you can go here and test it by clicking run. Now the status is showing as running, and you may want to check if the task is really running or not. And it seems like it's not running. So python.w.exe is not here. And the worst thing is that we don't even get any error now, because the task, the Python process is running on the background. And I know the reason why this is not running. You know, if you see in the script now, you'll notice that I'm still trying to modify the localhost file, whose path is being passed in here as a relative path. So this is not an absolute path like this one here. And the problem with that is, you know, Windows is now executing this website blocker.pyw script, is executing it from another directory. So it's not executing this from the Dropbox pp blog website demo. Therefore, it cannot find a file with this path. Therefore, the solution to this is to actually pass the full path of the file here. Because as we are now, Python is not trying to find this host file, so it's probably throwing an error that says the host file does not exist. So let's go ahead and I'll copy this directory, put it there, and hosts, a backslash there, and pass the R prefix so that you can escape special characters. Save that, and yeah, now go to the task scheduler and end this and try to run again. So it says running now, and let's see. And yeah, now this is running. So python w.exe, and you can also check the host file. So the lines are there, because it's between 8 and 4 p.m. So it's 4 to 3 of time. And yeah, the final thing we want to do is stop this very quickly and change this to the real path, host path, and this as well. Save it and go to the task scheduler and end the current task. So it's ready now and run it again. Go to the processes. Python w.exe is there, so it's running. You may also want to check the host file, which is in my notepad, and it says the file has been modified. And yeah, I can see the lines there, the 4 websites that I want to block. And maybe you're wondering why this first line is there, so it should be separated in here and be there, but the reason this line was up here was because the cursor was set to this point before executing the Python script. So you may want to set the cursor, so let me delete this. You may want to set the cursor in here before starting the Python program, so before implementing this program. Now I saved it and I now expect this file to be refreshed by Python again. So let me close that and open it again. And now, yeah, now this looks good. We have an empty line there, but that isn't a problem. So things will still work, even with Facebook in here like it was earlier. Things should also work. And everything looks to be working fine. I now cannot access Facebook between 8 AM and 4 PM. And that's all about it. In the next lecture, I'm showing how to do the same. So how to run Python as a process in the background for Linux and Mac users. And that will end this section. So hope you enjoyed it, and I hope you make the most of this program for your use, your daily use. If something isn't working there, just drop me a question or a message, and yeah, I'll be happy to help you. Or even if you have questions regarding the script. So I know this has been lots of indentation here, and probably you get some errors there, and probably that error is because of indentation. So be careful with indenting your lines. And yeah, I'll close this now, and I'll see you in the next lecture then. Thanks. Alright, this should be the last lecture of this section, unless I add more lectures in the future upon student request. So I'm on an Ubuntu computer here. I'm not on a Windows. And so for Windows users, you can skip this lecture if you want. If you like, you can follow this if you're curious on how a Unix-based computer looks like, such as Ubuntu. So this lecture is for those who have a Linux or a Mac computer, because in this lecture I'll show you how to make our Python program run when the computer starts. And for that we'll be using the cron service. Now cron is available both on Linux and Mac, so you don't have to install anything. Probably you know how to use cron already, but if you don't, there are just a few instructions that to make it work. And I'm gonna go ahead and open the website blogger.py, open terminal with right click and then Atom. So I'll be using Atom, which I have already installed earlier. And all we have to change from the script is the host path. So this was a Windows path, and on Mac and Linux that would be that one. And I'm gonna save the script here, go to the terminal, and I want to quickly check my host file. So I'm opening it with nano. And yeah, this looks good. I have no websites there that I want to block. Control X to exit. And yeah, what I'll do now is, before I try and add my Python script to be executed by cron, I'll go ahead and just quickly try the script with Python directly. Just a small change in here. Now it's 4:30, so let me change this to 17 so that we fall within the working hours. And I'll go ahead and sudo python 3 website blocker.py, execute, and yeah, it seems to be working. It prints out the working hours. Yep. Interrupt that and go and check the host file. Yeah, the lines are there. Great, this seems to be working. Control X to exit. So I hope things are going well on your Mac or your Linux as well. What's left to do now is to add this in the cron table. And to do that, you need to open the cron table file with cron tab with the E flag. Yep, and that opens the cron tab file. However, before you add any line here, note that the way we open cron tab, it opens up the file that is accessible by the normal user. So you may want to exit that and open a cron tab with sudo instead. The reason you want to do that is because we have to execute this website blocker.py script as an administrator, so with high privileges, because the host file is protected by Linux. So execute that and go at the end and say you shouldn't have this last line. I have this from another script, so ignore that. I'll add another line here. Reboot Python 3. So you need to write reboot there, which tells Ubuntu to execute this command when the computer starts. So that would be home, my short name, applications, and website blocker.py. Yeah, that should do it. So that's the path to my Python file. And Ctrl X and Y and enter, and that should be saved now. So if you open cron tab without sudo, you'll see a different file. But if you open cron tab with sudo, you'll see the lines that we have just added. Yeah, before I close this lecture, just a quick tip. If you're trying, for instance, to point to your local host file, which you're passing as a relative path here. So for instance, I'm not passing this as an absolute path like I'm doing with this one here. So if you're using Python to modify a file with a relative path, and you pass that command in cron tab, as I did here, Python will not be able to access that relative path, because cron tab will execute Python from another directory which is different from where the website blocker.py is located. So it's good to work with absolute files. And yeah, now this should be working well, and if I restart my computer now, the video will be stopped, so I can't really record the rebooting process. But if you have some problems, just drop me a message or post a question in the discussion. And yeah, I'll be happy to help you, as always. And if I browse Facebook, yeah, I'll not be able to connect, even though my internet connection is fine. So I hope that was helpful, and I hope you make use of this program. And I'll see you in the next lecture then. Hello and welcome to this new section of the course, and this is the very first lecture where I'll give you a demonstration of what you're going to be building in this section. So this is one of those sections of the course where you're going to build an application. This particular application is a website with Python. So yeah, Python can build websites, just like other programming languages do. Of course, you need HTML, and you may need CSS and JavaScript as well for the client side to render the web page on the browser. But on the backend, you use Python, just like you do with PHP and other programming languages. And yeah, the website that you're going to build is this one here that you see. I mean, it's quite empty for now, it doesn't have any content, but you can fill it with content and use it as a showcase for your work, as a portfolio or anything. So once you reach this point, you can improve it with easy. Also know that this website is now live, so I'll teach you how to deploy a website on a live server so that everyone can browse, can visit your website. So it's a complete tutorial to build a website from scratch and make it work online. Now this is a static website, but later in the course we have other applications where you'll be building more dynamic websites with a database on the backend and also some dynamic features. But this is a great point to start. So yeah, I hope you enjoy this section, and if you have questions, just feel free to ask. And yeah, I'll talk to you in the next lecture. Hello, and in this lecture you will build your first website with Flask, if you haven't done so already. And Flask is a Python framework that has all the tools and the templates and the functions for you to build websites with Python. And before going deeper into Flask and explaining you how to use Flask properly for building Python web apps, I would like you to spend 3 minutes to build a very basic website with Flask. And that is done with only 7 lines of Python code. So that's what we'll do right now. To build a web app with Flask, you need to have Flask installed. So pip install Flask should install Flask in your Python environment. Alright, that was successfully installed. And let's create our website now. What you need is a Python file. So I'm creating one here. Let's say script1.py. And then here is where you write the code that will build your web app. And everything starts from importing Flask. And actually you don't import the Flask framework, but you import the Flask class from a Flask framework. So from Flask imports Flask. And Flask is a class of this library, and this contains all the prototypes that you need to build web apps with Python. So this will handle requests for you. You don't have to set up requests yourself. But let's focus on this example for now. Once you do that, you need to create a variable where you'll store your Flask object instance, your Flask application. That will be equal to the Flask class, and you pass the name variable in there. Just don't worry about that right now. Then you need a decorator, root, and here is a URL where you'll view your website. So this slash here means the home page. And just after that, you need to write the function, the Python function. And this function is what defines what your web page will do. In this case, we will return a string. Let's say this string here. Website content goes here. Just after that, you need 2 more lines of code, and that's a conditional statement. If name equals the string main app.run, debug equals true. That's it. Don't worry about this right now. Just click save, open the terminal, and execute your script with Python. Script1 Python, yeah. And it looks like your web app is running now, so open the browser. And your website should be live on your localhost. That's it. Nothing impressive, but you see how easy it is to create a website with Python. And in this case, we are just returning a string here to the website. So there's nothing fancy in there. But later on, I'll explain to you how you can return HTML pages instead of plain Python strings to your website. That will allow you to actually have different formats, different fonts on your text. And then you can also apply CSS styling to your HTML, and so you'll have a complete website with modern features. For now, let's make sure you understand these 7 lines of code. Yep, it's 7 lines. As I said, the first line, you are importing the Flask class object from the Flask library. Then in the next line, once you have imported the Flask class in here, the Flask object in other words, you are instantiating that class, that object. And this here is a special variable that will get as value the name of the Python script. Now, when you execute a Python file, a Python script, Python assigns the name main, this string, to the file. When you import a script into another script, like if we import this script from another script, this script will be assigned the script1.py name. But when you execute this script, Python assigns the name __main__. So what happens is that in this line we say if name equals to main, then run the app. And this is true when we execute the script as we did here. But if we imported this script from another script, this line here would not be executed. So this allows us to have control over this script using this line here. Then we have these two lines. This is a decorator. Now the output that this function produces will be mapped to this URL. So if you want, you can change this URL to this, for example. Save the script. Sure, you need an URL here. Save the script, run, and go to the localhost, reload, and this time you'll get an error. Python couldn't find this page, but it can find the about page. Yeah, that's it. If you still want an home page, you would add another decorator and another function just after the decorator. So just leave this home page and just say home page here. Save. Again, we have an error because we cannot have functions with the same name. So we can change this to about. The name doesn't matter, so this doesn't have to be the same with this one. Click save. Run the script again. And go to the website. This is working. Try the web page, the home page. This is working too. If you want to change something, let's say about, content goes here, you save the script, and the web app will restart by itself, so you don't have to close the web app and run the script again as I did earlier. If you get an error like I got previously, the script will stop. But if everything is alright, you will not get an error, so try this again. Home page is fine. The about page is fine too. And with the new content. So that's about it. In the next lecture, you will learn how to return an HTML template, an HTML file, using your Python functions. That will give you full power to publish anything that you want in your website and not just plain strings as we did in this lecture. So see you in the next lecture. Welcome again. In this lecture, you'll learn how to generate HTML pages using your Python web app. In the previous lecture, we simply returned some plain strings, as you see here. So return a string. Now we will return an HTML template in here. And to do that, we need to use the render template method of the Flask library. And what render template does is accesses an HTML file stored somewhere in our Python application, in our Python files, and then displays that HTML on the requested URL. So we need to replace this with the name of an HTML page, let's say home.html. And this name here, this file name, has to reflect a real HTML file, which has to be stored in a folder, which itself has to be named templates. So be sure you use these names when you create a folder. Inside the folder, then, you need to create an HTML file, home.html. And the name has to reflect the name you are returning here in the render template method. That's it. And here is where you write the HTML code now. If you know HTML already, this should be as easy as breathing. If you don't know, then it should be easy to learn. If you know a bit of Python now, which you should, learning HTML is just a breeze. So just go ahead there and learn some HTML. It's that easy. But anyway, I'll create an HTML file here. Everything starts with a declaration of the document type, HTML. Then you have the HTML tags. That was the opening tag, and you also have a closing tag. That's it. You have body tags. Just like that. And inside here goes the content of your web page. So let's say I want a heading like this. And inside here you can put some text. My home page, for example. And yet another different type of tag, which is a paragraph tag. And say this is a test website. Click save. And yeah, you should be good to go. Go to your script, make sure you have saved it. And the web app is restarting, and I'll go now and visit my homepage. This is the about page. This should be the home page. Yeah. I seem to have a little typo in here, I guess. Yeah, this should be h1 as the opening tag. Click save, and you don't have to rerun the Python script. Just go here, reload the page. And this is normal text now. So this is a paragraph, and this is heading. Great, so we can also have another page for the about page. If you want, just quickly duplicate this. Say about my about page here. This is a test website. Again, just like that. You go to your script one and change this to render template, and there you pass about.html. Click save. Go to the localhost. This should be the home page. You have the about page. Yeah, my about page. This is test website again. So that's it. That's how you pass HTML templates to your Python web app. And that's how you map them to your URLs. Let's move on then to the next lecture. Okay, in this lecture I'll continue working on the website. And specifically, I'll be adding a navigation menu so that the user can easily navigate through the pages. Let me illustrate the idea first. First, I'd like to execute what we have so far. So Python script 1. So the application is running. And if you go to your browser, your local host, the default port is 5000. And this is the website. And we also have two pages here, about page. Good. So about page and home page. Now what I'll be building in this lecture is this thing here. I have a screenshot. So the home page, the about page, home page, the about page. So what we have is a navigation menu here, which if you click one of these texts here, you'll go to the specific page. And we also have a heading. And something you should notice now, which is important to notice, is that this part here is the same in both pages. That means we will add this part here, the code of this part, in each HTML page. How does it sound? Well, it doesn't sound very smart to me. A smarter way to do this would be to actually create a separate HTML page for this part here, and then link the about page and the home page to this page. So that's what we'll be doing in this lecture. So we need to have the HTML code for this header here and the navigation menu. And I already have that code, so I'll not go and type down all the HTML code here, right? But I'll explain to you what the HTML does. So first of all, I'd like to actually double click this and just show it locally. So we're not running this on a server. I just double clicked it. So we have the header here and the navigation menu, which if you click, you don't go anywhere because we haven't yet linked the layout.html page with the about and the home page. And as you can see, I put this inside the templates folder. So every HTML page goes to the template folder. So what we have here is we have the document declaration and we have the HTML tags then, closing here. Then we have a header element, and this contains a div here. And we'll be using this class name later to refer from our CSS code. Then we have a function here which says URL for. And what this does is that this will trigger the home function, the Python function, which we have here. So this one here. This function will be triggered when the home link will be clicked by the user. So this one here. And so the same for the about. So when a user clicks about, the Python function will be executed and the about.html file will be rendered through the render template method. So I hope that is clear. If you're lazy like me and you don't want to type every line of this file, you can find this file in the resource section, which is on the right of the screen. Now we need to figure out a way to link this layout.html file with the home and the about.html pages. I'll quickly go back to how the page looks like. And so as you see here, we have the header, and just down the header, we have the about.html page. So just here. That means just under the header, we will enter some code that will link to the home.html page or the about.html page, depending on what the user will click. And so we'll have a div division here, closing it. And I'll give it a class name so that I can refer later to the CSS code. Then you have curly brackets. So that's the syntax, and you also have to use %sign there. Then you write the block tag, and then you give a name to the block. And what we're doing here is actually template inheritance. So the layout.html page, which we are modifying right now, is a base template. The child template will be the home.html page or the about.html page. And these child templates will fill in this block here. And there is another line inside curly brackets and %signs as well. That is the end block keyword, which indicates the end of the block. And we are done with the layout.html page. What I'll do here is go to panes and split the window right. So I have the layout.html page here, close it here. And I'll go to the home.html now. And because this will be a child template, I don't need the declaration here and the HTML tag, and I don't even need the body tag. I'll replace this with a div. And let's say class equals home. Close that here. And delete this too. And what you have to do now is use the templating syntax again, like that, and use the keyword extends. And then you declare what you want to extend. So layout.html file. Then you also need another line. And here you need to specify the name of the block. So this needs to correspond with this one here. And so what's going on here? Well, let's go to the script, to the Python script. What happens is that when the user visits this URL, so the home page, or this one, let's say this one, Python will execute the home function because the home function is mapped to this URL. And the home function will render the home.html template. So Python will go to the home.html page and it will see that the home.html page extends the layout.html. So this one here. So what it will do is that it will send this code in this block in here, and then this page will be rendered in the home URL. So as simple as that. The user will see the layout.html page with its child content. So this is a base template, this is the child template. And we also have another child in this case, which is the about.html. So let me bring this here. And I'll just copy this and put this here. And this as well. Control C and yeah. Make sure you have saved all the files and this one. Yep. And let's take a look if the app is running. Yeah, it looks live. And I'll go to the home page. Yeah, looks good. We have home and about. Let's go to about link. Yep. We have seemed to have lost the heading here, the format of this line. Let's have a look at the about page. Yeah, I forgot to close the div here. Save again. Go to the browser. Reload. And it's fine. So that's about it. I hope things are working on your side. If not, please feel free to ask a question, or you can even check my files, which I am putting in the resource section on the right of your screen. And yeah, I think our application is ready for more. So let's move on and see you in the next lecture. Great, we have progressed quite a bit. We have a Python script that generates a Flask app, and we have two functions. And each of them maps two HTML pages to two different URLs. And this is our website with two web pages. In this lecture, we will add some CSS styling to this website so that this looks just like any other modern website and it is visually appealing and it doesn't look like in the 80s. Alright. To do that, we have to do basically two things. The first thing is we need to create a CSS file and write the CSS code inside it. And the second thing is, once we write this CSS code, once we have the CSS file, we need to link to it from our layout.html file. CSS is as easy as HTML, so if you don't know it, I would suggest you look at some tutorials, and I'm sure you'll get used to CSS very quickly. And I already have a CSS file that will stylize my website. I'll cut this and put it in a folder which I'll call static. Inside here, I'll create another folder and call it CSS, and I'll paste the CSS file just inside here. So let me close this. As you see, the folder I created and the file has been reflected in the tree view here inside Atom. So the idea is that Python looks for static files in the static folder. So here inside static folder you can put different files. For example, if you want to add an image to your website, you'd create a folder here called images and then put images inside that folder. Then you can link those static files from your layout HTML page or from any other pages. Now, before opening the CSS file and going quickly through it, I'd like to show you how you can link to the CSS file. Now remember, the visible part of an HTML code goes inside the body tags, while links, like links to JavaScript files or links to CSS files, go outside of it. And those should be put inside head tags. So head here and head there. And then we have a link tag. And the rel there means the relationship. So the relationship to the file we are linking to is a style sheet. So we are sort of declaring the type of the file we are linking to. So it's a CSS style sheet. And then we have the reference here, which will be equal to the URL for function, which takes as argument the folder name where the file is located and file name parameter, which is equal to CSS main.css. So what we got here is we declare the type of the file we're linking to, and then we put the link of the file, and it should be in quotes, so all of this. And I'd also like to add a title for the website. Let's say Flask app. That's it. I'll save this. And I'll go and try out the website. Oh, can you see the difference? Yep. We have the menu here, very nicely. About page, home page. And we have the title, just here. And then the content of the web page goes here. Now all these bars here, the background color, the paddings, all these have been defined using CSS. So let's go ahead and have a look at the CSS code. Here it is. I believe this is quite self-explanatory, but anyway, what we have is, basically, this is an HTML element. So the body is here. And once we write the HTML element in the CSS script, we use curly brackets, and then inside the curly brackets, we define these attributes. So the margin, the padding, the font family for the text, and the color of the text. If you want to change this, let's say 999, save and go to the web page, reload, you'll see that the text got some different color. So this is quite grayed out. So that means this attribute here is affecting the body of the website. I'll put this back to 444. Then you have the header element, which is responsible for this header here, so at the top. Then if you want to stylize a specific part of your web page, let's say only the logo, which is this one here, you'd have to refer to the header first, and then to the h1 element, and then you refer to the logo class. So this is a class name, just here. And so on and so forth. You can look at this code at your own pace, I believe. So the logic is the same. Great. And now we are ready to deploy this website online on the cloud. So we will do that in the next lectures. See you there. So we have a running website, which looks quite good. The problem is that this is in our local host. So the only person seeing this is, you, or someone who has access to your computer. So what we want to do instead is to deploy this website on web server or on cloud, as we will do in this course. And we'll be using the Heroku cloud. Heroku is a service that allows you to deploy Python applications in their cloud. The good news is that you can deploy an application for free, and you can have your public domain for free as well. Though you'll need a subdomain of Heroku, so something like, let's say, ardit.heroku.com. However, if your site will have a lot of traffic later on, you'd want to actually upgrade your plan and buy more bandwidth. Deploying on Heroku is relatively easy. You don't have to think and to do any administrative work. So Heroku saves a lot of time and effort so that you can focus on programming instead of the server parts. Before deploying to Heroku though, we need to do something. There is something that we should have done since in the beginning of this section, so even before writing any file here. And what you should do is that you should create a virtual environment, which is isolated from your other files and from your main Python installation. So to run our application, we use Python, which is coming from our main installation. So this one here, the ones I have here. This is not a good practice. A good practice is to actually have a clean installation of Python, which is used only for your application. So in that installation, you don't want to have libraries installed, libraries that you don't need for building Flask applications. Therefore, we need to create a virtual environment. And here I'll show you how you can do that. To create a virtual environment, you need to use a virtual env Python library. And to use the virtual Python library, you need to install virtual env. So pip install virtual env. So we are using the main Python installation here to install virtual env. Great, that was successfully installed. And now we will create a virtual environment. The virtual environment should be created at the same level with a main folder that holds the application files. So if we go to our directory, just here is where the files are. And what I'll do is create a main folder in here and call it my site. And I'll close Atom for a while. And this would go inside this. So just here. And now you can open Atom in this directory, because here is where we will create the virtual environment. So let's open the command line now. And we are ready to create a virtual environment. And to do that, you should use the virtual env library by saying Python, the env argument, then you have venv, which is the name of the library, of the module. And m here is an argument which allows Python to locate modules for execution as scripts. Then you need to specify a name for the folder where the virtual environment files will be stored in. So that should work. Let's see. The virtual folder was created. And yeah, the environment was created successfully. What we have here is an isolated installation of Python. And inside scripts, you'll see that you have Python there. Here it is. Okay, don't worry about that. And here is pip as well. So pip.exe. And that means you can use that Python if you like. Let me try out. So we are now at the my site directory. That means we need to refer to virtual scripts and Python. And that will trigger our fresh Python in the console. However, we are not interested to actually run Python from the shell. So I'll just exit this. And what we're interested instead is to actually run the Flask application using the fresh installation of Python. But before we do that, we need to actually install Flask in our virtual Python if you like. And to do that, you need to use the pip library of your isolated Python. So you need to point to the virtual folder, to the script folder then, and then to pip install Flask. And so Flask is installing, and it also installed its dependencies. And we should be good to go now. So let's run our web app using our new installation of Python. To do that, you need to point to the new Python, and that to demo, because we are in my site now, as you see here. So demo / script 1.py. That should work. Great. And if you go to the website now, you'll see that it's working fine. That's it. Now you are more than ready to deploy your Flask application on the cloud. And we'll do just that in the next lecture. And I would like to mention it again that please keep in mind that you should always create a virtual environment before you create your Flask application. So before writing any code, you should use a fresh installation of Python. Let's go ahead now and deploy our Flask application in a live server, which in our case would be the Heroku Cloud. There are around, let's say, 15 steps to go through for deploying your Flask application on Heroku. And we'll go through all of them step by step. And before we go to step 1, I would like you to know that if you're aware of deploying websites that are built on PHP, based on PHP, with these websites, it's fairly simple to deploy them. All you have to do is just upload all the HTML and the CSS and JavaScript and PHP files as well. You can upload them to your server directory using software such as FileZilla, and then you're good to go. However, with Python, the process is a little bit different. You'll deploy your application from your terminal, from your command line, from your computer. So there are a series of commands that you will want to give to the terminal so that we have these files uploaded in Heroku. So yeah, I suppose now you have a running website. So your Flask website is running correctly on localhost, and you also have a virtual environment which we set up in the previous lecture. So let's start with step one. Step one is you go and create an account in Heroku. So it should be somewhere in here. So you go to sign up and just create an account. So once you have that, then you can go ahead and log in. And yeah, dashboards should be your homepage once you log in. And under personal apps, which is this one here, you'll see your apps listed in there. Now, if you have just created an account, you'll not have anything, but I have this test 702, which I have created. And so the idea is that you first need to create an account in Heroku, and then you create apps. Now, to create an app where you will store your Python files so that you can access the website from the web, you can either go here to the plus sign and then create new app, or you can do that from the command line. And that's what we're going to do. So we're going to be using the command line to do everything. Yeah, basically we're done with the web page of Heroku. So step one was to create an account. Step two is you need to download the Heroku tool belt. Heroku tool belt. So it's served by Heroku. This is a tool that allows you to communicate with the Heroku server through your command line. So basically we'll be sending commands to the Heroku server. We need to download and install Heroku for that. So just go ahead and choose your Heroku for your operating system, and then just go ahead and install it. And once you have done that, you go ahead and go to the directory where your main file is, your Python file, and shift right click for Windows and open a command window here. So you can either do that with Terminal Plus inside Atom, but my Terminal Plus is not working at the moment, so I'm using the simple command line, which is the same thing. I mean, it's nice to have the terminal inside Atom here, but this is also the same thing. So I am in the demo folder. So demo, where my script 1.py file is. So what I'm going to do is point to Heroku and log in. So you can do that after you have installed Heroku tool belt. So what I'm trying to do here is log in to Heroku so that I can send commands to the Heroku servers. And yeah, my email was auditsuche.com. So that should be the email that you use to create an account in Heroku, and then the password that you chose there, and execute. Oh, my login failed. I seem to have entered the wrong email. Sorry about that. Login again, or did switch Hotmail? Yeah, now it should be fine. Now I'm logged in successfully, so I can go ahead and send commands to Heroku. So yeah, at this point we have covered 3 steps. We created an account on Heroku, and we installed the Heroku tool belt, and we logged into Heroku. Now, we need to create an app. To do that, you again need to point to the Heroku command, and then create, and then give a name to your app. So let me try Ardit there. I say I'll try because sometimes an app name can be already occupied by someone else. Because, you know, the name that you give to your app will be set as the domain of your web application. So it would be something like ardit.herokuapp.com. So let me try this. And yeah, that was successful. Obviously, there are not many people named Ardit, so that was good. And yeah, if you want, I mean, this is not a requirement, but if you want, you can list your apps using Heroku apps just to see what apps you have. And yeah, I have now 2, Test 702 and Audit. And yeah, great. Now we have an app on Heroku. And if you want, you can go and access your app, actually visit your app, audit.heroku.com. So Heroku.com or HerokuApp.com is the same thing. So basically what we have is just a default web page there that is waiting for some custom files to build a website. So in our case, we want to upload a Python application, and then we will have a website based on that. And yeah, this is how your app should look at this point. You know, this is different from, let's say, a random name that doesn't have an app. So this says no such app. But our app says welcome to your new app. So let's go ahead now and upload our files there. Now, to upload files into Heroku, we should use Git. Now, Git is a version control system, and it allows us to deploy an app to Heroku. And now you should have Git installed, but the good news is that Git is installed by default when you install the Heroku build. So Heroku build is based on Git, and it installs Git for you. But if for any reason you don't have Git, then you should be able to just search on Google for Git and just go ahead and install it. And once we have Git installed, then we go ahead and initialize a Git repository. But before we do that, actually, we need to have 3 files in our app directory. So I'm talking about this directory, which is where our main Python file is located. So script1.py file. Because here is where we have the app instance. So we are creating this Flask object here. And yeah, in here, what you want to do is open a command line, or you can use this one, but I wouldn't interfere with that. So let me open a command line in there. And we need to create 3 files. The first file should be named requirements.txt. So we should create 3 files. And then we upload these files together with our Python file and the CSS and the HTML files to Heroku. And Heroku will recognize these files because we'll give them specific names. And so in these files, we'll give some instructions. The first file is a file called requirements.txt. And what that contains is it should contain a list of dependencies that you want Heroku to install in your Python, in their Python installation. So we have Python and we have Flask installed in our virtual environment. So we should find a way to tell the Heroku servers that please install Flask for us. And that way is by creating this requirements.txt file. So I'll show you how to do that in a bit. Now we have Flask installed, and you can have a list of all packages and libraries and modules that you have installed in your Python installation with pip freeze. So that should list all the packages and libraries and everything. Beware though that what I used is pip freeze. So I used the pip of my main Python installation. So we're working on a virtual environment, and what you want to do is you want to point to your virtual pip, so to say. Now my virtual pip is somewhere here, and so here is the demo folder where I'm currently demo. So you should be really careful with directories. Then back, so demo virtual scripts, and here is my pip. So just there. That means this is the current directory. So I need to go back 1 directory. With 2 dots, you go back 1 directory and then point to virtual, and then scripts, and then pip, and then freeze to get a list of packages that you have with your virtual environment. And yeah, I have Flask and its dependencies. Now we need to insert these in a requirements.txt file. Before doing that, actually you need to install one more library that is called Gunicorn. Like that. Yeah, pip install Gunicorn. Let me expand this. Yeah, that's all I can do. Install. That was successful. So why do we need this library? Well, this is an HTTP server, so we need the server actually. Heroku server needs this to run your web application. If you do pip freeze again, you'll see that Gunicorn is there, and you also see the versions on the right. So to throw this in a file, you can do something like that, and the name of the file requirements.txt. Yeah, that should be okay. Great. This is a file, and yeah, we have all the dependencies there. Great, so that was the first file that I mentioned. We have 2 more files to go. The next file is a proc file. But be careful, you shouldn't have any extension in there. So that's a file without any extension. And just go ahead and edit it with whatever you want, or Notepad, or just here in Atom. So this should contain a line, and that would be web, a colon, unicorn, corn. So what you're doing is you're telling Heroku what to use, what web server to use to run your application. So we're saying use Gunicorn, and then Gunicorn has to point to script 1. So that's the name of our file, and a colon there, and then app. So again, a proc file is in the same directory with our script1.py, and it should be there. And then what you do, then you point to the file name of your Python file name, and then app. App is the name of the variable that is holding the Flask instance. So app there. Yeah, I hope that is clear. That's all you have to do with proc file. Just save that and close the file. And yeah, one more file now. And that would be a runtime file. Runtime.txt. What that should contain inside is the Python version that you want Heroku to run your app with. You can make it without creating a runtime.txt file, but in that case, Heroku will run your application using Python 2.7. So that version. If you want to run your application, so if you want Heroku to run your application with Python 3.5, you'd say Python 3.5.1. So why did I insert this? Well, Heroku actually, they have these 2 available runtimes. No, so supported Python runtimes. You can either specify this, which happens to be the default one, so you can get away without specifying this. And then they have 3.5.1. If maybe you have 3.5.2 in your computer, but that doesn't make any difference. So if you have 3.5.2 or 0.3 or whatever, you still have to specify 3.5.1 in the runtime.txt file. And yeah, save that. And all we have to do with the files. Eventually, we can go ahead and upload this file to Heroku. All these files that we have in this directory here. Great. To do that, you first need to create a Git repository. So you say git init for initialization, execute that, and as you see, you got a .git folder created in there. So that contains your local repository. So in other words, these files now are recognized by Git, and they will be uploaded into Heroku. So this is how this looks like. And now we want to add these files to the Git repository. To do that, you say git add and the dot. So what the dot says is, you're adding the files of the current directory. So the dot points to the current directory. And yeah, that was successful. And then you want to commit the changes. So you added some files, and later we will see when we make changes in the website, in the web application. And whenever you make changes, you say git commit with the M flag, and then you have to write some nodes there. Let's say first commit. When you do the second commit, maybe you change something in your web application. Maybe you added another web page in your website, and you'd say something like web page added or something like that. So this says 8 files changed. So why 8 files? Well, we have 1, 2, 3, 4 files in here, and we have 3 here, so 7, and 1 here, main.css. So we have 8 files that were actually added to the local repository. The next step now is to push the changes to Heroku. So we want to push to upload the Git repository, the files, to Heroku. However, first you need to do something. We have 2 apps in our Heroku account, but we haven't told Heroku which app we're working on. So to do that, to point to one of your apps, you want to do Heroku git remote, and then the app flag, and after that goes the name of your app. So everything that you do now is applied to the app that you referenced in this command here. Now, to push the changes to Heroku, so to eventually upload the files, you do git push Heroku master. Now, if you're doing this for the first time, you may get an error from Git saying that Git wasn't able to recognize you. In that case, if you get an error from this after executing this line, you can go ahead and authenticate with Git. That's actually very easy, so nothing to worry about. You say git config and global with 2 dashes in front, and then user.email, and then in quotes, you want to pass your email. You can use the email that you use for creating a Heroku account. So something like .com, and you execute that like that, and then you need to do one more thing. So again, git config, and then global user.name. So the username this time. Just pick a username that you want. Just like that. And once you have done that, then go ahead and push the changes to Heroku. So that would be, again, git push Heroku master. So I'm providing all these commands in a separate file, so in a text file, and you can find this in the resources in this lecture. There you'll find the commands in the correct order, as we are executing in this video. Execute, and hopefully this will be successful. Python app detected. So yeah, something important is that you want to be in a directory where your Python file is located. So that's how Heroku will detect that you're running a Python file. If you're, for instance, if your directory, your current directory, here would be something like website my site. Here, so website my site and not demo. So if you would be somewhere here, Heroku wouldn't be able to push the changes. So, and yeah, this verifying deploy done. This was successful for me at least. And now you can go ahead and browse to your web page. So in my case, it'd be audit.herokuapp.com, or you can open the browser by doing Heroku open in the command line. And yeah, here we go. My app is live now, and it's a working app, so I can navigate through the website and so on. So yeah, that was about this lecture. And Heroku info, you can get info about the current app. You have things like the Git link in there and to the owner and the URL of the application and so on. And that was about how to upload a Flask application into Heroku. This is a bit delicate work if you're a beginner. So if you were unable to do this, then you could download the text version of the commands and try to run them again one by one. And you can also ask questions and just tell me about the error you're getting, and I'll try to help you. And yeah, we still have one lecture to go. In the next lecture, what we'll do is I'll make a simple change to the website and see how we can upload the changes to Heroku. So we're talking about maintaining our website now, our web application. And yeah, let's move on, and I'll talk to you in the next lecture. Well, here we're going to talk about how to maintain your website. And by maintaining your website, I don't mean you have to go to your website every day to check your files and see if it's running or not. So that process is automatic. You don't have to do routine maintenance. But what I mean by maintaining your website, I mean, you may want to change something from your website. You may want to add a page or update a page or change the CSS styling or add another function to your Python script, etc. Only in rare cases you build a website and you put it online and then you don't change anything. That doesn't happen very often. And yeah, so how do we go about updating something from our website? Well, now our files are both in our local file system, so which is here in this directory, but they are also on Heroku. So if you want to change something, you'd first change that in the local directory. For instance, let's say this is the about.html page, and what I would want to do is I want to add another line. So I'll paste that and let's write something. This was added later. Now the middleman here is Git. So Git serves the role to connect your local files to the Heroku server. Which means now that you made a change, you can save your changes and then you can push the files again to Heroku. And actually, if you save the file now, Ctrl S, you'll see that in the atom directory tree, the about.html file name was colored in orange. That means you haven't pushed the changes for that file. So in other words, the file is different from the file that you have on Heroku at the moment. But if you test your website on localhost now, you'll see this change. So let me do that. And before I do that, I would like to change something on the CSS file as well. So 060, save that. And you see that CSS is also colored in orange. So I'll save that and go to the demo directory, or shift right click. I'll just go ahead and execute script1.py using my virtual Python, so to say. Yeah, that is running. So just go localhost. And yeah, this is the web page. So about. Yeah, we have 2 lines now. This was added later. You can also see the change that I did in the CSS file. So now the text color is green. Sometimes you may not see the changes right away, the changes that you do to your CSS file. In that case, you want to press Ctrl R to clear the cache when reloading a web page. So we're talking about localhost now. Yeah, once you see that the website is working well on localhost, so you make sure your website is working perfectly, then you upload the files to your live server. So you test things first in the development environment, which is my local computer, and then you push those changes to production. So yeah, I can go ahead and close this. And let's go ahead and now apply the changes to Heroku. So to do that, again, you would open a command line in the root directory, which is demo in my case. That's the directory where my Python file is located. Yeah, so you need to log in again. Heroku login. Enter your credentials. Alright, so logged in successfully. And then, to make sure that you're connected to the appropriate Heroku app, you could try Heroku info. And that would return ardid for my case. We suggest that Heroku knows what app you're pointing to. So if you don't get any information on this, if Heroku, if you get a message saying that you haven't specified an app, then you go ahead and write the command that we used in the last lecture, which was Heroku git remote, and then you specify the app flag, and then you pass the flag, the app name, like that. You execute that, and then you're connected to the ardid app in my case. In your case, should be the name that you have specified. Once you do that, then you could try again Heroku info to make sure you get the credentials for that app. And then you go ahead and add the changes to the Git repository. So that would be git add and a dot, like that. Execute, and then you need to commit the changes with git commit the app flag, and then you write something here, a note. You could say normally you write in the current tense, which would be add text to about.html. The other change that we did was change heading color. So that's the two changes that we made. Execute that, and you should see a message here saying that two files were changed. So we changed the about.html and the main.css file, and we inserted two pieces of information. So the first one was this paragraph line here. This was added later. And the next one was 060 that we added in the CSS file. And we also deleted something, which was 444, so the previous color that we had for the heading. And once you commit the changes, you want to push them. Git push Heroku master. Alright, that was successful, so now you go ahead and open your website. Your website should pop up. And then you can see that the new changes have been applied. So we have this dark green color there. And the about page should also have two pieces of text here, so 2 lines. And that's about it. I hope I was clear in explaining this. And it's quite a safe method to apply changes. And I hope you enjoyed this section of the course. And we'll move on. We have more applications to build. And you have quite a lot of things to learn by building them. And I'll see you in the next lectures. Thanks. Hello and welcome to this new section of the course. In this section you're going to learn how to build graphical user interfaces with Python. And specifically we're going to use the tkinter library for that. So in this section you're not going to build any real world program. I'll introduce you to the tkinter library. And of course, build a graphical user interface, a small program that can get you started with tkinter. And then in the next section, so once we are done with this section, in the next section, you're going to learn how to interact with databases with Python. So we'll be using Python as a wrapper of SQL code so that we can store data in a database, query data, delete, and so on and so forth. So that was the section after this one, and then in the third section, after these two sections, we're going to build a real-world program. And that program is this one here. So I called it bookstore, and what this does is, it allows you to store book information in a database. And this is a graphical user interface. So this program is made in 2 parts. You have a graphical user interface, which are these buttons here, which are called widgets. And this was built with tkinter. And then you have the backend, which consists of code that communicates with a database. So, for example, if we press the View All button, we are querying the database to load all the books for us. So we have the title. So if you press one of them, you get the title here, the author, and the year of the book, and also the book identification number, which is called ISBN. You can also search for an entry. So if you want to search for an author, you would write the author name in here and press search. And if you want to add an entry, you just type that in. And yeah, something like that. Add entry. And if you load them again, your entry should be here. So this is a program we're going to build two sections after this one. So let me close this one here, and in the next lecture I'll introduce you to the Tkinter library. So we'll be building some simple interfaces with some widgets. See you in the next lecture. So here we go. I have opened up Atom here. So I'm going to use Atom to build the bookstore program, so to say, that uses Tkinter and SQLite 3 as libraries. So I'll go ahead and create a new Python file in here. Let's script 1.py. Now, to build graphical user interfaces with Tkinter, you need the Tkinter library, and you don't have to install it because Tkinter is a built-in Python library. So all you have to do is go ahead and import Tkinter. If you are on Python 2, this would be with a capital T. In Python 3, it's Tkinter, simply like that. Good practice, however, is to actually import everything from Tkinter. So from Tkinter import all. So why we do that? We do that because we're going to use a lot of Tkinter objects in our scripts. So it makes sense to just load them all instead of referencing them with Tkinter.button, for example. Instead of doing that, we can just say button, then we enter the parameters and so on. So let me create a graphical user interface then. Now, a Tkinter program is made up of two main things. We have the window and you have the widgets. So, for example, the window is all this program here that you see, and then you have buttons and things like that, which are called widgets. So first of all, you need to create the window, and I like to call my variable window, and that would be equal to tk. That's it. That would create an empty window for us, but we need to do something more here. We say window.main loop. This is always necessary. So we open a window, we create a window, and then everything goes between these two lines. So you create widgets between these two. And this is necessary because if you don't have this, your program will open up and it will close in a split of a second. So basically this allows you to actually press that X button on the corner of your window and close the program. So this should be always at the end of your code. Now I'll save this script and going to execute it. And we got an error. It says tk is not defined. So Python is not recognizing this function here because it should be capital T. And execute again. And this is the window. And it has nothing inside, so let's go ahead and add a button. So we store the main window in a variable, and we're going to do the same for widgets. So we're going to create variables. Let's say b1 equals to button. So the button is the function that generates a button widget. The button function takes some arguments. If you want to get a full list of arguments, you would want to do some code introspection. Let's say IPython here. And from Tkinter import all, and then let's say button and a question mark. And here you can see what parameters you can pass to the button function. Now, the very first parameter you'd want to add to a widget is the variable of the window, of the main window. So you need to tell your widget the window that the widget has to be packed to. So window, and then you can pass parameters like the one you see here. Let's say one of the main parameters would be text. So text equals, let's say, to the string execute. So that is the text, the label that will be displayed over the button. Now, if we try to execute this script now, you'll see that we don't have a button yet. And that's because we haven't specified where to put that button. To do that, you need to use the pack method, which is a widget method, and then execute again. And now you see the button. However, there is another way to actually put your widgets in your window. That is the grid method. And often is a matter of preference, so whether to use pack or grid. But the idea of grid is that with the grid method you have more control on the position of your buttons and your widgets in general, because here you'd specify the row and the column where you want to put your button. So everything starts from 0, and so the first row has an index of 0 and the first column has an index of 0 and so on. I actually found illustration for that. So this is a Tkinter program, and we have two rows here. So we have this first row which should have an index of 0, and you have the second row which should have an index of 1, and you have columns, so 0, 1, 2, 3 and so on. Let's say the OK button, which is this one here, would have a row of 0, 1, 2, so 2 for the row, and then 0, 1, 2, 3, 3 for the column. Then you might also have widgets which span in more than one row or column. In that case, you'd add another parameter here called row span. And that would be equal to a number. Let's say if you put 2, the button would span in 2 rows. In our case, this is not necessary, actually, because we don't have lots of widgets. We only have one button. And so let me execute this script now and see what we get. So we get a button, which actually does nothing because we haven't specified what action to perform when you're pressing the button. And I'll explain that in the next lecture, but for now let's add some more widgets here, just for you to get more familiar with widgets. So let's add an entry widget, and let's say E1 for that. So entry1 equals to entry, and then guess what is the first parameter, and that's the window parameter. And we can leave it like that for now, and let's say a E1 grid and row, let's keep it in the same row and in column 1. Save, execute, and here we have an entry. So what's an entry? An entry is like an area where you can enter a value and then you can interact with that value in your script. So let's say you enter kilometers here and you'd want to have a button that converts those kilometers to miles. So the button would get the value of this area here and it would display it in another widget, which could be a text widget. So let's add a text widget. Let's say T1 equals text window, of course. And let's say T1 grid row 0 column 2. That's it. Execute. And we got a very big text widget because the default size, the default height and width is actually quite a big number. So we need to specify 2 parameters for the text widget. We would need to put the height, let's say 1 cell, and the width, let's say 20. And so this is the widget area. And this is the entry. And this is the button. And that's it for this lecture. In the next lecture, I'll show you how to put these widgets in live so that they can actually do something. See you in the next lecture. Hi again, and in the previous lecture, we built this graphical user interface with Tkinter, but the problem is this does nothing for now. So we press this, but it doesn't do anything. So what I'd like to do here, the final output I'd like to have is when I execute this button. So we have an entry here. We can input a value, and I want to execute this button and get miles here in the text area. So miles is like 1 kilometer unit is equals to 1 mile times 1.6. So if I execute this, I want something like 16 here to be generated. So a very simple program. Note that this is not one of the real programs that I've promised to build in this course. So this is just to get you up and running with Tkinter. So let's close this now. And to have a button do something, we need to add a command parameter here. So the command parameter takes a function here as argument, as a value. And then when you press that button, the execute button in this case, the function that you have here will be executed. So let's say we have a function here, def kilometers to miles. And let's say this function for now, it just prints out some text. Let's say success, for instance. Because it's good to, before you write your actual program, it's good to use print statements to try things out. So that allows you to isolate your problems. If something happens here, you know that you can't have a problem with a print statement, but if you had a more complicated expression here, it gets harder to know whether the problem happens in here, that you are not pointing to the correct function, or you have a problem with your statement. So it's good to use simple statements first, like the print statement. So you'd go here and kilometers to miles, that is the function. And one thing you should keep in mind is that you don't pass brackets here. So this is not a usual function call. You are just referencing to the function here and let Python take care of the rest. So the function name goes here, and let's try this out. Execute. And you see that we got success printed out in here. Press again, success, success, success. So it's working. However, we don't need to print out success in the command line. We want to print out a value in the text area. Now we need to look at the entry widget, because here is where we are going to get the value from. So the user enters a value in the entry widget, and then we grab that value, and then we use that value in our function. And for this, there is a parameter called text variable. And that would be equal to a string var object, which we have to declare further up here. So let's say E1 value, so that's a variable, and that would be equal to the string var function. And then we point to the E1 value, a variable, which we have just created. So this variable will get the value depending on what the user will input in the entry widget. Then we can use this value whatever we like. Let's say we want to print that out. A value. And we also need to add something extra here, which is a get method of the string var object. So this is a special object. It's not a string, a Python plain string. To get an actual string from out of this object, we need to apply the get method. So save this and try the script. Let's say 10 here, execute, and we get 10 printed out on the terminal. So we haven't yet connected this string here with a text widget. So let's do just that here. The idea here is that we need to insert a value to the text widget. And to do that, The text widget has a method called insert. So you need to refer to the text widget that you want. So T1 is our text object, and then apply the insert method. And the method gets an argument first, which is the place where you want to insert the text. Let's say we want to insert at the end of the text widget. For example, let's suppose you are inserting many lines of text in your widget, and you'd have to apply to execute this method multiple times. And each time, if you put end, you'd enter the new text at the bottom of the existing text. So you're saying put at the end this text. You want value.get. So the string of the value that the user will enter in the entry widget. So let's see how this goes. Execute the function and put some text here. You can also put anything. Hey there. Execute, and you get the string printed out in the text widget. Alright, but we don't want to just grab this value and insert it in the text. We want to first do something with this value, and then we insert the product, the output, in the text widget. So let's say we will grab the value.get, and we will multiply that by 1.6. And that would be miles. So miles equals to the value that the user inputs times 1.6. So you are asking the user to input kilometers, and 1 mile is equal to 1 kilometer times 1.6. Actually, is something like 1.606. I don't remember the exact value, but you get the idea. And lastly, you'd want to pass miles in here. So you would want to insert the miles output value in the widget. Save and execute. And I expect to get an error here. Let's say 10. Yes, we got an error. And so when you get errors, don't just try to copy this error and paste it on Google and try to see what other people are saying. You may waste a lot of time. Instead, invest some time and try to understand this error. So what this is saying, it says type error can't multiply a sequence by non-integer of type float. So a sequence can be a list, can be a string, a tuple, etc. And Python is trying to multiply a sequence with a non-integer, which is a float. So a float here is the 1.6 number, and Python is trying to multiply 1.6 with a sequence, with this here. So this is not a number, because the get method actually grabs a string out of a string var object. And a string cannot be multiplied with a float number. If this was 2, it was possible to multiply. For example, if you multiply me, the string me, times 2, you'd get me. So, but you cannot multiply me by 1.6 because it doesn't make any sense. Anyway, so the solution to this is you want to convert the value that the user inputs to a float. And you do that by adding the float function. So watch out for the brackets. You see there is an underline under the bracket, and you have an underline here. So this means this bracket closes in here. So everything looks fine. Save and execute again. 10 and execute. And we get the expected output. You can delete this print function, we don't need it anymore. And I believe that was a good start with the Tkinter library, and you should now be able to make more advanced interfaces. However, we'll be building a real advanced graphical user interface with Tkinter, which will interact with a database. So it will be a real world program. And for now, I'll just hand you an exercise in the next lecture so that you practice Tkinter a little bit. And you also get to know with some more cosmetic aspects. So you'll make the program that we built in this lecture, you'll make it more visually appealing, and you'll make sure you'll get your hands dirty with Tkinter a little bit. I'll talk to you later. Hi there, and I'm glad to introduce you to this new section of the course. And in this section, you're going to learn how to interact with databases via Python. And what that means is that you'll use specific Python libraries and you're going to operate a database from Python using Python. You're going to do operations such as inserting data into database tables. You'll be able to update data, delete, and query data all from the database. And then you are able to use those data in your Python program. Python is able to interact with many databases such as MySQL, PostgreSQL, Oracle, or SQLite, etc. In this section, you're going to learn how to interact with an SQLite database and a PostgreSQL database as well. SQLite and PostgreSQL are different in that SQLite is not a client-server database. Instead, it is embedded into the end program. So what does that mean? Well, let's look at this program. If you follow the previous section, you know that we're going to build this program in the next section. When you click a button here, you see some data, and these data are stored in a SQLite database. In contrast to other databases such as PostgreSQL, SQLite is based on a file. So all these data here are stored in a .db file, database file. So that means you can just give this program to someone else who don't have SQLite installed, and they can use this program. So they can add more data here, can update data and delete them and so on. But if you have this program in a PostgreSQL database, the user you give the program to, they would need to have PostgreSQL installed in their computer to be able to operate the data. So consider SQLite a small database, and you can call it portable, but it's very popular. And PostgreSQL would be more appropriate to use in a web application. So let's say you have some forms, you're getting some data from the user on your website, and you store your data on a PostgreSQL database on your server. And Python is a program that gets this data from your forms on the client, on the browser, and sends those data in your database. Now, to be able to interact with these databases, you need to have two libraries, and these libraries serve as interfaces to actually send SQL code to the database. And the library to interact with an SQLite database is called SQLite 3. And the library to work with a PostgreSQL database is psychopg2. So in this section now, in the next lecture, I'll show how to work with SQLite 3, and then we'll jump to psychopg2. So let's move on. Alright, in this lecture, you're going to learn how to use SQLite 3. So SQLite 3 is a Python library to interact with SQLite databases. So think of it as a Python wrapper of SQL code. So you can actually write SQL code inside Python using SQLite 3. You don't need to install SQLite 3 because SQLite 3 is a built-in Python library. So all you have to do is import SQLite 3. Let me test it. Script 1. Yeah, it's working. Now, a standard process of interacting with a database would consist of 5 steps. First is you connect to the database. Second is you create a cursor object. And the cursor object is like a pointer to actually access rows from a table of a database. Then the third step is you apply an SQL query. So you may want to insert data in the database or select data from the table and so on and so forth. And then the fourth step is you commit your changes to the database and then you close the connection. So let's go ahead and write an example with all these 5 steps that I just mentioned. So the first thing, you need to create a connection. And you want to store that connection object in a variable. So let's say con that would be equal to SQLite 3.connect. And what you pass here is the database file. So let's say light.db. And if you don't have a database file yet, your database will be created by this line of code, and a connection will be established. If you have a database, a connection will be established with your existing database. As simple as that. Then you have to create a cursor object. So cur, the variable, and you need to refer to your connection and then to the cursor method, which is a method of the connection object. So far so good. Then here comes the actual SQL code. You want to point to your cursor object and then use a execute method, and then inside brackets is where you enter your SQL code. And remember, your SQL code always goes inside quotes, so you pass the SQL code as a string to the execute method of the cursor object of the SQLite 3 library. So if you're familiar with SQL, this should be easy for you. If you're not familiar with SQL, SQL is quite simple, so you'll be able to learn it quite quickly. So at this point we have a database, but we don't have any tables in the database. Because you know, a database is made of tables, and tables have rows and columns. So first you want to create a table. And a good practice is to use capital letters for the SQL keywords. So create is an SQL keyword. And table is an SQL keyword as well. And then you want to specify the name that you want to give to the table. Let's say store. That's how you order Python via SQL to create a table, but then you need to specify what columns you want, what fields you want in your table. So let's suppose we are creating a table. We have a store, we have a shop, and we want to store our products in an SQLite database table. So we would want to have the item, so that would be the item name, and the item would be a text data type. So text is like strings in Python, and then you'd want to have quantity, and that would be an integer. So how many of this item you have in your store, and the price as well. And let's say real for the price, which should be a float in Python, so a decimal point number. And that's it. Here closes the quote of the SQL code, and here is the last bracket of the execute method. Then you need to commit these changes to the database. So you refer to the connection and then commit, and then you want to close the connection. So that's it. You save that and go and execute. QLite is not defined, of course, because I have made an error here, a typo. And again. And as you see, a database was created. Now, if you run the program again, you'll get an error because the table already exists in the database. So what you could do here is a simple trick. You need to add some code in your SQL line. You say create table if not exists. So save, and if you run your code again now, nothing will happen because what Python does is it goes and connects to the database, then it creates a cursor, and then if there is a table called store, it doesn't do anything and it goes to the next line. If there was no table, it would create a table. So it's good to have this simple conditional here inside the SQL code. How about adding some data to our empty table? Let's try that. Cur execute. So we are executing some SQL code again, and the keyword that inserts data to the database is insert. Then you want to specify where you want to insert the data. So insert into store, and what values you want to insert to your store table. So values. Then you open brackets, and inside the brackets you enter the values in the correct order. So in the order that you have defined your columns. So you'd have item, quantity, and price. And let's say wine glass. Now this is a string, so it should go inside the quotes. And you should use single quotes here because you are using double quotes for the outer expression. So if you use double quotes here, you will confuse Python and you'll get an error, so use single quotes. That's why we have different kinds of quotes to wrap around strings. So we have the string wine glass, and let's say we have a quantity of 8 and a price of 10.5. Save that and go ahead and execute. We didn't get an error, so that was successful. Now, what if we want to insert another row? Well, we could add that line in here under this, but then when we execute the code, we would get this line executed as well. So we would have a duplicate of this row. Therefore, what we could do in this case is we would use a function to wrap around our separate SQL statements. So you can indent this block of code. If you like, you can go to edit, lines, indent, or you could use a shortcut which can be specific in your keyboard. So just look here for your shortcut, keyboard shortcut, and then you can just use that. So the reason I'm indenting the block of code is that I want to create a function here. Let's say function create table. Don't forget the colon there. And then I want a separate function for inserting data. So that would be the SQL statement for the insert function. But you can see the difference between this function and this function. Here we are not creating a connection to the database, which is wrong. So you'd want to insert these lines in here so that you establish a connection with the database. And then you correctly close that connection. So you know how to use Python functions now. And naturally, the need comes to pass parameters to your function here. So you'd want to say item, so just some variables, and quantity, and price. And then you would want to somehow replace these parameters in here, so that every time you call the function, you insert some arguments, and then those values are inserted to your table. Now you can use string placeholders, Python string placeholders, to replace these values with the values that the user will pass when they call the function. But this is not a good practice because your code would be prone to SQL injections from hackers. And that applies when, of course, when your web application is on the web. But anyway, a good practice so is to put question marks in here. And then after the SQL statement, so after the double quote, you'd want to pass the variables that these question marks could be replaced with. So you'd want item, so in the correct order, quantity, and price. So let's try this out now. I would like to execute the insert function that I just created with some new items. So let's say water glass. We have 10 of them, and this would be less expensive. Save that and go and execute. I made a terrible error here. I wrapped with quotes all the arguments. So water glass should be in quotes, and these are numbers. So save again, try it again. And your data should be now in the database. So one more time, let's say coffee cup. Save, execute again. And now I'm sure you would want to see the data that you have been inserting in your database, in your table. So let's create a function that does just that. Let's say def view. And you'd want to establish a connection with the database. So let's copy that. Paste it here. And then here goes the SQL code. So cur execute. So we always use the execute method to send SQL code to the database. And then we have quotes. Let's say we want to select the data of all the columns of the store table. So select an asterisk, which means all, from store. All right. So we selected them, but how do we actually fetch this data so that we can use them in Python? Well, the way to fetch them is by using the fetch all method. And we want to select to store those rows in a variable. So let's say rows cur fetch all. And then we need to close the connection. So in contrast to the other methods where we were writing data to the table, here we are just selecting data, so we don't have to use the commit method. And we want to return the rows variable. And I would just like to print out the output of the function. So the output of the function is a rows variable. So I'll get the rows value printed out on the command line. Save the script, execute. Of course, I have a typo here and should be return. Try again. And here are our data. So we have wine glass, water glass, and we have 2 lines of coffee cups. That's because we executed the function earlier, the insert function, and then now that I executed the script again with a purpose to get the view function executed, the insert function was executed as well for the second time, so coffee cup was inserted 2 times in the table. Alright, that's for this lecture, and in the next lecture I'll show you some more operations you can do with the database. So, talk to you later. So, in the previous lecture I introduced you to the SQLite 3 library, and I showed you how to create a table in your SQLite database, and how to insert data in your database, and how to select data and view them in Python. So we have these 4 rows in our database table. And in this lecture, I'll quickly show you how to delete and update data from your table. So again, I'll create a function. So let me copy this. And we still need to connect to the database and create a cursor object. And then we need to use the execute method. And in this case, I would like to delete the row that has the wine glass. So inside execute, we would write delete from store where item equals. I would like to use a question mark placeholder here. So question mark, and in brackets, we would want the parameter that we would pass to our function. So this item here is the one we put inside here. Item, and let me change the name of our function. So this is this one. Don't confuse it with this. This is the column of our table, and this was the row from the previous function. Delete this as well. And you also want to commit the changes to your database. So commit. So that's it. And I'd like to comment this out, so I don't want to execute the insert function again. And I want the view function to be executed after we delete the row. So delete. So which item, the row of which item would you want to delete? So the item wine glass. And let's see what will happen. And we got an error, an SQLite 3 error, incorrect number of bindings applied. Line 28, I can see here. Yeah, there is something I often forget. You need to add a comma here. You'll see that when I teach you how to connect to a PostgreSQL database and how to query data from the PostgreSQL database. The code is quite similar, but it has some critical changes like this one here. So it can be confusing when you work with different kind of databases. Let's try this out again. And yeah, it seems to be working now. Wine glass is not here. So that's how you delete a row. Let's now add another function for updating data. Update. In this one, I would like to update the quantity of water glasses. So I would want to change this from 10 to 11. Again, you establish a connection to the database, create a cursor object, and then you execute. And here you enter the update SQL command. So update, what you want to update is the store table. And which column do you want to update from the store table? So you want to set the name of the column, which in this case would be quantity. And that would be equal to what? Guess what? Question mark. And then you say where Or let me show you how to update more than one column. So if you wanted more than one column, you'd use a comma and then say price equals another question mark. Alright, so we say update store and set quantity and price to this, but which row? So you need to specify a conditional here. So where item equals to wine glass. Or you can also set this to a question mark, so you have 3 placeholders here. And then you have the quote to close your SQL statement. And then inside brackets, you want to pass the parameters, quantity, and you have the second one is price and item. When you have more than one parameter here, you don't put a comma at the end, so this ends like this. And you also want to pass these parameters here so they reflect your function input. So what we have here is we are updating the store table and we set the value of the quantity column and the price column to these values, but only for those rows where the item will be equal to a given value. So we give that value to this one here and the first two to these ones. So you get the idea. Save the script and you need to call it here. So let me comment this out and update. So what quantity do you want to pass? 11, let's say. The price was 5, let's say it will go up to 6. And which item you want to update? Water glass. That's it. Save your script and try it out. And we got these values updated, as we expected. And that's what I wanted to teach you in this lecture. It could be more practical to actually have an ID here, so we say quantity and price where the ID is equal to a number, so we don't have to pass the entire name, which can be confusing or it's prone to errors. So in that case, we would want to change the table here. And we would want to add a primary key that auto increments. But you'll learn how to do that in the next section of the course. So there I'll show you how to make the real world program, and we will implement that in that program. So these were some trivial examples, and you'll get a much better idea in the next session. So next we will jump to PostgreSQL and we'll work with the psychopg2 library. Talk to you later. Welcome to this lecture. We are done with SQLite 3, so I hope you were able to build this script that I showed you throughout the previous lectures. Because in this lecture, we are going to use this script, but I'll modify it so that it is compatible with interacting with PostgreSQL databases. So luckily, most of the code is the same with some slight changes. Of course, we would need another library called psychopg2, and then we will grab methods from that library. And unlike SQLite 3, psychopg2 needs to be installed, so it's a third-party library. It doesn't come as a built-in Python library. So you need psychopg2 installed, and you also need PostgreSQL installed in your computer. So in this lecture, I would like to show you how to install PostgreSQL and psychopg2 as well. Alright, this is the official webpage of PostgreSQL, and you can just go to downloads, just here or down here. And then you want to find your operating system. So PostgreSQL works on Mac, Linux, and Windows, Solaris as well. So I'm on Windows, so I'll just click on Windows, and when you install PostgreSQL, you are also installing the pgadmin 3, which is a graphical tool where you can see your databases. If you're familiar with MySQL, pgadmin is equivalent to PHP MyAdmin. PostgreSQL also comes with a stack builder, which is a package that you can use to download and install other PostgreSQL extensions. So let's say you want an extension for spatial data, so to store spatial data in PostgreSQL so that you can use it for GIS applications. So there's an extension for that called PostGIS. So anyway, I'll show you how to install extensions. First, you need to download PostgreSQL, and I am on Windows. So I'll click this, and I'll wait a while until my download finishes. So I'll quickly go through the installation process. So I'm just being asked where I want to install PostgreSQL and where my data will be stored. And here you should be careful with these credentials. So your super user, the ones who have most of the privileges to your databases, and your super user name is Postgres. And I would actually like to create a simple file, a text file just to store my credentials. I would like to set the password as well. 1, 2, 3. All right. So I would enter Postgres 1, 2, 3 for password. Then next, and this is the port of your server, of your database server. So I would want to take a note of this too. This is about your local settings, so I'll just leave this default. And you'll just have to wait a while until the installation finishes. Alright, that was successful. Now, if you want to launch Stock Builder to install extensions for the PostgreSQL database, you may want to have this checked. So this is my database server. And here you have a bunch of extensions that you may want to install. For example, spatial extensions. And you have PostGIS for 32-bit and for PostGIS for 64-bit. If I click next, this tells me that hey, they need one package at least to be installed. So let me just install PostGIS. Alright, agree to the PostGIS license and then just go next. This is asking me about GDAL, which is another interface for GIS data. Alright, that was how to install external extensions. If you want to go back to Stack Builder later, your Stack Builder should be here. Or you can just go to PostgreSQL, and here you have pgadmin as well. And here is the application Stack Builder. Alright, but if you want to work with Python, you want to access the PostgreSQL databases through Python, so you don't have to interact with these applications here. The way to interact with PostgreSQL with Python is by installing psycopg2. And you can install psycopg2 with pip. However, you may run into problems because psycopg2 is written in C, so you need a C compiler installed in your system. On Windows, at least, you will not have this problem on a Mac and a Linux, I am quite sure. The solution to this, actually, there are a few solutions. One of the solutions is that you may want to install Visual Studio on your Windows machine, but that's quite a big program, and I wouldn't want to install that. So the second solution, which I prefer the most, is to use precompiled Python libraries. And you can find almost any Python libraries that require a C compiler, you can find those libraries in this page, served by Christoph Goldke. So we're looking for Cycle PG2. Here you have the wheel files. So a wheel file is a file that can be installed with pip. So what you do when you install something with pip install cyclepg2. Pip is downloading the wheel file from a remote server, and then it installs it in your system. So here you can look for your version. This would be the file for my system. So I'll just get this from here and paste it in here so that I can access it through the atom command line. So here is the file that I just downloaded. So just go ahead and pip install, and then you need to point to the will file. So dot will. Alright. And that was successfully installed. I can quickly check if that is available. And it seems to be working. You can also check the version of your library if you want. So it's 2.6.1. Alright, so in the next lecture, we will connect to the database, to the PostgreSQL database, and then we'll be creating tables and inserting data, viewing, deleting, and updating them. So let's move on. Very good. In this lecture, you learn how to connect to a PostgreSQL database and how to create tables in a PostgreSQL database, insert data, view data, and delete and update rows as well. The script you're looking at now, though, is a script that you built in the previous lectures using a SQLite database. So if you haven't watched those lectures, I highly recommend you to go through them first, then you come here, because in this lecture I'll just go through this code and replace only a few lines of them. And that suggests that the code that you use for the SQLite 3 library is very similar to the code we will use for cyclepg2, which is a library you use to connect to PostgreSQL databases. The main difference is that your database will not be a DB file stored in your file system. It will be a database embedded in your PostgreSQL installation. And so the first requirement is that you need to have an existing database in your PostgreSQL database server. And PostgreSQL comes with a default database. So once you install PostgreSQL, you'll have a database called Postgres. So you can just pass the database here. Or if you like, you can create your own database. So you just need to go to your PostgreSQL installation. And you can create a database through pgadmin. So here are your database servers. And this is a default one. You need to connect to your database server first. And then this would be the password that you created when you installed Postgres. Postgres 123 was mine. Alright, so I was successfully connected and I have 3 databases. So this is the default database that I was talking about. And these are 2 other databases I have created. So to create a new database, just right click on the databases and then new database. Let's say database 1. And you need to specify the owner, so the user of your database. Postgres, so this is what I specified when I installed PostgreSQL, and this should be enough. Alright, so now you have a database here. If you click to that, you will connect to it. Now you can just close this and go back to Python. Okay, let me first comment these lines out so that when I execute the script, I don't get this function instances called. So we have an empty database. So the first thing we would like to do is to create a table. But first of all, I would like to change this to cyclepg2. And of course, I would like to make a batch replacement of SQLite 3, replace it with cyclepg2. So I want all these library names here to be replaced with cyclepg2. So replace all and just press escape, and that goes away. Luckily, this code is the same as SQLite 3 library. So we have connect, and then we have the cursor object, then we have the execute method, commit, and close. All we have to do is change the parameters here. And here we would want to pass the database name, the username, the host, the password, and the port number of your database server. And all that comes inside quotes. So it is passed as a string to the connect method. First we have the database name, so the parameter db name, and that will be equal to a value. So you need to insert the value inside single quotes. So that is database1, the name of the database. Then you have user, and be aware that you don't need to use commas in here. So all this goes as a string, and it is read as a string by the connect method. So user goes inside quotes, Postgres, then we have password, Postgres 1 to 3, yeah. Then you have the host name, so the host parameter, and that should be localhost. Alright. So localhost should be your host name, and it's always like that. And last we have the port number, and that goes inside quotes as well, so 532. So those are the parameters you pass to your connect method of the cyclepg2 library. Then let's try to call that function. So create table is the function, and I'll save the script. So let me make sure you know what is happening here. So we connect to the database, and then we have the same methods for the cyclepg2 library. So we are creating a table, name store, and then we have 3 columns for that table. And we commit those changes, and then we close the connection. So save the script, Ctrl S, and then call the script. And that looks successful. If you like, you can just go to pg admin, and here you can see the table that you have just created. So just enter the password, and you need to go to your database. So database1, expand that. Then you need to go to schemas, public tables, and this is our table name. So we have the store table, and you got 3 columns: item, quantity, and price. Alright, we have an empty table, so let's go ahead and insert some data to that table. I'll just copy this connection string and paste it in here. Then remember that we use question marks when inserting values for SQLite 3. If you want, you could use string formatting placeholders. So one for the item, the one for quantity, and another one for the price. And then after the comma, let me delete this. After the quote, sorry, you would pass the percentage, so you already know string formatting, and then you'd specify the tuple of the variables you want to insert here. So item, quantity, and price. So you can use this, but this would be prone to SQL injections from attackers, so it's not a good idea. I can go ahead and execute this actually just to see what happens. So let's say Apple and 10 and 15 for the price. Let me execute this. So it looks like it worked, and we can check it in the table here. So you can just go to your database, which is database1, and here you can execute a simple SQL query. Select all from store, go to run, and you see that Apple was added to the table. So it works, but it's risky to use Python string formatting. So what you want to do is, I'll leave it for a while there so that you compare things out. And to avoid SQL injections, you should actually pass your variables as a second parameter to the execute method. So what does that mean is you don't have to use quotes, so you just pass %s, just like that. And then you put a comma here, so that means this string here inside double quotes is one argument, and then this one here is the other argument. And then you pass your variables. So that should work now. So I'm sure you can see the difference between this and this. And I'll just comment this out so that it isn't executed. And let's say orange. Same price and quantity, execute. And let's go and check in pgmadmin. So let me execute the query again. And you see that orange was added as a new row to the table. So this is the way to go, and I'll delete this. Alright, now let's look at the view function. So what the view function is doing is it connects to the database and it selects all the rows from the store table. And then we store those rows in the row variable using the fetchAll method. And then we return those rows as a function output. Everything you need to change here is an argument of the connect method. So just put them here and you should be good to go. So let me view, call the function, and execute. And yeah, we need to print it. Forgot it. Yeah. So we got apple and we got 3 oranges now because when I executed the script here, I got the insert function executed again. So we got 2 oranges and another one when you use the string formatting placeholders. So you get the idea. Let's look at the delete function. Again, we need to pass arguments of psychopg2 connection. Then we have delete from store, where item, again, we can't use a question mark, so we need to use %s. And then as a second argument, we pass the item variable. So it's the same as SQLite 3, but we use %s here. And let me call delete. I'll comment this out and delete here. So what you want to delete is the item. What item? Let's say we want to delete rows where the item is equal to orange. So let's see how this goes. And yeah, the item was deleted. The rows with the item orange were deleted, and we got the view function executed, so we got 1 row now. Our table has only 1 row. A quick look at the update method now. Just like that. And here we are updating the store table. And there we are setting, so we are updating the quantity to this value. And the price as well to this value, where the item is equal to this value. Alright, so we got 1, 2, 3 values, and we pass 3 variables here after the comma. So as a second argument of the execute method, and the update method gets 3 arguments. So let me comment this out. And update, we have only 1 row, so I'd like to set the quantity of apples to, let's say 20, and the price, let's keep the price the same. And for the item apple, just like that, and execute. And we got the quantity changed to 20. So that was it. I believe that was quite simple, so if you learned SQLite 3 before, this was quite simple for you. And if you have any questions, just feel free to drop them in the discussion section. I'll be happy to answer. See you in the next lecture.